Yeah. Anusha, am I audible? Can you see me?
Yes, Krishna, you are audible.
Okay, okay. You can see me well, right?
Yep.
Okay, thank you. Yeah, it's fine.
Hello. Good morning to all of you.
Good morning, sir.
Good morning to all of you. Am I audible to all of you? Is it okay?
I can hear you, sir.
Okay, fine. So,
Yes, sir.
Om Namah Shivaya to all of you. Can we start our today's proceedings?
Yes, sir.
Okay. So our first is the poster session, and first presenter is Chaitanya Kapoor. Chaitanya Kapoor is there with us.
Namaskar, sir.
Namah Shivaya.
Sir, Chaitanya Kapoor and I, we are in the same team. I am the presenter for today. My name is
Okay, so
Pankaj
Pankaj Wali. Okay, both of you are together. Okay, fine. So can you please start your presentation of the poster?
Sir.
Yes, sir.
Yeah. You want to raise some question? Who is asking? Who is asking? Balmukund.
Yes, sir. Sir, we can just have an introduction and then we can start.
Yeah, Chaitanya and our Pankaj. They are from Amrita Vishwa Vidyapeetham, our own students. And it's not mentioned which course are you doing. Which course are you doing?
So, computer science engineering, BTech computer science engineering,
Okay.
AI.
That's fine. So computer science engineering, and you are most welcome to make your presentation now. Thank you. Because time is limited, so let us immediately start your presentation.
Yes, sir. Sir, I'm having some trouble.
Just share your screen and upload it.
Yes, sir, I'm actually trying to, but I'm not able to.
Okay, what could be the problem? What could be the issue? Balmukund, can you help?
Okay. So, sir, by the time we can call the next person and we'll get her poster and present.
No, or they can send the poster to one of us and
Yeah.
then they can share it instead.
Yeah.
Yeah, you can mail it to our team there. Pankaj, are you there? Please mail
Yes,
your
sir.
poster to
Yes.
our team. Right. Meanwhile, can we start with Dr. Vaira? Dr. Vaira is there?
Yes, sir.
Yeah, please,
Here.
you can start your presentation. Dr. Vaira is also
Sure, sir.
assistant professor, Department of Mechanical Engineering. So please start your presentation, sir.
So hope the presentation is visible for you right now, sir.
Yeah,
I
it's
start?
okay. Okay.
So greetings of the day. Myself, Dr. R. Vaira, serving as assistant professor in the Department of Mechanical Engineering, Amrita Vishwavidyapeetham Coimbatore campus. Our research work is on composite paver block technology for recycling waste polymer and fly ash, which is a method for developing a technology for recycling polymer waste and fly ash. The challenging environmental norms force the technologies to focus on the development of methods to effectively reduce and reuse waste materials. The major fraction of waste materials includes plastic materials and fly ash. Low density polyethylene, which is commonly called as LDPE, is one of the most utilized one-time usage polymer-based materials. This is extensively used in carry bags, food containers, and water bottles. Mostly, they are discarded after their intended usage. Globally, 270 million tons of plastic materials are produced in a year. Among this, only 55% of them are discarded, and only 20% of this plastic waste are recycled. And in India, the estimated total generation of solid waste is approximately 150,000 megatons per day. That is as per Ministry of Housing and Urban Affairs, Government of India. The Central Pollution Control Board, Government of India, shows that around 4,059 tons of plastic waste are generated in major cities of India per day. And extrapolating this value, it is estimated that around 25,000 tons of plastic waste are generated per day in India. In addition to these plastic waste, coal-powered thermal power plants generate second most quantity of waste in India. So that includes fly ash, which is the leftover particles obtained by the combustion of crushed and atomized coal. Conventionally, these fly ash are dumped near the power plant sites. They do not possess a technological or a commercial value. The presence of heavy metal oxides in the fly ash poses a great threat to the environment and especially groundwater contamination based issues. Currently, 112 million megatons of fly ash is produced annually in India. So devising an effective waste management strategy or developing technology for recycling waste is the need of the hour. Earlier research pointed out that fly ash can be used as an additive in the cement industry or building industry for brick making, glass, lightweight materials, ceramic tableware, artware, mullite, composite materials, etc. However, most of the research work are just lab scale experiments. Besides, most of the earlier research was not commercialized because of complex pre-processing routes that they require surface modification with respect to coating of fly ash particles or to activate the surface of fly ash particles. And added to that, they have non-economical fabrication procedures that generally includes high temperature processing techniques. And third is high production cost that is involved. So in our research, we have simplified the production process for compositing fly ash and polymers. So in this case, the composite paver block is made by heat and curing the homogeneously blended polymer waste and fly ash in a specific proportion. The sequence of steps in fabricating the composite paver is as follows. So fly ash is obtained right away from thermal power plants. The dirt and other foreign metallic particles in the fly ash should be removed through segregation process. The segregated fly ash is sealed to obtain fly ash particles with particle size ranging from 10 microns to 30 microns. Next, the food packing containers, carry bags, water bottles are shredded into small pieces of size ranging from 1 mm to 4 mm using mechanical shredder. The shredded particles are pulverized to particles of size 40 microns to 60 microns using a pulverizer. The shredded and pulverized LDPE is known as waste polymer. That's what we have used in our study. Next, the fly ash and waste polymer are blended homogeneously using a ball milling unit. The blending operation was performed for a period of 20 minutes. Then the blended mixture is subjected to cold compaction at a pressure of around 150 megapascal to 200 megapascal in a hydraulic setup to make the green compact pellet. Then the compact pellet is heated and cured at the temperature between 170 and 190 degrees Celsius for time period of 5 minutes to 20 minutes in air. On furnace cooling, the final product composite paver block is obtained. So the invented composite paver block has a density of 1.17 gram per cc to 1.28 gram per cc, and the micro harness was around 46 HRP.
Please sum up. Your time is up. Please sum up.
Yes. So the wear rate is approximately 8.11 gram per Newton, 10 per minus 5 gram per Newton meter. And the water absorption is less than 1% concerning the mass. So the properties adhere to the recommendations of Bureau of Indian Standards for the paver blocks. So the same has been applied for patent, and patent application has been published and the status is under examination. Thank you, sir.
Yeah, thank you. Thank you very much, Dr. Vaira. I have a very quick small feedback for you. One is, why do you prefer to mix fly ash and polymers? What are the, you don't need to answer. Just please consider it, okay? And other
Sure.
is, have you worked out the cost benefit ratio? I mean, how much cost is actually input, how much energy is used, and what is the output and what is the value of output? Have you worked out this cost benefit ratio? Right?
Yes, sir, we have worked out that too. So the previous cases, they are using temperatures of as high as 500 to 600 degrees Celsius for producing the composite paver blocks. But in this case, the temperature is around 170 to 190 degrees Celsius only. So added to that, the time is also around 5 to 20 minutes, so which could be accomplished using some continuous cooling, continuous heating furnaces too.
Okay, and
So,
finally, who is the actual user, ultimate, who's the person, who's the industry which is using this mixed product?
sir, actually, this is a paver block which could be utilized for most of the construction-based sites.
Okay,
So-
are they accepting it? Is there acceptability for this kind of product?
Yes,
Anyway,
sir.
just
Actually,
You just please
Yeah.
consider, because these are the applied aspects which you need to highlight. I know you may be having good answers for all this, but in order to do the marketing, you have to emphasize on these very parameters, isn't it? So,
sure, sir.
yeah, these are the applied aspects. Thank you very much. It was a great presentation. Thank you.
Yeah.
Is there any other question from amongst our other delegates?
Yeah, this is Gopal.
Okay.
Yeah, I was also wondering about the same thing in terms of, since we are saying it's a paver block,
Okay.
how does it compare with other paver blocks today in the market, and in both in terms of hardness and you have shown the numbers, but how does it compare with other paver blocks, and therefore how does it cost benefit with respect to the comparison? I think that is very important, as Dr. Sudish mentioned.
Okay. So, quick answer. Can you please provide quick answer? Otherwise, you please you can communicate separately, right, Dr.
Yes, sir.
Vaira? Okay. Thank you very much. It was a great presentation.
Yeah,
Now,
thank you.
our next presenter is Vishal Manon. Mr. Vishal Manon, are you there?
Yes, sir.
Please start your presentation. Vishal Manon is also our student. He's Amrita Vishwa Vidyapeetham. Which campus are you from? Please, can you just mention?
Amrita.
Okay. So please start your presentation.
Namaste.
No, Shivaya.
My presentation visible?
Not yet. It is, I think, taking. Yeah, it's becoming. Just put in the presentation mode.
Yeah. What about not? Is it visible in the presentation mode?
Yeah, that's right. Please go ahead.
Yeah.
Balmukund, please
Greeting
keep
to
the
the-
timings. Balmukund, please keep the timings.
Yes, sir. Yes, sir.
Greeting to the respected dignitaries and my fellow researcher. I am Vishal Manon from the Department of Computer Science and Engineering, Artificial Intelligence, Amrita Vishwa Vidyapeetham, Amrita campus. And today I'll be presenting my proposal for the poster submission on the topic of IoT-enabled multi-hazard warning system for disaster-prone areas. So, natural disasters in India have become a big challenge in the recent year, and this year the rates have been escalating the social as well as the economic progress of our country. India's topographic, climatic, and socioeconomic features make it vulnerable to the devastating effects of such disaster. So, hello, sir. Can you hear me?
Yeah, please go ahead. We are listening to you. Please go ahead.
Okay. Hence, it is the need of the hour to come up with a system capable of long-term as well as quick prediction of disaster. This can be useful for early preparedness and developing a well-planned mitigation/relief system for such devastating effects of disaster. So we will explain an IoT-based system that is capable of prediction as well as detection of disaster. So this is the basic system architecture of our proposed model. So we'll look into the data collection model.
Your slide is not moving.
different.
Hello, Mr. Manon, your slide. Yeah, now it is moving. Okay.
So the data collection module consists of point of use module, echo modules, and push module. The point of use modules consists of is an aggregation of sensors, Arduino board, and Bluetooth. So the sensor might change depending upon the disaster to be predicted. It can be earthquake detection, landslide detection, weather prediction, etc. So the information from these disaster-prone areas is taken from the POU module, and this information has to be uploaded to the servers, local servers. So these POU modules may not be in the range of Wi-Fi regions. Therefore, we will use echo module, which is an aggregation of Arduino boards and Bluetooth, which will act as a hub for the POU modules to push modules, which will upload the information, to the servers. So the push module will consist of Arduino board, Bluetooth, and Wi-Fi module within it. So once the information is collected from the data collection module, it next moves to the local server, which pre-processes the data, and then it moves to the central server, which will upload the data to the central system. The central system consists of quick prediction algorithm that is used for quick response, and will send email and SMS when there is an onset of disaster to the people in the locality. And it will also upload the data to the cloud platform, which will which will aggregate the data and can be used for prediction using various ML and CNN algorithms. So we have also proposed a robust user app that can be used. Hello, sir. Sorry, sir.
Summarize in a minute.
Yeah, sure. So we also have proposed a robust user app which can be used for analyzing the disaster in their respective locality. So initially, once the logger signs in, the GPS location of the user is taken. The user gets multiple option of navigating throughout the timeline, home, and map options. In timeline, the recent disasters in his locality is shown. Then in the home, there are various modules for separate disaster, and the map is used for marking the various regions or localities nearby us which are prone to multiple disasters. So within the disaster module, as we have shown here a flood module as an example, we are able to navigate through prediction windows, visualization and map windows. In prediction windows, the prediction of the possibility of a disaster in the coming days is shown. Then visualization is used for visualizing the sensor data that are taken from the POU modules. And in the mapping module, what happens is various regions in the map are marked as red, green zone depending upon the intensity of the affected regions. So with that, I have reached the end of the presentation. Thank you for your time. And now we are open for questions.
Thank you, Mr. Manon. Please, are there any questions from delegates?
Any questions can be answered in the chat also.
Yeah.
Hello, Vishal.
Yeah, please raise your question.
Okay. Yeah, thank you for the presentation. But could you please elaborate a little bit upon like how you have developed this visualization module, that mapping module, etc. Like, I mean, what is the software and front end and back end?
Yeah, currently the development of this module is actually a work on progress, because due to the pandemic, we weren't able to do the real-time analysis of the data. So it's still on hold actually. So we are working on it. So it's just a project, like it's just a proposal or idea of a basic architecture.
And
we haven't completed the real-time implementation.
Okay, thank you. One more question. So this one in your communication module, you have told that your the communication module that you are using as Bluetooth, right?
Sorry, I didn't hear you. Can you just repeat your question?
In the communication module, in the architecture, your communication, the communication module that you are using is Bluetooth, right? Mode of communication is Bluetooth, right? Are you using Bluetooth module for the communication system? Hello, can you hear me?
Mr. Vishal, she's asking,
sorry,
how do you communicate? Are you using Bluetooth technology? How do you communicate? That is the question she's raising.
Yeah. Okay, so basically, as I said earlier, means within the data collection module is divided into POU modules, then push modules and echo module. So POU modules and the echo module use Bluetooth for the communication. And once the data reaches the push module, then it is uploaded to the local server using the Wi-Fi modules. I hope that answers the question.
Okay, thank you. Thank you, Vishal.
Yeah,
any other question? Gopal sir, please.
Yeah. No, sure. Vishal, this is a standard architecture, right? This is a standard architecture that people use. So what is your innovation, or what have you done in the architecture that differentiates your solution?
So basically, like we have also, proposed an idea of creating a robust app for the user that can be used for like analyzing the disaster in each locality. Then the information, so we are thinking about, using the information from all the local servers, so that, we can divide the analysis for each locality also, like
So
that.
the user's smartphone is a part of your network?
Yes, sir.
You didn't indicate that. Did you indicate that in your poster?
Yes, sir. I have explained the poster.
Okay. I think I missed that. Okay, so the user's smartphone is also a part of the thing, and so the user's smartphone will use you'll use cellular technology, or it will continue to use Bluetooth to get to your system.
Sir, as the information is uploaded to the cloud also, so it can use the cellular data for retrieving the information from cloud.
Okay. Yeah. Thanks.
Thank you, Gopal sir. Thank you, Vishal Manaji. It was a great presentation. Keep it up. Really good.
Thank you, sir.
Thank you.
Thanks.
So our next presenter is Mr. Anish Rajendran. Anish, are you there?
Yes, sir. I'm here.
Yeah.
Can you hear me, sir?
Yeah,
Yes,
please.
sir. Can you hear me?
Anish is also our own MTech student. I don't know which campus are you studying?
No, sir. I am from College of Engineering, Trivandrum.
Okay, College of Engineering. Very good. You are welcome. Yeah,
Yes,
you are
sir.
welcome. You please make your presentation.
Yes, sir. Shall I share the screen? Yes. Sir, I hope the screen is visible.
Yeah, it is. It is visible. Please go ahead.
Okay.
Try to summarize in 5 minutes.
Yes. So myself, Anish Rajendran, I'm currently doing PG in MTech in Power Systems Engineering, which is coming under Department of Electrical Engineering at College of Engineering, Trivandrum. So we did this work as part of my thesis work, which is jointly with Energy Management Center, Kerala. This topic is all about optimal placement of electric vehicle charging stations. So we know that our government, both the central government and the state government, is giving a great push to electric vehicle and e-mobility promotion, which is great support to sustainable ecosystem. We know that the pollution caused by transportation, which accounts for almost 70% of the global pollution, which we can offset to a great extent, relying to green energy sources from solar and wind, and this can be used for electric vehicles. So we have launched the national e-mobility program and FAME 2 scheme in 2019, and it is projected about 10 lakhs e-scooters, 5 lakhs of e-autos, and 50,000 e-cars by the end of 2020. So the governments have started working on that. So this further development of this e-mobility, we need a very keen charging infrastructure, which will supply just like the fuel stations we are having the spread of Kerala state. We need to expand more charging outlets to fuel these electric vehicles. So along with this, we have found a problem, which is basically an optimization problem. So coming to the problem formation, we have identified the Kerala state highway stretch from Thiruvananthapuram to Kasaragod. So you can see the map. So here we have identified the strategic locations where EV charging stations can be placed. So here the prominent candidates, these are called nodes. So the candidate nodes are fuel stations, which one dispenser can be changed to fuel station, EV charging station. Then the restaurants where parking time is available for consumers while traveling. Since in EV, the main problem which the consumers are facing is the range. The extension of range to a further extent without sizing the battery is not a bigger constraint. So we have to place the EV charging stations suitably to extend the range of the vehicles. So we have shopping malls, supermarkets. Then the KSEB substation also we have taken because as per the state government plan, some of the KSEB substations also identified to because the KCB is the largest electrical utility in Kerala, who is also the nodal agency to implement the charging infrastructure in Kerala. So some of their substations are also taken care into consideration. Then we have identified the availability of the number of nodes available. So the most we have identified that 73% of the fuel stations are available along the highway, and the second largest contribution is from the restaurants. So based on the wait time and number of slot availability, such constraints, we prioritize these nodes, and we have identified district-wise nodes and identified that we have a total number of nodes maximum in Alappuzha, and the second highest is in Malappuram and Thiruvananthapuram. So a total number of 217 candidates are identified. Now coming to the statistics, we have prepared the statistics like that, and we found that the fuel stations are the most prominent share in the number. So we have formulated the problem by minimizing the capital cost and minimizing the operating cost. And also this is a combined transportation plus power system problem. So we have minimized the power loss in the grid, and we have minimized the wait time. So we have identified the constraints like the charging demand points and the energy cost limits, the active and reactive power limits of the grid. So some equality constraints, like this is the most important equality constraint, the load generation balance has to be met by placing these charging stations on required buses of the power system. So we can see this is the we have superimposed. This is the Kerala map. The red line is showing from Tirunelveli to Kasaragod, which you see in this line where the candidates are placed. So this map is merged with the superimposed with the electrical power system network. So we have selected a standard 33 bus IEEE system for this study. So we have superimposed this, and we have used the genetic algorithm based optimization technique to optimize the problem further. And we have used the forward reverse load flow analysis. Since this is a radial network, we have used this forward reverse algorithm, and we have used this MATLAB program, which is inbuilt genetic algorithm is available, and we optimize the results, and the best particle best and the mutation was done. And we have identified the one study with minimizing the number. We are still in the work is not completed. We are doing this
Sir, time is getting exceeded. Can you conclude?
Yes, 1 minute more. Yeah. So we have optimized the numbers, the number of fast charging stations and slow charging stations, and which node number these are placed. So these are placed like that, and the capital cost and operation cost also optimized. So these are the node-wise operating cost and capital cost, and the total cost was arrived, which is the optimized cost for the utilities. Then coming to the conclusion, the major share of the cost is the capital cost, because nowadays the cost of the charging station is on a higher end. It is tend to reduce. Now the second is the energy cost, which is the capital, which is the the operating cost. Then as a conclusion, we need a optimal placement of the EV charging stations to the utility grid as well as the transportation network, which will reduce the power demands and which will reduce the losses in the system. So this will add to a sustainable development of the community. So thank you.
Yeah, thank you, Mr. Anish. It was a very good presentation. One or two very small questions are coming in my mind. One is how much time it requires to charge, and if it's taking more time, then parking of the vehicle will be a major issue. Can we have a device wherein the battery is just replaced with the charged battery? This charged battery is immediately replaced by a charged battery. Some system has to be worked out on that, so that we reduce on this time of charging plus dead parking. So that I think that level of efficiency needs to be brought in. I'm sorry, I'm not an expert on this, but this is just offbeat. I'm just raising this question. Are there some other questions, please?
Yes, sir. Actually, what you are told is correct. We have not considered the battery swapping in this. So we are further developing this, and also we are planning to implement the use of machine learning and artificial intelligence. So that's why I attended this seminar. We have a workshop on that also. So if time permits, we will incorporate that also.
Okay, fine. Thank you. Are there some other questions? Some
Yeah,
quick
no,
questions?
yeah.
Answer?
This is an excellent presentation, very good presentation, very good analysis also. My only question is what traffic density and what percentage of electric vehicles did you consider in your analysis?
Actually, we have taken the data from our motor vehicles department, which is available in the Parivahan portal. Almost 20% of this total vehicles, which is projected in 2020, this requirement is projected, but it is not met. So we have taken almost 25%, 20 to 25%, I think, yeah, 25% of this total number. And we have taken the 217 numbers of candidate nodes, which where we can place. These are only the candidates. Not necessary that we have to place everywhere. There are some critical nodes where placement has to be done. So that critical nodes plus some other nodes will be coming. So we are expecting around 150 numbers because the state government is planning to put 150 numbers of charging stations. So we are concentrating on that, sir.
Okay. Okay. Thank you.
Okay. Thank you. Thank you, Mr. Rajendran. Thank you very much. It was a very good, very comprehensive presentation. Thank you.
Sir,
So
Pankajawali's presentation is there.
Yeah, please, Pankaj, can you now upload your presentation?
So someone else will be sharing the screen on my behalf.
Okay,
Thank you,
please.
sir. I have stopped sharing.
Yeah, please start it.
Yes, sir. Sir, are connected smart cities. So connected smart cities are an upcoming innovation and that can revolutionize the way we exist. So what is actually a smart city? So a smart city is an urban region that collects data using various electrical systems and sensors. So insights gathered from this data are utilized to efficiently manage assets, resources, and services. And in turn, the data is utilized to enhance city operations. So this data includes information gathered by citizens, devices, buildings, assets, and all, which is later processed and analyzed in order to monitor and manage traffic, transportation, power plants, utilities, and so on and so forth. So the question arises, why are smart cities important? Like, what is the need for it? So according to the recent survey, 54% of the world's population lives in cities, and it is expected to rise to 66% by 2050. So with this expected population growth, there comes a need to manage environmental, social, and economical sustainability of resources. So smart cities allows citizens and local government authorities to work together to launch initiatives and use smart technologies to manage assets and resources in the growing urban environment. So how does a smart city work? The basic workflow of a smart city is first collection, that is smart sensors gather real-time data, that is collection of the data. And the second step is analyzing. So this data is analyzed to gain insights in the operation of city services and other operations. And third step is communication. The result of data analysis are communicated to the decision makers. And the fourth one is action. So action is taken to improve operations, manage assets, and improve the quality of the city life for the residents. So in our work, we have proposed a connected smart city structure. It is a topology comprising different sections based on a hexagonal city layout. So hexagonal shape is used, hexagonal layout is used so as to avoid overlapping and to cover more region without leaving any gaps. Yes, sir. So this is our.
Okay. Are you concluding with your recommendations?
Yes, sir.
Okay.
Sir, we can move ahead.
Yeah. Should we raise some questions?
Sir, actually, we are running short of time. So maybe in Q&A section, some people can post question and she can answer from there also.
Okay, I think it was a very nicely drafted poster. The poster is depicting a lot of good value additions that you have tried to bring in. So I'm sorry, there's no time. Time will not permit us to go into more details. There are some very good presentations from our 2 o'clock keynote addresses. Dr. Vasudevan will be presenting on Varanasi, Smart City. I'm sure you will be attending that. Okay. So I think with this, we are concluding our poster presentations. It was all a very comprehensive, very thoughtfully selected topics and very good presentations. I'm really very happy. Our young, bright scholars are doing great. So congratulations to all of you. Thank you very much. Now we'll move on to our PhD colloquium. PhD scholars, and our first presenter is Miss Anjana Eka. Are you there?
Yes.
Yeah, please, can you start? She is a PhD scholar from the University of Delft University of Technology, the Netherlands. So you are welcome, Ms. Eka. Please start your presentation.
Thank you so much. Hello, everyone. My name is Anjana Eka. I'm a PhD scholar of Delft University of Technology, and my PhD work is all about understanding the impact of anthropogenic modifications on river flow regime, and then trying to understand how the impact of human modifications on river landscape can impact the ecosystem services provided by the river. So the outline of my presentation would be, so here basically I'm taking into account the impact of reservoir on river flow regime. So I'm using a landscape-based hydrological model, which is known as FlexTopo, to model my river flow regime. And then my presentation will include like how I'm including reservoirs in that hydrological model, and then how I'm calibrating it, and then my results would conclude how the reservoirs that has impacted the flow regime based on the indicators of hydrological alterations, and then conclusion. So when we see the river landscape, then from a biophysical point of view, of course, when we talk about a river landscape, then it's comprises of both the biophysical constants and also the social constants. But from a biophysical point of view, the river landscapes, they are the result of co-evolution of climate, topography, vegetation, and geology. And many researchers, they have said that if we use at least topography and vegetation, then we can understand the landscape very well. So that's what we are using the information of topography and vegetation in our hydrological modeling to understand that how they can predict the flow regime. And so my study area is Kaveri River Basin, and if you can see, these are the number of dams. There are like 96 dams located in that basin, and I have chosen 4 basins in the upper Kaveri region for my study. These are like Harangi, Hemavati, Krishna, Sagar, and Kabini. So what I'm going to see is that what is the problem with Kaveri River Basin? So we have data available from 1979 to till date, but we don't have data for the previous year where the dams were not built. And we don't know how to predict that, like, okay, if there is no data available, then how we are going to predict what is the natural and pristine condition. That's why we are using this FlexTopo model to see, like, okay, what is the river flow regime when we remove the dam, and how the river will flow. So that is ultimately that I'm going to do with my landscape-based hydrological model. So this is my methodology. So my method consists of 3 parts. The first one is the FlexTopo modeling, where I'm going to really set the model with the help of topography and vegetation. The second one is the reservoir modeling, where I'm modeling the reservoir, and the third one is integration, calibration, and then predicting the model with and without reservoir and comparing it with the indicators of hydrological alteration. So this is how my landscape preparation and the model looks like. So these are my 4 sub-basin, and I divided my sub-basin into 3 parts. The first one is like, I call it like F1. So here what happens, this is the catchment. This is the catchment area, and the water from F1 comes towards the reservoir, and then the reservoir model like starts working, and then there is an outflow. The outflow water from this outflow and this whole region, the water, it comes here, and then here we have the gauging station to measure the water flow which is coming from the reservoir and this surrounding particular area. So this is how we have divided our flex topo model into 3 sections. This one is the reservoir model, the F1 and F2 is the flex topo model. And then for the landscape preparation, this is how the landscape looks like. So I have taken like distal elevation model, slope, and then height about the nearest drainage. These are the things that I prepared in ArcGIS, and this is how the model looks like. This is the landscape, that how it looks like. This green one represents the hill slope, this red one is the plateau, and this blue one is the wetlands. So these landscape, they acts as a different hydrological response unit. So this is the representation of my model, and I divided my model into like 4 structures. So and this is based on the land use pattern of that particular landscape. And then next, yeah. And then if when I'm talking about the reservoir, then definitely there is going to be a water demand. So I calculated the water demand based on the crop water requirement and using the crop coefficient. And this is how I try to model the reservoir based on the mass balance, and these are the parameters. So in Kaveri River Basin, the reservoir that I have chosen, there are 2 kinds of reservoir. The 3 Harangi, Hemavati, and KRS reservoir, which is known as the Krishna Rajasagara reservoir, they are used for irrigation. And the Kabini reservoir, that is used for hydropower. So we have different parameters to model the reservoir, because for Kabini reservoir, for hydropower generation, we cannot remove all the waters from the dam. We have to maintain a certain level so that hydropower can be generated. But that thing is not required for the reservoir which is used for irrigation. So so we have taken this parameters into account when we were modeling the reservoir. So this is the reservoir modeling, which is based on the different zones of the reservoir which is being used.
Ms. Anjana, please sum up in next 3 minutes.
Yeah. And this is the shortest rule curve of the reservoir. And then we used the NSGA, which is non-dominating sorting genetic algorithm, to calibrate our model. I have used 2, negative Nash cliff efficiency and mean absolute error. And both performed well. And this is the impact. This is my results. So as I said, I divided my model. I ran the model with reservoir, which is the base case, and then we removed the reservoir, and then we ran it without reservoir. And then I compared that with the indicators of hydrological alterations. And this is the results with and without reservoir. So here what you can see is that, of course, with no reservoir case, the water has increased both in Kudige and Amachali subbasin, but in Tinarsipur subbasin, which is in where the Kabini reservoir is located, which is for hydropower. In monsoon season, the water it hovers the reservoir case. That means in reservoir with hydropowers, water is already there, and if we add more water, then it is going to it going to outnumbers the flow which is already present with the reservoir. And in Koligal, since it is used for irrigation from the month of September to December, the water just a minute, yeah. So the water is more in case of reservoir condition compared to no reservoir condition. This is the again some more indicators, and the very striking thing is that the number of 0 days in Kabini River Basin is it's around like 36, which is not good for the aquatic and fish species, especially living in the rivers. And yeah, of course, means overall, I can say that yes, definitely the impact of reservoirs is seen in many cases. And what I can conclude is that, yeah, so from a broader aspect, my model, I have tried to incorporate both the biophysical constant and anthropogenic modification simultaneously. So it is possible to, combine these both. And then also including the indicators of hydrological alterations also gives an understanding like how this natural flow regime can impact. Means we can know the degree of impact, and not only that, okay, this is impacting, but also we can know the degree of impact. Yes, in summer days, the negative impact is more, and also the size of the reservoir and the type of reservoir. If the size is really big, then you can have means the impact might be big, and also means what is the purpose of the reservoir, whether it's used for irrigation or hydropower, that also impact the river flow regime. Yeah. Thanks.
Thank you, Ms. Ika. It was a very good presentation. There are a few questions which have been bothering my mind, because flow regime is a very complex process.
Yes.
And you need to consider the overall discharge conditions, the size of the sub-basin, what basis you are delineating a particular sub-basin or catchment area, and what are the issues related to riparian rights, or the small versus large dams. This has been a major topic of discussion amongst the scholars, whether we should construct small dams with smaller submergence area or large dams with larger submergence area and with the hydrological power generation and all that. So these are some of the questions, and you please need to ponder on these. You don't have to answer right now because we are running short of time. Are there some other feedback?
Sir, I have a question. This is Dr. Geeta here.
Dr.
Good
Geeta,
morning.
please.
Good morning, Dr. Vadanan, sir. And good morning, everyone.
Good morning.
My question is, you were talking about the different type of reservoirs and the maps you showed. And in that you were talking about the DEM model also. But none of the maps showed about
I didn't talk about the DEM model, but this is about the flex topo model that I'm using. And yes, this map shows, okay, I'll show you this map that I prepared the landscape.
No,
so
the previous, this one.
Yeah, so this one. So this is the landscape. So this is how I delineated this area based on the gate station located here, so that I shouldn't miss any part, like, okay, which is not going, in that gate station.
This was understandable, but my question was, you were talking about the DEM model also while talking about this.
So DEM, I didn't talk about, when I said DEM, so I used this digital elevation model, model, yes, DEM, which gives information about the elevation. So I used this information to make this landscape. BEM, hand, and slope. I use these three information.
Attribute data which you collected for doing this particular map?
So I as I said, I used DEM, digital elevation model, I used slope, and I used hand. Hand is known as height about the nearest drainage. So these three information I took, and then for each sub basin, I clipped it in the ArcGIS, and then I exported that in MATLAB, and we have one formula like, okay, if the DEM is equals to, like, if the hand is equals to 5 meter and the slope is equal to like 0.1%, then that should be considered as wetland. So I gave this formula in MATLAB code, and then that's how I generated this map.
Thank you, Anjana. It was a good presentation. Thank you.
Thank you so much.
Good. Thank you very much. It was a very confident and very mature presentation. But please ponder on some of the feedbacks which we are offering. Right?
Sure.
The area of submergence, and particularly the riparian rights, whether water is being utilized to the optimum extent or not, or it's being wasted like that. The actual carrying capacity of a river has to be, I think, considered very important.
Yeah,
that is the applied aspect, right? Thank you very much once again.
Namaskar, sir. One poster presentation is left. One student, Kiran Khanna.
No, that is, I think, scheduled for tomorrow.
No, sir. The Chaitanya and Kiran Khanna was there, so Chaitanya was not able to present. So she is available.
So now I think our next presenter is also ready. We'll do it at the end of the session now.
Okay.
Ask her to be ready there. I'll request Mr. Morova, Douglas. Mr. Douglas, are you there? Mr. Douglas?
Yes, I'm available.
Oh yeah, please. He is our own E4Life PhD scholar. So welcome back to Amrita University. Please start your presentation. Thank you very much, Mr. Douglas.
Okay.
Please upload your presentation.
Okay, let me just upload my presentation. Sorry. Where do I find the file? Sorry, I'm getting challenges in terms of getting the file here.
Yeah, okay. If you are taking time, then we can ask for our next candidate, Miss Sindhu. If you are taking time, then you please.
Yeah, I'm just trying to locate the file. Let me just maybe someone can present whilst I find my way in terms of connecting. Thank you.
Our team. Okay, we'll come back to you after our next candidate is completing this presentation. So can I request Miss Sindhu?
Sir, I can present actually.
Yeah, please go ahead. Miss Sindhu is from Tokyo Institute of Technology, Japan. She is a PhD scholar, and she'll be talking on community-based portable breakwaters for mangrove restoration. It's a very interesting topic. Welcome, Sindhu madam. Please start your presentation. Really great. Very good topic.
Thank you very much for the opportunity to present in your conference, sir. Okay, is it visible?
Yeah, it is visible. You please move to the presentation mode.
Okay, fine. Thank you.
Yeah, good. Go ahead,
Good
please.
morning, everybody. Today I'm going to talk about the community-based portable breakwaters for mangrove restoration projects. I'm Sindhu Sriranga from Tokyo Institute of Technology, Japan. Presentation is as follows. Initially, I'll be discussing about the background introduction. Then we had done some field visits. Later, the results of field survey and design of these breakwaters. Then some of the to understand the effectiveness of this breakwater, we have done some numerical modeling. Later, the results and discussions and conclusions. Coming to background, mangroves offers coastal protection against tsunami, high waves, and storm surges. This is a well-known fact. But the global coverage declined by 45% in past 2 decades. It's from 13700 to 8100 square kilometer. It has been declined. Expansion of land for agriculture, aquaculture, shrimp farming, industrialization, timber, and charcoal production are major reasons for the loss of mangroves all over the world. Large-scale replantation was carried out and is also being carried in many South and Southeast Asian countries. The investment is very huge, up to 1 to 10 million US dollars. However, the success rate is not observed to be very effective. It is only 1% to 60% success rate has been observed in various countries. So mangrove rehabilitation often fails in so many ways, especially during the initial stage of plantation due to physical factors such as high waves, less sediment supply, biological factors such as algae bloom, insects, and also by hermit crabs. Waves usually uproots the young seedlings, which are loosely deposited on the sediments. And countermeasures such as rock barriers, sandbars, and placement of wooden piles have been implemented to protect this. However, the efficiency of these methods has not been proven satisfactorily. The goal of this work is to investigate, integrate ecological and engineering principles for the effective restoration process. In this study, I have designed a small rubble mound, which was with a low cost achievement, and it can be depicted as a small breakwater to protect mangrove plantation and thereby promote the growth of mangroves, young mangroves. When the mangroves grow sufficiently, these breakwaters can be easily lifted up and placed in the required region, maybe in the nearby replantation region. The entire presentation is divided into 3 parts. The first one is field studies in Amami Oshima Island, Japan. And second one is design of this breakwater. And third one is numerical simulation using open foam and Ola flow. So we visited Amami Island. This is a southernmost island of Japan near Okinawa. And here in the tidal inlet of near the Sumio Bay, we have our investigation site. The site has little expanded mangrove forests. So we found Candelina obavata, the species which is predominantly present in this site. And we did many tests in this site. One among them is we generated waves manually on these small plants, and we tested how these plants adopt themselves for the high waves, or what are the problems it is facing. So in results of field survey, we did some plantation. We collected mangrove seeds in the location. You can see 7 mangrove seeds. We just planted nearby one reference point, which is a little older mangrove. And we visited the site back after 7 months, and most of the seedlings were survived. Actually, this area is, even though the world is facing the loss of mangroves and degradation, this is one place where it is continuously expanding. So we wanted to study this area. So later we conducted some manual wave generation test on 1 month, 3 month, and 6 months old, 1 month, half-year-old, and 1-year-old mangrove plants. See, when we applied this manual wave generation test, half-year and 1-year-old mangrove plants were stable and sustained the wave attack. But when you see figure 4C, there's a very small mangrove plant, around 1 month old plant with a very small root and very thin subroots. It got bent and almost submerged. So the if the typhoon comes or the high waves approaches such plants, so the survival of these plants is not as good as the matured plants. So that's why we are trying to protect such plants until it's a sufficient growth by using this portable breakwater. So I designed this breakwater, a small breakwater. So maybe I designed almost 4 cases using Hudson stability formula. I calculated the stability factor, and also some geometrical designs based on the Arons low crested breakwater equations. So these are all the few important equations which I studied. Later, by this initial part of the design, I made sure that these 4 geometrical cases are stable enough with the very small stone weight of 15 kg. Stones can be used to construct these breakwaters. Then the same modules are studied in the effectiveness of this breakwaters was studied in open foam. So I conducted numerous simulations in the supercomputer deployed at Tokyo Tech called Subame 3.0 so which has wave generation and active wave absorption working boundary conditions, which is a two-phase flow through porous media, that is VARANS equations is involved in this. So the mesh size and the time steps, wave type is regular and conoidal wave is used. Turbulence model is used. Porosity for stone is usually taken as 40%. The same thing is applied here. And weight of the stones comes from their basic design, and DN50, which is usually called as nominal diameter of the stones, is around 0.14 meter. So for these are all the initial conditions, and we applied the wave period.
Ms. Sindhu, please sum up in 3 minutes.
Okay, sir. So we applied the wave period, load and water depth, and the what we have conducted. I mean, what we have gained the information from field survey, we have applied the same thing in this numerical model, and these are the results and discussions. So here we studied the wave height reduction versus wave steepness. So we observed that the greatest wave height reduction of around 68 to 82% is observed for short wave periods of 2 seconds, 3 seconds, and 4 seconds. The reduction rate is slightly smaller, but wave height is still reduced by 50 to 78% with this small breakwaters. And the results we have compared with the wave transmission of these breakwaters with the previous studies. So of the previous breakwaters such as submerged breakwater or emerged breakwater or reef type breakwaters from previous researchers. And we find that our results match very well, though the design is very different from the previous design, but the transmission coefficient which matches very well with the results of previous researchers. So our breakwater, the specialty of this breakwater is it behaves as submerged in the high tide condition, emerged in the low tide condition, and medium water depth in the mid tide condition. So it can accommodate itself to various tidal conditions. In this study, the conclusion is, in this study, a simple rubble mount breakwater is used to protect young mangroves from fluctuating waves. For this purpose, field survey was conducted at Premier Mangrove Forest of Amami Oshima. It was confirmed that mangroves of about 1 month old were bent and submerged against 10 centimeter waves. In contrast, mangroves older than half year and 1 year were undamaged. The cross-section of the rubble mound was designed by applying the existing formulas considering the local tidal and wave conditions. Numerical analysis was performed on 4 different shaped mounds to investigate the wave transmission. Although there is a significant difference in the wave transmission due to the difference in shape, the wave dissipation efficiency was found to be high, which is more than 50%. The results of the present numerical analysis were compared with the experimental results of 4 previous studies, and the wave transmission coefficients showed a similar trend of change with respect to the relative water depth at the crest. Although the present structure has a very small cross-sectional shape compared to the conventional breakwater, there is a clear consistency between them in terms of wave transmission ratio. A portable rubble mount breakwater can be expected to sufficiently reduce the wave energies before reaching the mangrove plants. So these are our few recent publications and few references.
Thank you
very much.
Thank you very much, Ms. Sindhu. I'll just make very quick observations. This is a feedback. Please ponder on this. Number 1,
yes.
Are you considering different species of mangroves? Maybe there are some species which are more sturdy than the ones you are experimenting with. This is one. Number 2, what is the rate of siltation? How is the sedimentation going on around there? Are there any considerations for that? And number 3, if you are breaking these natural systems with your artificial rocks and such rubble, then the general observation while studying the coastal erosion aspects is that it can change the dynamics, the flow dynamics. It may be encouraging sedimentation at one place, but it may enhance erosion at others. So it's a very dynamic process. Please ponder on these aspects.
Yes,
Whether
yes.
the waves and the storm surges effects are
Yes.
also getting altered because of your artificial intervention, human
Yes.
interventions,
Yes,
right?
yes.
So
And
this is for your.
can I answer your last point, sir, please?
Yeah, just quickly, please.
Yes, just quickly. Actually, your observations are absolutely right, but we are introducing this in a degradation site. So where the erosion is also taking place, and usually mangroves grow under the protection of parent plant. Here in such sites, they don't have parent plants. So we are trying to start replanting the process, the entire process.
Yeah, but then the selection could be to have a more sturdy and fast growing mangroves. I don't
Yes.
know the details.
Yeah,
but
this is
maybe-
a very, I think, especially this species is very fast growing. It's
Okay.
like the protection is required to only for initial 3 to 4 months. And these structures are so small that even though I understand there will be some destabilizations in sediment, maybe it would be positive to, hold, to make the strong sediment near the mangrove site. It is one positive aspect. But of course, we have to study the sediment dynamics when we instantaneously remove the
sure.
structure.
Please study the sediment dynamics and also the configuration of these water bodies, these inlets and such. This geomorphic configuration also has got the influence on that. So, are there some other quick feedback points? Some questions from the delegates, please?
Sindhu, I have a question here.
Yes.
Have you seen the importance of this mangrove grown in the particular place to see the tsunami effect before and after?
Sorry, it's quite a disturbance. Can you please repeat the question?
My question is, you were talking about the mangrove, is it not? So have you studied any tsunami effect after and before?
Yes. Actually, there are many studies on that, but I think we have mentioned that in our literature, in our publication, and we also studied. But our research is slightly deviated, not studying how mangroves protect against tsunami, because it is a matured mangrove. So our studies is on young mangroves. How can we protect it during the initial plantation? Many studies are available. And
have you compared the growth of mangrove in your place as well as the other western part of the country?
In my place means, sorry?
Wherever you have done your research.
Okay.
With the other places of the world.
Growth of mangrove forest in
Yeah.
Amami Island and other parts of the other mangrove forest.
Yeah.
Actually, there are 180 species of mangrove, and every country has it's very different mangrove forests and mangrove dynamics. So it's kind of a comparing two different fruits. But of course, we are studying the protection part, not exactly the ecological part, but we are studying more of an engineering part.
Okay,
I
thank
hope
you.
I answered your question.
It will be good if you can include that.
Okay.
Thank you.
Thank you very much.
Thank you. It was a good presentation.
Thank you.
Thank you, Dr. Geeta, and thank you very much, Ms. Sindhu. It's a great work and very practical applications wherein the community is also involved in these efforts. Really great. Please keep it up. It's great. So we thank you once again. So now
Douglas
Douglas
presentation is there.
Please, Mr. Douglas, please go ahead with your presentation. He's our own research scholar. He's associated with Sustainable Development Program with Amrita University. So, Mr. Douglas, please. Mr. Douglas, are you there? Yeah, please go ahead.
Yes, thank you. My name is Douglas Marwa, like you have said, one of the PhD in Sustainable Development scholar with the Marita School of Sustainable Development. I'm going to talk about the climate shocks and women's livelihood in Zimbabwe. It's a case study of Chimanimani district, which was recently hit by Cyclone Idai. And I'm going to look at the climate shocks in Zimbabwe, as they are now very worrisome in terms of sustenance of women livelihood. And these disasters have thus threatened the existence of mankind on the planet. Obvious, as we all understand, the impact of climate change has displaced a lot of people, and diseases, outbreaks. Obviously, there's also some destruction in terms of infrastructure and facilities, including houses. So you'd find women are vulnerable to climate shocks. The background where I'm coming from, you'd find the IPCC mentioned the issue of underprivileged communities. This includes the women, the grossly, or they experience the major impact in terms of climate change. Even other authors also mentioned that Sub-Sahara of Africa, it's recording crop failure and livestock failure. I would not dwell much on that because I want to dig much into what was the problem. I was looking at disaster management, its complicity, and it has exposed communities to disasters rather than managing the impact or mitigating the impact. And hence, women are the most vulnerable groups. So the research questions here, you'd find attempts have been done before to try and develop disaster management strategic plans, the whole world. However, the question that remains is whether these climate shocks on women are being addressed. And I also looked at the adaptation strategies. Are they reducing the climate shocks on women livelihood? And the climate policies gender sensitive? And the real answer here is no. Climate shocks in Zimbabwe have been of worry to the sustenance of women livelihood. You'd look at these pictures, ladies are in trouble. So the objective of the study was to try and assess the climate shocks that were encountered during the Cyclone Idai in Zimbabwe and relate it with the livelihood of the woman. And this was just done the rationale was to try and recommend future gender sensitive adaptation and mitigation measures in the study area. So as I was conducting the research, I used the gender approach in climate change analysis. You'd find women and men faces different social and economic or environmental realities. There's dissimilarities. Women are involved in the day-to-day taking care of the family. They look for food, they run around, they make sure things happen. So if you look at the men, they've got their own roles. So I did this study in Chimanimani district and used the positivist and the interpretivist. This was a qualitative research where reality was given from the community using the instruments that were independent from the researcher. I assembled 50 participants and 10 participants. I used the interview and group focus. The results, what happened? It was clearly revealed that women were heavily affected by the shocks during the Cyclone Idai. You'd find buildings were destroyed, and these are their houses. We also noted that there were no specific undertakings which were targeting the women in trying to address their climate shocks. Rather, the entire population was said to discriminate gender imperatives and even the developmental practitioners, those guys who were coming on board as non-governmental organizations to try and support, they were using the term blanket intervention, where they were saying, let's just try to help everyone. And the women were not given enough room or to try and to be sensitive as they were giving their interventions. It was also clear that the major adaptation strategies that were used were early recovery, conservation agriculture, water harvesting, climate resilience, and in terms of crops and their varieties. However, women lack rights and access to the resources and information that was vital to overcome the challenges. It was also very clear that there was need to have climate smart technology. And these women were saying it will empower them against climate shocks. Then the other aspect which came on board was the issue of population. You would find women insisted that the climate smart technology would be more effective and sustainable if they are given preference, because they constitute the bulk of the population. They are also on the forefront of the economic activities, like I've mentioned before. It was also noted that there was policy gap among the climate policy, governance, and the research, such that the government must consider to invest in breeding drought-resistant crop varieties. And to be honest with you, the most vulnerable and the highest population in that area demographically is the woman, and they were not given room to be involved in the humanitarian work. And you'd find this whole batch of food in the picture is rotten food in a warehouse in Chimanimani. In conclusion, the research, through the researcher, concluded that there is huge policy gap on gender mainstreaming and climate adaptation and mitigation programs. The women are excluded in the disaster management strategic planning process, leading to poor outcome during the implementation. In real sense, if the majority of the population in Chimanimani is women, if they are not involved in the planning, in the whole process, the monitoring, the implementation, the monitoring, the evaluation, then it means the whole, like I've said from the start, the problem have been disaster management complexity, which means it's exposing the community to disaster risks rather than mitigating the impacts. So in short, this is what came out from the research. I thank you. And I also want to thank Amarita for giving me this chance. E4Life International Fellowship Program under Amarita University, and the Live in Lab for providing me all the support. I thank you.
Thank you. Thank you, Mr. Douglas. Now the topic is open for discussions. It's a very important and really relevant topic, this gender sensitivity. Mr. Douglas has made a very good presentation of the field observations. Are there any feedback or any questions?
Yeah, I have a couple of observations which I would like Douglas to consider. It was a great presentation, Douglas. It's a very important problem. My question is, one, did you consider single women or women who are household heads in the study separately, or it was just generally women? That is my first question. The second question is, what about the social norms and gender discriminatory aspects of society itself or the government because whatever interventions we do, if those policies are not fixed, right? If men always own property, if men always control resources, then interventions will not generally have the impact that they should have. So I wanted your thoughts on how it is in Zimbabwe, whether gender discriminatory or gender bias policies, as well as the social norms, how do they impact this whole problem?
Okay, thank you. For the first question, this was a convenience sampling, whereby I focused on the woman and then zeroed down to convenience. And as I was picking or identifying using the non-probability sampling, I also happened to interview single women. I also happened to interview widows. I also happened to interview women-headed family. So they were involved. That's what I can say in terms of the characteristics. The full report review or indicate the age group and marital status. It's captured in there. This was just a snapshot. Then in terms of social, it was very clear that there was a lot of discrimination and to an extent of getting to the abuse level. You'd find women who give in to certain pressure from the men, especially on the distribution of the food. There was an issue of unfair distribution of food, whereby favoritism, corruption, bribe, and all those things come into play. Then the other aspect was traditionally men were given, first priority, leading all the processes, and then women will always listen and try to follow behind. That's why it came out clearly that they were not given enough resources, neither information. The full report also reviewed that there was an element of even divorce, marriage breakage. There was a lot of breakages. People were separating because ladies would then try to find their way out to try and find goods and food for the family. Then they were being accused of being involved in other immoral issues, and then they were divorced. The issue of witchcraft came into board as well. I thank you.
Okay. Yeah, thank you very much, Mr. Douglas. Are there some other points? We have another 2 minutes to ponder on this particular topic. This is a very interesting topic.
Mr. Marova, I have a question here. You were talking about in the conclusion that the women are excluded in disaster management strategies and planning. Maybe they are used for planning, but during disaster, is it okay for a woman to work in it? Because we see that men are more stronger to work during the disaster management time than the women. Are you saying that they are biased for implementation?
Yes, it doesn't start with the implementation. The process itself starts with the planning for the strategic or the strategy that they want to use, or the plan. So it's a stakeholder approach that is very important at this level, whereby they involve all the stakeholders, meaning to say in the stakeholder composition, ladies or the women are supposed to be invited. We start from that level, whereby they are also in the forum or in the room as they discuss the plan of a disaster management plan. Then from there, you take your management plan to implementation stage. During the implementation stage, there are a lot of committees that are identified. For example, there will be a welfare committee. There will be a team of those who be on the forefront recovering in terms of any disaster that may happen, the Civil Protection Committee. There are very few women in those committees. In other committees, there is no one in terms of a lady. It's just a group of men who are saying we are a committee for this particular task. So they are not involved in the implementation. When it comes to the monitoring, again, it's another stage whereby non-governmental organizations or stakeholders, the district committee come together, try to review progress. Again, women are not involved. Majority are out, just a few who are at that level. When it comes to evaluation, once again, they are also not involved. So it means it's a plan without the women who are the majority in terms of population. I think basically that's what came out during the study.
Okay, thank you.
Thank you, Marwa. It was a good presentation.
Yeah.
Thank you.
Yeah, Mr. Douglas, I think the literacy rate and how healthy are the women there, these are also important parameters which also go into actual planning and formulating a policy. Now, what are the remedial measures? Those you need to please highlight actually. Those you have identified the problems and the various gaps and various aspects of corruption also. But what is the way out? What are the actual remedial measures and from where to begin? And how strong are the women? What is their literacy rate? Are they really leading in their democratic setup? And is the socio-economic conditions are they are continuing like this, and you want to bring in some change, some political, social aspects need to be changed. So those are the issues you will, I think, please consider and develop some tenable answers to that. So thank you very much, because time will not permit us to go into more details. If there are more comments, please, we can put it in the chat or in the queue box, and he can just think on it. So we'll, I think, thank you once again, Mr. Douglas. It is a great work. Please continue doing good work. Our best wishes. We'll move on to our next speaker today. That is Mr. Prince Destiny. He is also our own student, E4 Life PhD scholar. So, Mr. Prince, are you there?
Hello.
Yeah, please.
Can you hear me?
Yeah, Prince Destiny, please, can you upload your presentation and start doing it?
All right, just a minute. I would share my screen now.
Okay. Meanwhile, Balmukund, one candidate is left for poster session.
Yes,
After
sir,
this, I think we can take up that particular one.
Yes,
because
sir.
I didn't have the details for that candidate. So you will introduce that candidate and we can have that poster after this presentation. Okay.
Sure, sir.
So, Namaskar, sir. I'm Kiran Khanna from BTech second year Computer Science with AI department.
Yeah, after this
Sir,
you have to come. After this.
Please wait for another 20 minutes. So we are waiting for you to be presenting your case. Mr. Destiny, are you having any difficulties? Hello, Malmukunji, can we extend some help to him?
Prince, are you there? Yeah, he's sharing, sir. He's sharing.
Okay, good.
Can you see my screen?
Yeah, we can see your screen. Please go ahead. Please put it on the presentation mode.
Is it there now?
Yeah, please do it for the full screen one. Just switch it to full screen.
Is it not? Can you not see the full screen?
No, it is not. You please just switch it on the full screen. On the bottom right hand side corner, there is a switch. Yeah, that's
it came. It came.
That's it now. Please go ahead.
My video is not on. I'm struggling to put on my video.
No problem. You can present.
Sorry, let me see now if it is working. I'm not sure.
Yes, it's working. Video. Now we can see you. You can present now.
Oh, great.
Please stick to the time, okay? Take 10 minutes.
Thank you very much for allowing me and for your patience. Like has been introduced, my name is Prince Destiny Ugo. I'm a for life PhD international fellow. I just prepared this presentation as part of my research at Amerita University. And I wanted to really understand what is the water issues that India has. And this was premised on the work that I did in South Africa, that was in 2015, because there is a similarity between water crisis in South Africa and that of India. So there is a kind of linkage between the severity of water situation. So I was very much interested to now explore more about water demand management in India as part of my studies in Amerita University. So because whatever thing I do here now will be implemented in the rural villages where Amerita is deeply invested in assisting the rural villagers. Without taking much of your time, that was why I wanted to give this background so that we understand the context even before we go to the local villages. What actually is happening in the country? I'm not sure the next slide is not moving. Let's see now. Okay, so I'll give a bit of introduction. I will talk about water demand. I will look at the challenges and the methodologies that we tend to employ. If you look at the left-hand side of your screen, for those who are already in India, you can be very happy that this is your map. The essence of this map is just to provide a kind of context, because the map you are seeing here is a map of India, and India is home to 18% of the global population, but it only has 4% of the global water resources. This is according to the World Bank anyway. But the fact remains that India villagers mostly rely on rivers, wells, and other water bodies for survival. And they walk several kilometers to access water. However, getting the water is also becoming unpredictable due to the impact of climate change. Now, but while significant amount of water requirement is achieved through groundwater, a long-term analysis of water research is both pre-monsoon and post-monsoon seasons indicates decline of water table due to inadequate research. You can understand that yesterday there was a professor that was working with NASA. There was a very fantastic presentation he made. He looked at the impact of climate change in places like California and all those places. There was a table which fascinated me. He was looking at how water would not even be very difficult, even though it gets to the groundwater level. The recharge of the water to the aquifer is very slow. So you see now, even in the monsoon that India has at the moment, people would think that there is water, that water is just available everywhere. But research has shown that this water takes time, or sometimes it's even lost before it gets to the aquifer. So now this big picture you see here just captures the whole story, and this is a courtesy of the World Bank report. You can see that from the year 2000, water demand in billion cubic meter have increased. You can even look at the 2050 projection. This projection is according to the Central Water Commission of India. So you can see that even from the year 2000, demand for water is continuing to increase. So water demand for various sectors has also been assessed by the National Commission on Integrated Water Resource Development. If you look at this table, you will be able to see that irrigation remains the largest sector demanding water demanding sector in India. If you see, like in 2010, we have about 557 billion cubic meter that irrigation alone is consuming, and this number continues to increase. If you look at the domestic use, see that it's only about 43 billion cubic meter. But in 2050, this number would outweigh the irrigation. But the research have shown that this is also attributed to population growth. But my major concern here is that in the irrigation sector, what kind of activity do people do in this using irrigation systems that take so much water? So is there a way that we could be able to analyze and lay hand on particular irrigation system to be able to reduce water intake? I think this is an area that is of interest, so that this water intake at this sector will be minimized. But I'm not sure if anything has been done to that extent, because even all the previous presenters have shown there is lack of data. Everybody that have presented will now tell you there's lack of data to be able to implement some of these things. So our interest now should be how to be able to generate this kind of data for policy making. So the challenges to address, the water demand planning and management in rural communities is a challenge that we seek to address. So what I have just presented was like a foreground to look at overarching impact of water crisis in a country like India. Review of literature highlights the fact that natural systems, physical infrastructure, lifestyle, behavior, and aspiration of the populace should be viewed in an interactive manner. Taking care of looking at the human settlements and the cities. Because people behavior related to resources use is influenced by their level of awareness. So somebody can just wake up and begin to use water unsustainably. Maybe the person is not aware that this is a precious resource. So there needs to be kind of engagement so that people will be able to reduce or minimize their water intake. And adequate access to an adequate supply, equitable access and adequate supply, and responsible consumption of these resources are central to achieving key policy goals such as poverty alleviation, health, sustainable cities, low carbon growth, and vulnerability reduction, and improvement in the quality of life. So according to the Bureau of Indian standards, so they set out parameters how water is going to be utilized. Like for example, they say there's 200 as per the minimum domestic consumption in cities and flush toilet. What about the rural communities? So because we are going to the rural communities, these data, even the one for the planning commission, did not even take account of what is happening at that micro level. So that becomes a problem, because if you want to make a planning, you don't need to plan for the city and the urban areas. What about the rural areas? So data in these rural areas are not available according to the information that is available from literature. Looking at the planning commission, even the Bureau of Indian standards. All the measurements and parameters they brought was on the framework, beautiful framework. We are for the cities and those kind of places, but the rural communities have been excluded in this kind of reports. I don't know whether they are not part of the demand planning and all that. So, because we are going to the rural community as part of the Amerita, so we should be able to assist in a very little way, to be able to generate such data. If we go to a community in a rural village in, for example, I'll give you an example now, like Odisha, or I'm not pronouncing it correctly, or Gujarat, we should be able to say in this community or in this local village, this is the amount of water they consume. So that can also have a spillover effect in terms of policy and planning of that very big street or locality. So if you take further, for example, this is also from the Central Water Commission. This is 2019 to 2020 annual reports. You find out that this report was published last year. But you see the annual rainfall of almost 20 years, 1985 to the year 2015. They only have 1,105 millimeters of rainfall within this span. And if you look at the annual rainfall of 2018, just 1 year, we see that it is below the amount of rain that fell for almost 20 years. What does this tell us? This tells us that the impact of climate change is real. It is very real. Something needs to be done on how we use these water resources because there is less rainfall. That is what this is really telling us. And if you look at, like I was talking about the guy from NASA who was analyzing how water was really, it's very difficult to really get to groundwater level. Now, if you look at the water availability as at 2013, the net groundwater availability, according to the Central Water Commission, you find out that it is 432 billion cubic meters, 411 cubic meters. But ultimately, irrigation alone has the potential to take about 139, almost 140 million hectares. No, this is like description is like million hectares, talking about the capacity of the reservoir. So that is what that unit to be, the capacity of the reservoir. And you see the surface water is 76 alone. The groundwater is less. So that justifies why, even if the monsoon, the rainfall, groundwater intake or the absorption, the groundwater remains very, very low.
Prince, can you try to conclude?
Yes, I'm almost done. Thank you. So methodology, what we try to do is to have a major shift because research has shown that there needs to be a shift from engineering-dominated approach to an adaptive learning approach, which refers to a systematic process of holistic management of water resources. This is water demand is influenced by several intersecting cultural, climatic, demographics, and all that. That is why the study will leverage methods and techniques used in qualitative and quantitative. That is, we are using MIST method now. We're going to use questionnaires and interview, for example, on interlayer, socioeconomic and demographic attributes of the respondent. Where do they actually get the water? How do they use water? So those are the kind of things we seek to do when we get to the local villages. And in conclusion, this now we know that water demand assessment is a barrier to sustainable water resources management in India. So the study will also support decision-making for Amerita self-reliant villages. Amerita is heavily invested in implementation of water distribution systems. So if we go to a local community, we should be able to know how do they use water before the implementation of this water distribution system. And we even want to also know their water consumption change. For example, if a small family uses like 10 liters of water or 20 liters of water every day, and there was no water distribution system, do they take up to 50 liters a day after the water distribution system has been installed? So those are the kind of things we will engage and see how we can be able to bring out better of water demand management, to actually help local community will better manage their scarce water resources through an effective and efficient water demand management. We're sourced to put this together. In case anyone will want to refer to them. And I would like to acknowledge, I'm very grateful to Amma for the gracious funding of my for Life International PhD folio. My guide, Dr. Gita Trikans, really appreciate you, Prof. Thank you very much. And I will leave you with the word of Amma. Amma said that in order for service to be beneficial, it needs to go hand in hand with discernment. This is the essence of sustainable development. Thank you very much. And open for any question or suggestions to improve this study.
Thank you. Thank you, Mr. Prince Destiny. You're really a prince. You made a very good presentation. Are there any observations or feedback, comments, please?
Yeah, this is Gopal. I have a couple of observations.
Sir.
Very good presentation, Prince. Appreciate it. The observation I have is you rightly pointed out that we have to move from an engineering intensive kind of approaches to more management approaches. But you're talking about demand side management. We should also look at supply side policies. I'll give you a couple of quick examples. The government gives free electricity to farmers to pump water out of the ground. So free water, free energy. So that's what's happening. They're just pumping it out, right? So community ownership of water is something that should be pondered upon in your study. What is the dynamics of community owned water? It's not individual owned water. Person should not own water. Community should own water. And then appropriate government advocacy to the government to do proper supply side management. That's something that you should ponder about. Thank you.
Thank you. I've taken note of that because this is very important. This is an ongoing research, so this kind of suggestion will really help us to build. In fact, there was even an aspect because of the time limit now and the constraint we have. There was this issue of people who do wells. There are racketeers that there are conflicts. People monopolize a particular well and even extort the local villagers. So I didn't want to go into that, but those are the kind of things we look at because we are looking at the advocacy and the involvement of the government and the supply side. So those are the kind of things we will look at. We are just researchers. We are not politicians. So we will have to do our best to give to the policymakers, but if they don't do anything, but they need to know what is happening there on the ground. So thank you.
Yeah, good. Thank you. Thank you very much, Dr. Gopal. Very relevant points raised. Demand and supply, they are the major concerns for the government of India also. And Mr. Prince, you have done a lot of exhaustive literature survey. I'm really very happy with that. But I think you perhaps need to consult the Central Groundwater Board reports also. We have a Central Groundwater Board. It's a central government all India level organization. They have also now shifted the approach to demand side rather than from supply side. Now, how best are they doing it? And what are the conjunctive utilization aspects? Conjunctive means both combination of surface as well as groundwater supply as per the demand needs of a particular segment. And we know this in India, at least there are more than 70% water consumption is for agricultural use, for irrigation. So please think more on these. And you started very nicely how best we can think of reducing that component so that the water is made available for other segments of the society, industrial and other uses. So I think more efficient use of the water is really needed. And that aspect you will consider while doing more research work. Thank you very much once again. I think a paucity of time will not permit us to go into more details. So we'll thank you and move on to our last presenter, our poster session presenter, Miss Kiran Khanna. Miss Kiran, are you there?
Yes, sir, she's there.
Namaskar, sir.
Please start your presentation. Sorry, we kept you waiting because your data was not readily available and there were some glitches from our end also. You please start your presentation. Thank you.
So is screen visible, sir?
Yeah.
Yes, the screen is visible. Kiran, stick to 5 minutes, okay?
Yes, sir. So our topic is network topologies for connected cities. So network topology is a way the network is connected and distributed, and how the set of nodes are connected and related to each other. So the proposed topology comprises of variables, mobile phone sensors distributed throughout the cities based on data responses and resource distribution mechanism using SD and Mininet. So Mininet, we have implemented the topologies in Mininet also. Mininet is a real, Mininet is a realistic topologies where we can do research. We can implement we can deploy it in hardware. We can share with our friends. So in Mininet, we have implemented implemented using mobile phones from where throughout the cities in which data is collected and resources are allocated. So a network topology is implemented using SD and Mininet. Topology showcases the resources distribution in the city. The implementation consists of different clusters of servers, firewalls, and load balancers needed for the city topology. So we have done it in the Cisco package tracer consisting of 4 areas, local areas. This 4 areas represents the city topologies in which we have different computers, laptops, mobile phones, printers connected. The implement consists of variable devices, laptops, and other devices that are used as a part of the city. So here we are having a smart city. In smart city, in mobile phone implementation, the data is collected using the sensors. Like data is collected and it is distributed. If during COVID, if many people are gathered together, that it will be sending the data to the IoT devices. So if there are more people, they will be sending the drones. So our main approach for this project is for good successful cities and communities and good health and well-being. We want to show that using in the network topologies, using the resource allocation, we can solve the problems such as disaster management. We can prevent the disaster management. For an example, if some landslide detection we can detect, and we can send some security set like drones, emergency responses, or ambulance, so that people can be safe before any disasters occur. Only that's all.
Yeah, thank you very much. Please go to the top of your poster.
Yes.
Yeah, okay. And your title is actually connected cities. Now, once you use this plural word, cities, I thought maybe you are dealing with the interconnectedness of different cities. But what you talked about is actually within the city.
No, sir. Different cities are there, sir. Total 4 cities.
Okay. So, but those things are not brought out in the context that you are actually thinking. Anyway, I think it was a good presentation. Although the sharpness is not there in the poster, but we could get the gist of what you really mean. So are there observations on the feedback or comments on this, please? Yes, Gopal sir, are you there?
Yeah, I'm here.
Any comments?
I was just wondering what they were trying to optimize, or were they Are you guys trying to just outline an architecture for the topological architecture? Is that the objective of the poster?
So like this is a kind of idea. So we didn't implement it till now. Like if it will be implementing and presenting, publishing a paper based on that.
Okay, so you're on the beginning. You're in the beginning stage of your
Yes, sir.
project. Okay, got it.
Can you go to
Now,
the
Shiva, am I audible?
Yes.
Yeah, please.
Yeah, sir, Chetan inside. Actually, I just wanted to say that sir had initially asked about the connected concept here. So the term connectivity was used specifically because we just wanted to explain that, how the sensor data, that is sensor data and also data from different kind of mobile devices or IoT devices distributed throughout the city can be used for a simulation for resource allocation through the network topology. And for this, actually, like Kiran said, we had used we had simulated 4 cities, and that was done using Cisco Packet Tracer. That's why the term connected cities has been used. And furthermore, the question here was that what is the main objective here, or the thing that we need to optimize? So the main objective here was disaster mitigation, and to see how in the cases of disasters, or in cases like one of our applications that we are planning to explain is mitigation in cases of COVID. Like for instance, if there's a lot of people at a specific place, how can this topology be used to quickly mitigate the crowd and prevent further COVID spread? So there were various test cases that we are planning to discuss in our publication also.
Okay. So one thing about disaster, one observation that one thing that you need to ponder about in terms of disaster scenarios is the disaster will also affect the infrastructure. So if you're dependent, if your infrastructure does not have built-in redundant robustness, then the very infrastructure that you're dependent upon will also go away. So you need to ponder.
I agree, sir.
So how do you build in such robustness and redundancy?
Yes,
Also
for that actually, for that way, I think we will be discussing various resilience metrics. Like for instance, if specific aspects of the infrastructure have been damaged, maybe drones can be used for that process, as has been showed in the the poster. Furthermore,
so your simulations includes drones as well. You have included drones.
Yes, sir. In the poster, it can be seen. So for the network topology implemented, that was a portion.
Okay, good. So the simulation focused mainly on traffic, just traffic simulation in terms of the packet, the Cisco packet thing, the tool that you mentioned. Is it more of a traffic simulator?
So Cisco Packet Tracer. So we were planning to showcase 2 aspects of this. The thing that of the implementation, we wanted to show 2 aspects. That's why we use the Cisco Packet Tracer also. So the main implementation is based on Mininet, but Cisco Packet Tracer also we wanted to use so that we can show how variables and different devices distributed throughout the city can be useful for this process.
So are you tracking latencies and stuff? If you're going to do disaster response, then latencies also are very important. Response times are very important.
Yes.
So
maybe that can be a scope for future work. We didn't look into that. That's a very good.
You're only looking at functionality at in this stage. You're looking at functionality.
Yes, sir.
Okay, got it. Good.
So good.
That's really great feedback. We'll look into it, sir. Thank you.
Yeah, thank you very much, so Chetan and Kiran. In fact, my elementary understanding is that smart cities are smart because people are smart. If people are not smart, then all these modern gadgetry may not be really delivering the kind of goods that you are intending to deliver. So I think we also need to think how best to make our people smart. Any capacity building aspects and then aspect of good governance, as Gopal sir was also mentioning, that response aspect. If someone is raising some alarm and there is no response. For example, I experienced the waste disposal aspect. I see the waste bins, they are just overflowing with the waste. And even if someone complains, there is no response. Nobody is coming to just clean it and pick it up. So these are the aspects which I think need to humanize how to involve the people who are to be serving and to be responsible for actual action. The actionable aspects, the governance part of it, those are to be also, I think, I'm not very sure because this is not my field. So maybe you can think on these aspects also. Thank you very much for your presentation. It was really thought-provoking. So we have come to the end of our today's presentations. Balmukund,
Yes.
are there any other candidates left, or we are?
No, sir. No, sir. Thank you. I thank Dr. Vasudevan sir and Gopal sir and all the faculties for joining and giving the students their guidance. I request the students to further connect to the faculties to get more feedback, since because of lack of time, there could not be that much discussion, but all the presentations were very nice. And now I would like to conclude this session by thanking to all the speakers and all the faculties once again. And we request you to join at 12:30 for the next sessions for the day. So from we have another session coming up from 12:30 to 2 p.m. So there will be distinguished talks in that. So all of you please join again. Thank you.
Okay. So thank you very much. So back to the host team.
And during the break, videos will be played.
Will you be sharing these posters and presentations to all the participants?
Yes.
Okay. Will there be any proceedings also for this poster presentation, just like conferences?
Yes. We'll let you know all these things.
Okay. Thank you.
Thank you very much. And of course, they will be given the participation certificates also, right?
Yes. Certificates will be given to all.
Okay. Thank you. Thank you all. Thank you very much.
Thank you.
Thank you all.
Stopped.
കഴിഞ്ഞ വർഷം അനേക പ്രകൃതി ദുരന്തങ്ങൾക്കും സംഘർഷങ്ങൾക്കും ലോകം സാക്ഷ്യം വഹിച്ചു. പ്രളയം നമുക്കൊരു താക്കീതായിരുന്നു, സന്ദേശമായിരുന്നു. സ്വാർത്ഥമായ താൽക്കാലിക ലാഭങ്ങൾക്ക് വേണ്ടി പ്രകൃതി ചൂഷണം ചെയ്യാൻ തുടങ്ങിയിട്ട് കാലങ്ങൾ കുറേയായി. അതിൻ്റെ ദിഗ്ധഫലമാണ് നമ്മൾ കണ്ടത്. ഓരോ വൃക്ഷം വെട്ടുമ്പോഴും അത് നമുക്ക് ശവപ്പെട്ടി ഉണ്ടാക്കാൻ പറ്റുന്ന വൃക്ഷം വരായി തീർന്നിരിക്കുകയാണ്. പ്രപഞ്ചത്തിനൊരു താളമുണ്ട്. ഈ വിശുദ്ധം അതിൽ അകലജീവിയാളും അഭേദ്യമായ ബന്ധമുണ്ട്. പരസ്പരം ബന്ധപ്പെട്ട് കിടക്കുന്ന നെറ്റ്വർക്കുകളാണ് ഈ പ്രപഞ്ചം. 4 പേര് ചേർന്ന് പിടിച്ച് ഇവരുടെ കോണിൽ സ്ഥലമുണ്ടായാൽ അതെല്ലായിടവും പ്രതിഫലിക്കും. അതുപോലെ നാം അറിഞ്ഞോ അറിയാതെയോ ഒറ്റയായോ കൂട്ടമായോ ചെയ്യുന്ന എല്ലാ കർമ്മങ്ങളും പ്രപഞ്ചമാകുന്ന വലയുടെ കോണിൽ പ്രതിഫലിക്കുന്നുണ്ട്. അവർ മാറി നമ്മൾ മാറാൻ നടക്കില്ല. അവർ മാറില്ല, നമ്മൾ മാറിയാലും മാറ്റം കൊണ്ട് കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതി സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
ഒരപേക്ഷയുള്ളത് യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവർ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളവർ ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ടും നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ള ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മിക കൂടി ഗ്രഹിക്കുന്നത്. ഇപ്പം നമ്മുടെ തലമുറയ്ക്ക് ഇപ്പം കുറച്ച് വെള്ളമെങ്കിലും ഉണ്ട്. നമ്മൾ പൈസ സമ്പാദിക്കുന്നു, കുട്ടികളെ സൃഷ്ടിക്കുന്നു.
പക്ഷേ കുടിക്കാൻ വെള്ളമില്ലെങ്കിൽ എന്തായിരിക്കും? ഇതിൻ്റെ കൂട്ടത്തിൽ പണസമ്പാദനം കുട്ടികൾ സൃഷ്ടിക്കുന്നത് പോലെ തന്നെ അതിനേക്കാളും കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതി സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labte jnanam. Human settlements in rural areas have always enjoyed a direct link with the surrounding natural environment. However, with rapidly depleting resources, many villages in India have entered into sustained poverty. In 2013, Amrita Vishwa Vidyapeetham, guided by its Chancellor, Srimata Amritanandamayi Devi, launched the Live in Labs program.
We have made this program in such a manner that it has closely knitted the interdisciplinary domains together to bring in the solution. We give the students an opportunity to see the rural community, be in that environment, in the rural community, along with them, live with them. So automatically, compassion will be generated in their heart, which provides them an opportunity to find out what are the challenges they are facing and how their technical knowledge can be used to provide it as a solution.
The Live in Labs program continuously strives to achieve the UN Sustainable Development Goals by fostering self-reliant communities. Bachelor's, master's, and PhD students from all over the world can spend 2 weeks to 6 months working with Amrita faculty and students at one of the program sites. After a comprehensive orientation session and team formation, program participants will live in and explore the village to identify challenges and co-design a proposed solution. Implementation, evaluation, and making improvements will happen after testing the solution in the university's labs.
For any technological solution to be viable, to be sustained, you need to be with the community in designing the solution. That is one of the major things we train them in the whole process, where they'll work with them in coming up with the design. They look into it, what is their needs, so that they can come up with affordable, adaptable, sustainable solution, which will make sure that the technological solutions will become a success.
The program draws on principles of human-centered design for the development and deployment of sustainable solutions in the areas of energy and environment. By developing pathways to access renewable electrical energy, utilizing smart energy technology, and encouraging sustainable practices to protect the environment and conserve natural resources. Water and sanitation. By designing micro-water distribution and management systems, implementing water filtration systems, and fostering water-wise communities. These are joined by initiatives in rural sanitation, which develop sustainable models for toilet construction, fostered through democratic participation. Health and hygiene. By implementing hygiene awareness programs to increase community health and well-being, developing low-cost technologies, diagnosis units, micro-healthcare management devices, a rural health management system, and epidemic management and detection programs. Livelihood and skill development. by designing immersive training programs to acquire new skills, further developing existing skills, and identifying alternative and sustainable income generation avenues, ensuring long-term viability. Education and gender equality. By encouraging gender equality in education through immersive technologies for language training, vocational training, after-school assistance, and life skill training. Waste management and infrastructure. By exploring environmentally sustainable solutions for rural waste management, such as waste-to-wealth initiatives and alternative affordable construction techniques from natural resources. Agriculture and risk management. By designing innovative and smart technologies to promote efficient farming practices, developing techniques to enhance soil and crop quality, and implementing models and systems to map and identify environmental risks. Over the years, students from multiple universities around the world have come to Amrita to participate in various Live-in Labs projects. India's villages are her life force, and they need immediate care and attention. Societies are at their most resilient when knitted closely with threads of love and compassion. So join us and let us work together to develop self-reliant villages in India. Experience is the final evidence for knowing. Shraddhavan Labte Jnanam.
ഞാൻ ജനിച്ച ഗ്രാമത്തിൽ ഒരു 90% ആൾക്കാർ അന്നന്ന് ജോലി ചെയ്ത് ജീവിക്കുന്നവരാണ്. അസുഖം വന്നാൽ അല്ല ഹാർട്ട് അറ്റാക്ക് വന്നാലോ വാൾ മേടിക്കാൻ പൈസയില്ല. അത് വെളി രാജ്യത്ത് നിന്ന് വരുത്തണം, അത് വലിയ തുകയാണ്. അപ്പോൾ ഇവരാരും ഓപ്പറേഷൻ ചെയ്യുകയോ വാൾ മാറ്റി വയ്ക്കുകയില്ല. 70 വയസ്സ് ജീവിക്കേണ്ടവൻ 40 വയസ്സ് 30 വയസ്സിൽ മരിച്ചു. അന്ന് ആ രാജ്യത്തിൽ ഉണ്ടാക്കിയിരുന്നെങ്കിൽ വളരെ വില കുറഞ്ഞ് കിട്ടിയേനെ, ഇവരൊക്കെ രക്ഷിക്കാനും പറ്റിയേനും. ആ സമയത്താണ് റിസർച്ച് ഇഷ്ടം വരികയും റിസർച്ച് ഇങ്ങനെ സാധുക്കൾ കൂടെ സഹായിക്കുന്ന രീതിയിൽ ചെയ്യുന്നത് നല്ലതായിരിക്കും എന്നൊരു മനോഭാവം മനസ്സിൽ ഉണരുകയും ചെയ്തു. ശിശുമരണം വന്നപ്പോൾ നമ്മൾ അന്വേഷിക്കാൻ അയച്ചു ഗ്രാമങ്ങളിൽ. ആ സമയത്ത് ചില സ്ത്രീകൾ പച്ചില കഴിക്കുകയാണ്. എന്തിനാണ് നിങ്ങൾ പച്ചില കഴിക്കുന്നതെന്ന് ചോദിച്ചപ്പോൾ മാസത്തിൽ 10 ദിവസമേ ഭർത്താക്കന്മാർ ജോലി കിട്ടുകയുള്ളൂ, അതുകൊണ്ടൊരു മാസം തികയ്ക്കണം, അപ്പോൾ കുറച്ച് ഭക്ഷണം കഴിക്കാൻ കിട്ടുകയുള്ളൂ. അപ്പോൾ ഈ ഒരു തരം വിലയുണ്ട്, അത് കഴിച്ചാൽ വിശപ്പറിയില്ല, അപ്പോൾ കുറച്ച് കഴിച്ചാൽ മതി, അപ്പോൾ വിശപ്പറിയാതിരിക്കാൻ വേണ്ടി കഴിക്കുകയാണ്. ഇങ്ങനെയുള്ളവർ പ്രസവിച്ചാൽ എങ്ങനെ പോഷകാംശമുള്ള കുട്ടികളെ പ്രസവിക്കാൻ സാധിക്കും? അപ്പോൾ തീർച്ചയായിട്ടും സ്ത്രീകളെയാണ്, അമ്മമാരെയാണ് ആദ്യം ശ്രദ്ധിക്കേണ്ടത്. അപ്പോൾ ഇതുപോലാണ് കണ്ടത്. വേറൊരു ഗ്രാമത്തിൽ ചെല്ലുമ്പോൾ അവരൊരു ഭക്ഷണമുണ്ട്, പക്ഷെ ഭർത്താവ് കുടിച്ചിട്ട് വരുന്ന നമ്മൾ പിടിച്ച് തല്ലിയും വളം വയ്ക്കുകയും ചെയ്യും, ഉള്ളത് തന്നെ കഴിക്കാൻ പറ്റുന്നില്ല. അപ്പോൾ അവർ ജോലി തരുന്നതുകൊണ്ടല്ലേ, എന്ത് ചെയ്യാനാണ്, നമ്മൾ പഠിച്ചിട്ടില്ല. അപ്പോൾ ആ സമയത്ത് എനിക്ക് തോന്നി, കാരണം ഇവർക്കൊരു എന്തെങ്കിലും ഒരു തൊഴിൽ പഠിപ്പിച്ചു കൊടുത്താൽ ഇവർക്കൊരു സ്വയം പര്യാപ്തമാകാൻ പറ്റും. ഇങ്ങനെ ഇടികൊണ്ട് കഷ്ടപ്പെടേണ്ട ആവശ്യമില്ലല്ലോ. കാരണം എന്ന് വെച്ചിട്ടാണ് അങ്ങനെ തൊഴിൽ പഠിപ്പിക്കാൻ തുടങ്ങിയത്. വേറെ സ്ഥലത്ത് ചെയ്യുന്നപ്പോൾ പറഞ്ഞു ഗവൺമെൻറ് ചില ആനുകൂല്യങ്ങൾ കിട്ടുന്നമ്മ, പക്ഷേ ഭർത്താവ് അത് ഒപ്പിട്ടിട്ട് ഞങ്ങളുടെ ഒപ്പുപോലിട്ടിട്ട് കൊണ്ട് പൈസ എടുത്ത് പോയി കുടിക്കുകയാണ്. പക്ഷെ അതുകൊണ്ട് അവരിങ്ങനെ കഷ്ടമായി. അപ്പോൾ അക്ഷരങ്ങൾ അവർക്ക് പഠിപ്പിച്ചു കൊടുക്കണമെന്ന് തോന്നി, അങ്ങനെ അക്ഷരങ്ങൾ പഠിപ്പിച്ചു കൊടുക്കാൻ തുടങ്ങി. അങ്ങനെ ഓരോരോ സന്ദർഭങ്ങൾ, ഓരോ അനുഭവത്തിൽ നിന്ന് പലരും പല പല കാര്യങ്ങൾ അങ്ങനെ ചെയ്യാൻ പറ്റി. അതുകൊണ്ട് ഒരപേക്ഷയുള്ളത്, യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവരെ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളവർ ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ട് നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെച്ചാൽ വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ളവരുടെ ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മിക കൂടി ഗ്രഹിക്കുന്നത്. ലോകത്ത് 2 തരത്തിലുള്ള ദാരിദ്ര്യമുണ്ട്. ഒന്ന് ആഹാരവും ഭക്ഷണവും വസ്ത്രവും കിട്ടാതെ ദാരിദ്ര്യം അനുഭവിക്കുന്നു, 2 സ്നേഹവും കാരുണ്യവും കിട്ടാതെ ദാരിദ്ര്യം അനുഭവിക്കുന്നു. ഈ സ്നേഹവും കാരുണ്യം ഉണ്ടെങ്കിൽ ആഹാരവും വസ്ത്രവും കടപ്പാടവും കിട്ടാത്തവരെ സഹായിക്കാൻ സാധിക്കും എന്നുള്ളത്. ജീവിതമാകുന്ന വൃക്ഷം സ്നേഹമാകുന്ന മണ്ണിൽ ഉറച്ചു നിൽക്കട്ടെ. സൽക്കർമ്മമാകട്ടെ അതിൻ്റെ ഇലകൾ, അനുകമ്പപൂർണ്ണ വാക്കുകളാകട്ടെ അതിൻ്റെ പുഷ്പങ്ങൾ, ശാന്തിയാകട്ടെ അതിൻ്റെ ഫലങ്ങൾ. അങ്ങനെ സ്നേഹത്തിൽ ഒന്നായി ഒരു കുടുംബമായി വളർന്ന് വികസിക്കട്ടെ. അങ്ങനെ ശാന്തിയും സമാധാനവും കളിയാടുന്ന ഈ ലോകത്തിനു വേണ്ടി നമ്മൾ പ്രാർത്ഥിക്കാം.
In rural areas of India, the water the villagers consume is often contaminated due to runoff from their fields, which carry a high concentration of chemical pesticides. Recognizing the need to address this challenge, the Amrita University team decided to work with the villagers to bring clean water to the settlement. In the village of Guptapada, located in Odisha, through MA Mart's Amrita Serve and Amrita University Live in Labs initiative, water is now distributed to 60 homes. Villagers are now able to receive water through a pipe system which connects to an overhead Syntex steel water tank that currently stores 5,000 litres of water. Many villagers express their gratitude to Amma because they no longer needed to make the strenuous trek to collect and carry water back to the village.
ସବୁ ଦେଲେ ସବୁ ଇଆଡ଼େ କଳ ବସାଇଲେ ଆମ ଗାନ୍ଧୀ ଏଠି କାଲି କହନ୍ତି ବଛର ଦେଲେ ଆଉ ସବୁ ତ ଆମକୁ ଦେଲେ ଆଉ କ'ଣ ଆମର ଅସୁବିଧା କଲେ
ସବୁ ହେଲା ଲୋ ମାମା ଏଇଟା ସରକାରୀ କବଲରେ ଆମେ ଏଇ ଜାଗା କାଗଜପତ୍ର ହେଇନି ଯେତେ ଆମେ ଗୋଟେ ଘରୁ ବାହାରିଲୁ ବଜାରକୁ ଯିବା ପାଇଁ ତେଲ ଗୋଡ଼ା ଧୁଆ ଦେଇଛୁ ସୁବିଧା ଆସିଲୁ ଶୋଷ ଲାଗିଲା ଏଠି ଟିକେ ପାଣି ପିଇଦୁ ବଜାରରୁ ଆସିଲେ ସାଇକେଲ ଚଲେଇକିରି ଟିକେ ପାଣି ପିଇଦୁ ଖରାରେ ଆଉ ଆମର ଏଠି ଫୁଟବଲ ଖେଳ ହେଉଛି ଏଠି ଆମର ଷ୍ଟଲ୍ରେ ପାଣି ରହିବା ନିହାତି ଦରକାର ଷ୍ଟଲ୍ ପାଖରେ ବି ହେଇଛି ଏଠି ଆମେ ଷ୍ଟଲ୍ କରୁଛୁ ଫୁଟବଲ ଖେଳ ହେଉଛି ଆମର ମ୍ୟାଚ୍ ଆମ ଦେବାରୁ ଆମେ ବହୁତ ସୁବିଧାରେ ଅଛୁ।
For many villages in India, collecting and carrying water is part of their daily routine. However, villagers often have to walk several kilometers to collect water necessary for themselves and their families, sometimes walking several times a day. Many villages, especially women, collect and carry between 150 and 500 liters of water per day for their families and cattle. This was the same for the village of Harirampur, located in the district of Rajasthan, one of the 101 villages adopted by the MA Mart. Recognizing the hardship of the villagers, Amma encouraged staff and students from the Amrita University to provide water distribution systems for more effective water use and management. In Harirampur, MA Mart recently constructed a borewell in the village, and water is now distributed to all 65 homes through a pipe system, with an additional 5 taps conveniently placed in public areas. The pipe system connects 2 overhead Syntex water tanks that currently store 5,000 litres of water each. Villagers are extremely grateful to Amma for bringing water to their doorstep.
अम्मा जी ने भाई साहब पहले नंबर में हमारे शुरू में ऐसा है कि पहले हमारा ये छोटा सा गांव था, सांकला में लम्फी इसकी या बस्ती की ढाणी की सांकला में ही जुट रही। एक बात तो पहले नंबर का ही किलो का हमारी ढाणी भी अलग बना चुकी, मतलब अलग गांव बना दी हमारी तन सब बता दी कि भाई के हरिरामपुरा अलग है। दूसरी बात पीछे फिर वो हमारे लिए स्कूल हमारा बहुत ही टूटो पड़ियो, बहुत बुरो। तो अम्मा जी ने हमारे लिए इसमें लाख 3 लाख 4 लाख कहाँ कितना लगाया, मैं तो अनपढ़ दूसरा यहाँ पर तो उनके कते ले गया कते नहीं ले गया। तो अम्मा जी ने हमारे लिए बहुत अच्छो काम स्कूल हाई फाई बना दियो। और तीसरी बात हमारे स्कूल में बालिक सांकले जाव्या, फिर स्टेशन जाव्या, हाडोती जाव्या, तो दिन भर भगया, घंटा 2 घंटा पढ़ाया, भिगवा में भूल जाव्या।
अम्मा जी हम बहुत खुशी हुआ, हमारे को वाटर घर में ही पा दिया है, हम बहुत खुशी हैं, बहुत अच्छो करियो, बहुत ही अच्छो करियो।
Just wait for a couple of minutes, sir.
Yeah, sure.
So maybe we can get started. So welcome all to the afternoon session of day 2 of our symposium. So it's my pleasure to introduce the first speaker of this session. Dr. E.A. Gopalakrishnan currently serves as Assistant Professor Selection Grade at Amrita Center for Computational Engineering and Networking, called CEN, and Department of Mechanical Engineering, School of Engineering, Amrita Vishwavidyapeetham, Coimbatore campus. Dr. Gopalakrishnan finished his BTech in Mechanical Engineering from the University of Calicut. He obtained his master's from Amrita Vishwavidyapeetham in engineering design and started working in Amrita as an assistant professor. Later, he proceeded to IIT Madras to pursue his PhD under the guidance of Professor R.I. Sujit in the Department of Aerospace Engineering. His research interests include complex systems, combustion instabilities, nonlinear dynamics, stochastic systems. Currently, he is working on developing precursors to impending catastrophic transitions in complex systems. Apart from his academic pursuits, he is interested in understanding Indian culture and Indian philosophy. His area of interest in Indology are Indian philosophy, scientific achievements in ancient India, and the relevance of Indian scriptures in the modern context. His topic for today would be AI-based early warning signals for rate-dependent transitions in ecosystems. Dr. Gopalakrishnan, the stage is yours. I would request you to keep it around 10 minutes so that we have some time for question and answers after that. Please take it over. Thank you.
Thank you very much for the nice introduction, and Namah Shivaya to all of you. So let me just start my presentation. So hope my presentation is visible. So I will just put it in the presentation mode. So hope it is visible.
Yes, sir, it is.
Yeah. So I will start. So yes. The topic for the day is AI-based early warning signals for rate-dependent catastrophic transitions in ecosystem. So I know that it's a very long title. So I will just walk you through the title. So first of all, before we begin, so let us try to see a very short story of 1 minute, like the story of Sahara. So we know it is one of the largest deserts in the world. However, some of us may be surely knowing that this was a lush green ecosystem some thousands of years before. So what has happened to that lush green ecosystem actually? So if you look at the graph below, then you can see that there was a transition that happened around 5,000 to 6,000 years from now. Before, and then that transition resulted in the ecosystem becoming a desert from a lush green ecosystem. So there are many theories for this. And one theory says that there are some anthropological reasons or forcing there which accelerated this abrupt shift. So please take note of these two words, abrupt shift and accelerated. We will be using it later also. And now look at this area marked with the red circle. So suppose that you were there at the bottom of the red circle, that is the bottom line. We would have never thought that we will go or we will undergo a regime shift like this. So that is the suspense, or that is the real crisis. So ecosystems undergo regime shifts, and these regime shifts are nothing but, in the modern parlance, we call them as tipping points. So what is a tipping point? So tipping point is something like this, what you see here. So you can see a very fertile ecosystem. So when one of the system parameters, something like dryness of climate is changing, so you are there on the top black line. So you are now coming down. And you think that you will continue in the top black line, but as soon as you hit what is known as the critical transition point, or otherwise the tipping point, then you tip to the alternate stable state, which is an undesirable state most often. So this transition is actually the regime shift, otherwise it is called tipping, and this tipping happens because of change in parameter, so we call it as B tipping or bifurcation induced tipping. Now going further, you can see that this tipping can either be catastrophic or non-catastrophic, because you have heard this term catastrophic many times during the last day's presentation and again today also. So you can see here, this represents a transition wherein there is a slight change in condition which is causing a large change in the state of the system. Then the other picture, the second one, is also representing that. However, the difference between the two is, if you want to restore the ecosystem, then in the first case, you just want to restore the conditions, so your ecosystem is back into your desirable state. Whereas in the second case, you cannot do that. You need to reduce the conditions, or you need to reduce the conditions to a much lower level in order to restore your ecosystem. Now, this can also be caused because of the noise of the fluctuations present. So these are the anthropological forcing that is that can be there, or human forcing that can be there. So if the ecosystem can be pushed to an alternate state. So now, just to get what is the difference between this catastrophic and non-catastrophic. So take this transition. So imagine that you are changing some control parameter and you are making some measurement. So the blue line is representing stable state, blue circles. Red circles are representing unstable states. Now what happens? You hit the control parameter value of 0. Then your stable state becomes unstable, and there is a birth of new stable state, which you see as the new branch there. So you will go to the new branch. So this is actually the regime shift. So this regime shift, you can see that it is continuous and it is not abrupt, and you can easily revert back. Now, whereas if you are facing a catastrophic regime shift, then what happens? You hit the transition point, you see an abrupt shift. And then what happens? You need to reduce the control parameter further in order to bring your ecosystem back. So you can see 3 regimes there, or 3 states are there according to the parameter. One, wherein you will always be in the desirable state. Second, you can be in the desirable stable state or undesirable stable state. That is called the bistable state or bistable system. Then you have the third one, wherein you will always be in the undesirable state. That is, the transition has already happened. So now we need early warning signals for these kind of catastrophic transitions. So the question is, can we develop such early warning signals? So I will make it very non-mathematical so that all of us can understand without much time delay. So let us say that we are in a double well. So a ball is there in a double well. So this is like 2 stable states. So initially you are far away from this tipping point. So what happens? Even if I perturb the system, even if I perturb the ball will come back to its position. So the recovery rates are very high. As you approach the tipping point, what happens? The basin of attraction of your desirable stable state is reducing. Because of that, it becomes more shallow, and the shallow nature reduces the recovery rate. And once you approach the bifurcation point, then there is your stable state is completely becoming unstable, and you will shift to the alternate stable state. So this phenomenon of critical slowing down, mathematically, it amounts to the change in your eigenvalue, and especially your real part of your eigenvalue becomes 0. So using that, you can develop early warning measures. Main measures that you can develop are autocorrelation and variance of the time series that you observe. And these measures actually show, as you see in the picture, you are transiting from the top stable state to the bottom one at the point F1. But your measures are showing this transition well ahead of time, well ahead of transition. So you can be forewarned. Now this we also did a laboratory experiment along with a numerical experiment in a bistable oscillator, which can be a representative for many ecosystems, a canonical model, and we were able to publish it in scientific reports. Now, coming back to the question, that is the rate dependent transition. So we saw tipping, we saw catastrophic tipping. Then what do you mean by rate dependent tipping? So rate dependent tipping means the tipping not only happened because of the parameter change or not only because of noise, but also because of the rate at which you change the parameter, which is very, very startling. So why this happens? It happens because of the bistable nature of the system. So I already told you, in the bistable state, the system can either be in the desirable stable state, which is in the bottom. So if you are below that red line, you reach that. And if you are above the red line, you will reach the undesirable stable state. And the red line is actually representing like a hill, which is the separation between the two wells which we saw. Now, if you just see this same picture, if you see it in the phase space, so you can see that the undesirable stable state is like a blue circle and the desirable one is like the blue dot. And the hill that is separating them, that is the unstable state, that is the red circle. Suppose that you are there within the red circle, which means that you will not tip. So you will not tip into the barren state actually. However, what happens if there is some disturbance, and because of the disturbance will die down and you will come back to the stable state. But by the time you come back to the stable state, the rate of parameter change is very high. So what happens is that the basin of attraction of the stable state is reducing. Because of that, you just get transited to the unstable or undesirable stable state. So this will be more clear here. So this is again the bistable system. So which is, you can see one initial condition we have taken, which is in the which is in the basin of attraction of the fixed point, or which is basin of attraction of the desirable stable state. So it will come back. Now you can see there the parameter there, R dot is dependent on the control parameter mu, but mu is now not independent of time. There is a rate of change of mu, which is mu dot equal to C. So now if I increase the value of C, what happens? There is a sudden shift. So this is what happens to many ecosystems because of the human forcing and because of other interactions. What happens? The rate at which the transition happens is much more than what we think. So because of that, we get what is known as R tipping. And the question is, can this occur in a real ecosystem? Yes, the answer is yes. It comes from the research of the Peter Ashwin. You can see this is about the peatland fires that you see. So in the peatland fire means these are wetlands where you have a lot of carbon there and there are heat being released because of the microorganism, and this heat will not dissipate and that will accumulate, and that accumulated heat will result in a fire. So that fire is going to depend upon the ambient temperature, and the rate at which ambient temperature will depend upon the factors like global warming. So if your rate of increase of temperature is changed, then you can see these type of hazards much more than what you actually observe or what you actually expect from your mathematical models. So now the question is, can our earlier developed that critical slowing down based measures, can they predict these kind of rate dependent transitions? Unfortunately, the rate dependent transitions cannot be predicted mostly by the CSD based indicators. We did an experiment with a numerical model, again a bistable model, it's a forced oscillator model, and we saw that the measures that we usually use for a machine learning algorithm like accuracy, precision, and recall. And for your information, I have just given the explanation for that so that I don't have to explain what all they. So now you can see that it is actually predicting only 50%. So that means just like tossing a coin. So your CSD based indicators are not going to be very useful. So what you need to do is you are moving from the CSD based indicator to what is known as an AI based indicator. So here basically, you know, a neural network is a regression machine. So you give X and you say that this is Y, and you try to develop the relationship between X and Y. But you can do much more with a neural network. That is, you can ask X of t you can give, and X of t plus delta t you can give, and ask the neural network to start predicting the next data point. So that is what we use a neural network like an LSTM. And again, here we use the hybrid neural network, basically a CNN LSTM hybrid network. And this network work, what we did is we gave the input. The input was time series before transition. I say again. So this time series is given, and the output that we have asked from the neural network is whether the transition is going to occur or not. So thus a trained neural network, it was able to predict almost like 99% it was able to predict. So this is just a work in progress. Many things have to be done here. So the main take home message that I want to tell here is we need to understand not only about the parameter change, we should also be concerned about the rate at which parameters change. And this is very, very important as far as ecosystems are concerned, because this is where our action is going to add or remove the effect. That is, if we are able to slow down the change, then definitely we can see that the regime shifts can be delayed. So that can also be seen. So for want of time, I'm not showing all that. Now, the conclusions are, we can view the regime shift as catastrophic transition using mathematical models. And the tipping can happen either because of parameter change or because of fluctuations or because of rate at which parameter is changing. And you can develop traditional early warning signals for B tipping and N tipping, and you can develop AI-based early warning signals for R tipping. And I would like to conclude by saying that no matter what we do, we need to understand finally that we are part of the nature, as our Chancellor says, and that is the only route out for us to go out of this condition. So thank you very much. I thank all the organizers for giving me this opportunity, and I also thank all the listeners for patiently listening. Thank you very much.
Thank you so much, sir. You did a great job within a very short time, trying to elucidate some very difficult mathematical concepts, even giving real life examples. For want of time, I'm going to suggest that people can type in the questions either in the chat window or the Q&A window, and I will request the speakers to look for these questions and try to respond to them through one of these chat window or Q&A window. Thank you again, sir. Thanks for taking the time and giving this presentation. Thank you.
Thank you.
So our next speaker is going to be Dr. Maya Mahajan. My pleasure introducing her. She currently serves as Associate Professor at the Center for Sustainable Future at Amrita Vishwavidyapitham, Coimbatore. She is an environmental professional and passionate and committed environmentalist. She has more than 25 years of experience in research, training, advocacy, and management in various sectors of environment and development, biodiversity conservation, sustainable development, participatory forest management, sustainable livelihood, wetland ecology, forest ecology, environmental pollution, and environmental education, etc. Dr. Maya Mahajan has a long list of educational and academic achievements that backs her vast experience. A postgraduate in botany with a doctoral degree in environmental sciences, a postgraduate diploma in environmental education from CEE, Ahmedabad, and CEDA, Canada, an executive MBA from Symbiosis International University, Pune. She's also a certified lead auditor of ISO 14001. She was a key resource person for developing and implementing of education module on environment and sustainability, which was implemented for National Teachers Training Program organized by IIT Mumbai, where 170 representatives and 10,000 teachers got benefited. She played a key role in conservation of mangrove wetlands in Mumbai through research, restoration, and education and awareness building with SP Godrej Marine Ecology Center, the CSR wing of Godrej Groups in Mumbai, and was awarded the Women of Substance in 2007-2008. Award by the Young Environmentalist Program Trust at the Environmental Arts Awards function for her contribution to environment protection through education, public awareness, research, and conservation of mangroves. She was also invited as a mangrove expert in the planning phase of Maharashtra Gene Bank, a project being proposed by Rajiv Gandhi Science and Technology Commission of Government of Maharashtra. She was responsible for providing scientific and technological support to NGOs working at grassroots levels in various parts of the country, Bhopal, Pench, Dehradun, Uttarakhand, Ellore, Vapi, Unnao, etc., while heading Environment Quality Monitoring Division in People's Science Institute at Dehradun. With an indomitable and determined personality, Dr. Mahajan is a scientist who is able to communicate with the local community with as much elan with which she can communicate with the scientific community. She has presented and published several scientific papers in national and international journals, books, and was keynote speaker for international conferences, including 6th Griha Summit, Earth Science and Engineering, Environmental Governance and Sustainable Development, etc., and has written books, book chapters, and several popular articles on various environmental issues. Dr. Mahajan would be speaking on ecosystem restoration by community participation today. I would request Dr. Mahajan to keep the talk within 10 minutes for want of time. Please, Dr. Mahajan, please take the stage. Thank you.
Thank you very much, sir, for that such a exhaustive and beautiful introduction. And I wish Happy Environment Day to all the participants, and I thank organizers for such a wonderful webinar, and giving me opportunity to talk. Let me share my presentation. Mine will be slightly different. than all the technical or IoT thing. But when I got this invitation, I thought this aspect is also very important. This one. Are you able to see my screen?
Yes, ma'am. Yes,
Hello?
we are.
Can you hear me? Yeah. Okay. Thank you very much. So I'm more going to talk about ecosystems and community, like how community can participate in ecosystem conservation. Again, if it was like, I hope you all are safe in this pandemic. And I'm sure if it was non-pandemic or before or after that, we would have definitely taken all the participants to different ecosystems around our university. We are very lucky that we are located in Western Ghats, and India itself, we have diverse ecosystem. We have got moist deciduous forest, dry deciduous, scrub jungle, evergreen, sholas, alpine, unique ecosystems like mangrove, coral, wetlands, deserts. And coming to this Western Ghats, we have got this unique ecosystem called evergreen, and all of us know that how this ecosystem was saved, especially in Silent Valley. And we have unique ecosystem which is endemic only to Western Ghat, that is Shola. You can see here grassland and evergreen vegetation patches. This is unique ecosystem. It is found only in Western Ghats. It is not there anywhere in the world. This is a Myristica swamp. This is also one unique Western Ghat. It is highly threatened. This is actually something like mangroves, but mangroves usually grow near brackish water, and this Myristica swamp forest, they are freshwater ecosystems, and it is a unique form of Myristica. In Malayalam you call Jatika. It is spices, very expensive and very medicinal spices. This is different varieties of Myristica swamp that is also found in only very few areas in Karnataka and Kerala and Western Ghat part. And that is also having a great threat, and it is almost now endangered. So many speakers have spoken about ecosystem services. We all know why these ecosystems are so important. Like, you take anything, whether it is oxygen, water, like soil conservation, it's maintaining their fertility, and watershed management, water purification, flood control, carbon sequestration, like global, how to combat global climate change, everything we are getting these services from ecosystem, even decomposition of waste. And forest ecosystem provides shelter, livelihood, water, fuel to almost 2 billion people all over the world. And fisheries supply 45% of animal proteins. Forest provides home to 300 million people worldwide. So 30% of the world's forests are primarily used for production of wood and non-forest. I'm not going too much into detail because we all know why forest or any other ecosystem in that case, why it is so important. One thing I would like to stress here, that when anything comes free of cost, we don't have value for that. Because we are getting drinking water free, we are getting pure air free. Pure air is luxury now. We know what is happening in Delhi. So yes, in Amrita or in some part of Western Ghats, we are getting pure air. So I just want to stress this point here. For those who are non-environmentalists, or especially those business people or politicians or policymakers, they understand anything if you tell them in the terms of like monetary terms. So here UN scientists, like there was a study made by UN, and they could find that I know it is very difficult to put value to anything like pure air, pure water, or biodiversity or medicines. It is very difficult to put value, but there are certain methods by which you can do valuation of ecosystem services. And by using those methods, when they did that, they could find that it is $70 trillion per year. So you can understand like how valuable they are and how we are going to lose if we are losing all these ecosystem services. One more important thing is pollination of plants. See, I am telling this in many of my lectures that we are thinking that we are supreme, and we have got all the technologies, we are engineers, we are going to space or whatever, but we can't even mimic a simple process called photosynthesis in lab. We need agriculture, we need land to do agriculture, and we need bees to do pollination. If that bees have gone, finally we will be starving. So we are restoring ecosystems not only for sake of universe, but we are doing it for sake of ourselves. Like we can go extinct, but universe will go on. So we are going to do this for our own sake. So with that understanding, because when we go in a scientific mode, we think that we have got technologies to repair anything and everything. So I want to take this opportunity to tell you, yes, ecosystem restoration we have to do, we have to develop technologies, but why can't we say which is already there, which is unique and which takes billions of years to form? So first of all, even before restoration, we need to think, why can't we conserve what is already available? Then see, each species in the ecosystem is important. As I told bees, if one species is lost, entire chain is going to collapse. I'm mostly here talking about forest ecosystem because I have done more research in forest and mangroves, but here I have shown many other ecosystems. Each and every ecosystem and elements in that ecosystem are important. And even if there are no decomposers, entire world will be huge dumping ground. So I already told you that human being thinks that everything is for me, but which is very, very wrong. We are just a small, tiny part of this universe or ecosystem. And Earth has given us warning. We have like this simple coronavirus. Now we are not able to conduct seminars. We are not going to go out. We are conducting webinars. So Earth has its own mechanism to control population or anything. I'm sorry for this pandemic. I don't want to say that it is a good event or anything, but I'm just giving warning because we have played with ecosystems. We have played with wild animals. This is all started with wet market from China. So unless we respect ecology, ecosystem, and environment, our existence itself will be in question. And Mother Nature has given us warning many times. Now, coming to my main topic, threats to ecosystem. Before going for ecosystem restoration, why it is getting damaged? Developments, urbanization, industrialization, and this is creating double damage. See, first thing here, you are clearing forest for your livelihood or for over-exploitation. You are doing over-exploitation. You are clearing forest, or you are clearing forest for urbanization, industrialization. Is one great damage you are doing to ecosystem. And during the process, because of urbanization and industrialization, you are also releasing huge amount of greenhouse gases. So damage is double. And again, this global warming is causing again harm to ecosystem. So it is a cyclic.
Mahajan, sorry to interrupt. Could you try to wrap up in a couple of minutes because we are running out of time?
Okay. So I will skip this. What is the state of world's forest and forest absorb huge amount of side and like I will skip all this Amazon rainforest. I had got some data on how mangrove system helps us to absorb 5 times more carbon dioxide than any other ecosystem. And due to climate change, how these ecosystem, which actually protect us, mangrove or coral, how they are getting damaged. Here one beautiful example I had cited that how in Nagapattinam and Pichavaram, both cases, a cyclone has affected. Pichavaram, there was a very little impact because huge amount of carbon is sequestered. Huge amount of mangrove is stored there. Then this coral bleaching, we all are aware about this forest. Okay, I'll skip all the things, global warming and how it is impacting our wildlife and tigers and Arctic and all. I'll come to my work. So usually we talk only about problems. So here I'm going to talk about PhD project was on different invasive species in different forest types, and I found that lantana is creating huge threat to ecosystems and biodiversity. So we thought that why can't we control it? But it is very difficult to control by chemical, biological, or mechanical way because participation and control this invasion and restore ecosystems. So this project was conducted initially in Coimbatore in Sirmani forest. This is lantana, which is invading very rapidly and destroying biodiversity and ecosystems in the entire Western Ghats and Northeast. So we have given training to our tribal people there, and this training is to make furniture out of lantana. We thought if we can't destroy, why can't we make use of it? So this is the process: collection, boiling, assembling, produce, and then this is a beautiful furniture is made, which looks exactly like cane furniture, but its cost is half of the cane furniture because raw material is free of cost. So we also give them training and give certificates so that they can train other people. So we are producing master trainers, and through this process, we are conserving forests. At the same time, we also give them support for marketing, and this thing we have replicated in Dahanu, that is in Maharashtra, some 3-4 villages. Then in Wayanad, we took help of Wayanad Forest Department because many forest people are looking for how to control this lantana, and they're finding it very difficult because it is notorious weed. So nature and outcome is eradication of lantana and conservation of forest ecosystem.
Sorry to interrupt again. Please try to wrap up.
Success stories we have done, like participatory forest management in Wayanad Wildlife Sanctuary by again the help of tribals, how to do of non-forest products, gave them training on race. Yeah, one.
Sir, looks like we've lost her. I suppose she was almost done. So sorry to have lost you, Dr. Mahajan. I would request you to take the questions through the chat window and the Q&A window. So please, look at the. Ma'am, we lost you for some time. I don't know what happened. So thank you. I think we ran out of time also. I request you to, look at the Q&A window and the chat window for any questions that the audience might have and try to respond to those. So such a nice talk on the valuable work you're doing by empowering the rural communities. Thanks again for taking the time to do the presentation. Thank you, ma'am.
Thank you.
Thank you. Our next speaker is going to be Dr. Alka Singh. Dr. Alka Singh is an assistant professor at Amrita Center for Wireless Networks and Applications, Amrita WNA in the Amritapuri campus. She was a postdoc in the Jet Propulsion Laboratory of NASA, California, and also the Goddard Space Flight Center of NASA in Maryland, USA. Dr. Alka obtained her PhD from the Technical University of Munich, TU Munich, Germany, and Masters in Geoinformatics from ITC, Netherlands. I request Dr. Alka to deliver her talk on the topic of, I lost the screen.
Never mind her.
Okay, Alka, you can tell the topic and start.
Yeah.
Thank you.
Yeah. Thank you very much, sir, for giving me this opportunity. I'll quickly share my window. I'll be talking about one of my research work, which is basically evolution of drought and vegetation resilience using remote sensing data. So the goal of this study was to water-carbon interaction. In other words, ecosystem response to climate extremes like drought using satellite-derived data. In order to do that, we have to first identify and extract drought. As we know, there are different kinds of drought. Here we address hydrological drought and flash drought using SMAP and GRACE. Flash drought is relatively new concept. I'll discuss a little more about it in the later slides. After we identified drought, we wanted to determine vegetation response to the drought. So across various land use, land cover types. Specifically, we looked into lag response between the anomalies of soil moisture, which was observed by SMAP, and carbon uptake observed by SIF and GPP from different missions. By different missions, I mean here, like what we had basically used in this project is predominantly SMAP. So SMAP data is available in different products. The level 3 SMAP soil moisture product is a purely remote sensing based observation. Level 4 is remote sensing based observation assimilated in models like a carbon model where we have SMAP L4 carbon product, and soil moisture model, hydrological model where we estimate, NASA estimated SMAP L4 soil moisture product. So the advantage of using the assimilated product is that first of all, we can increase the spatial and temporal resolution, but on top of it, the limitation of space-borne soil moisture observation is that where the region where there is dense vegetation, for example, Amazon forest, or the region which has extreme arid situation like Sahara, Sub-Sahara region. So these areas are soil moisture estimates from space-borne missions fail. So we cannot estimate soil moisture from that region from satellite data. So by assimilated model, we fill this data gap as well as increase the spatial and temporal resolution. So that is the product we get from NASA. And there is another soil moisture product, which is purely remote sensing again, which is called CCI. It is SMAP. It is ESA, the European Space Agency's product, which is purely remote sensing, but they assimilated all different available soil moisture, remote sensing based soil moisture observation. Eventually, it has a longer time window. We also used another NASA mission, which is called OCO2, and we used a product called SIF, that is solar-induced chlorophyll fluorescence. Another important mission which we used in this project was GRACE, which is a gravity field observation mission. And from GRACE, we get terrestrial water storage. What does it really mean on ground is that GRACE, because it observes the change in gravity, gives us an idea about change in water in that pixel or in that column. That may include change in surface water, soil moisture, groundwater. So from surface to subsurface to deep groundwater, everything included as one unit. So we may not be compartmentalized among the different types of water, but we know with another perspective the amount of water located or stored in that particular pixel in that region. All these missions have different methods. So yes. So we harmonize them 2.5-degree grid, and then reduce the their climatology to compare them, compare their anomalies across different land use, land cover type. So how do we now let's go into the calculation of drought. So first of all, hydrological drought. In order to estimate hydrological drought, we reduce the climatology of that time window from that pixel from the observation. So for example, in this figure, I hope you can see my pointer. So the red line shows terrestrial water storage, which is the observed parameter, and we calculate climatology from this observed terrestrial water storage by taking mean of each month. So for example, all Januaries, all Februaries, and so on and so forth, took mean of it and set for 1 year. So, and the mean is called as considered as the climate. And then we reduce this climatology from terrestrial water storage, and that results into some surplus water. So wherever we have more than climatology, we say we have surplus water. Whenever we have less than climatology, we say deficit. So due to this, so these deficits altogether be called, in other words, drought. So this is hydrological drought based on the amount of missing water, the deficit. And the amount and the amplitude here, you see the green plot at the top is in our definition drought. It not only shows the duration of drought, but also the amount of missing water in that water column. This is a very important and information which we get from GRACE. So now we know this is the amount of water missing in this water column. So whenever it goes down, we know the drought is increasing. Whenever it goes up, we say that we are the drought is decreasing, and so the system is recovering. So this is the way we estimated hydrological drought.
Couple of minutes. Try to wrap up in a couple of minutes.
Oh, really?
Yeah, maybe 2 to 3 minutes.
Okay.
Yeah.
Other way estimated the flash drought is by SNAP, and here we used root zone soil moisture, loaded it to percentile, and whenever we say the soil moisture percentile dropped from above 40 to below 20, as well as the evaporation drops from 8% to below 60% of the climatology within the small time window, that is within 20 days, then we considered it as flash drought. So these are the two different kinds of drought we observed, and basically we use GRACE and SNAP in a way, GRACE or soil moisture, and we can see from this map the correlation between them, their anomalies, that for most of the region they match. So that means the system is driven by soil moisture, but for many regions where they do not match, shows that other parameters like maybe surface water or groundwater or snow or any other hydrological parameters are playing role in this region. For example, even in our north part of India, where we know that groundwater decline is going on, so we say we see that there is less correlation in this region. So and so forth. Now coming close to the results, so one of the most common flash drought we happen to see in the recent year is June-July 2017 North American flash drought. We could also estimate it from our model, and for this is a region where our model identified flash drought. And we can see if we look into the time window, the entire time window, from 2002, this region had one hydrological drought, which took like 3-4 months to get to its minima. While flash drought happens spontaneously, like we see the sudden drop in the water in that column. So we can see that the duration of flash drought is very sudden, and we may think that okay, maybe because it's sudden, our vegetation may or may not respond. So we look into it. 2017 only, each month we can see that vegetation, so NPP, the PP and net ecosystem exchange and gross primary productivity dropped suddenly in the same month as we identified the flash drought from other missions. When we look at the hydrological drought, So the drop was like, it took a while to respond. So for example, in the North American savanna region, it took like a month or so. And in Europe, it took like 4 or 5 months to respond. Because the reason for this is the European cropland is actually dominated by radiation limitation. So the cropland response took longer, while savanna and evergreen response took like 1 or 2 months for a regular drought. But for flash drought, this response from vegetation is sudden. And we also observed from the previous slide that SIF responded spontaneously, while GPP or NEE responded in a couple of months based on the land use, land cover, and the climatology of that system. Yeah, with this, I would like to thank quickly. Maybe I missed some points. It would be great to discuss it in more detail sometime else. I'm looking forward to any feedback and questions.
Thank you, Dr. Alka. Again, I would request you to look for questions in the Q&A window or the chat window. Right now, there are no questions, but I'm sure they will come as time goes by. I would also like to mention that on June 19th at 3:30 p.m., Dr. Alka Singh is going to give a webinar titled Explore the Earth from Satellite Remote Sensing. So the registration will open shortly in a couple of days. So do look out for that, and do attend the webinar on June 19th. So with that, I thank Dr. Alka Singh, and it's my pleasure now to invite the next speaker for today. Thank you, Alka. So the next speaker is Dr. Sudish Manalil. Let me give a brief intro to Dr. Manalil. So he currently serves as professor and head of research and chairperson of postgraduate program, School of Agricultural Sciences, Amrita Vishwavidyapitham, Coimbatore campus. He holds a PhD from the University of Western Australia. He has both national and international experience in the field of agricultural sciences. He did his bachelor's and master's in agricultural sciences from Kerala Agricultural University. For the master's program, he secured a research fellowship in agronomy from the Indian Council of Agricultural Research. And for the PhD program, Dr. Sudish secured a SIRF fellowship from the University of Western Australia. While at Kerala Agricultural University, Dr. Manalil specialized in agronomy and agricultural meteorology and worked in pepper and banana research stations. Dr. Sudish did his PhD in population genetics and simulation modeling. After completing his PhD, Dr. Sudish joined as a postdoc with the same university and worked on an Australian government project on greenhouse gas emissions and abatement strategies from wheat fields. As part of this program, Dr. Sudish secured experience in soil sciences, water management, molecular characterization of soil microbes. Later on, Dr. Sudish joined as a professional officer with NSW Government Department, NSW, and worked on genetically modified cotton. In 2014, Dr. Sudish joined as a research fellow with the University of Queensland and worked on the ecology of major weeds. Currently serves as an honorary associate professor of the University of Queensland. Dr. Sudish is also on the editorial board of international journals in agriculture. He published more than 30 articles in high-impact reputed international journals, including Soil and Tillage Research, Frontiers in Agriculture, Weed Science, and Nature Scientific Reports. So I invite Dr. Manalil to deliver his lecture on the topic of conservation agriculture, a climate change resilient practice, and its compliance and performance in small holding rice farming unit. Dr. Manalil, please take the stage. Thank you. And I would request you to keep it to about 10 minutes, Doctor.
Yeah,
thank you.
Thank you. Just trying to Namshivaya all, Sethu sir and Manisha madam, organizing committee. Just trying to share. Yeah, thank you. So, topic I am presenting is conservation agriculture. So, conservation agriculture is quite popular in many developed countries, and it is. We also started in India in northern wheat belt. And we are trying to see the possibility and performance of this conservation agriculture in rice farming, small rice farming unit. Yeah, next slide. Yeah, here conservation agriculture, I showed a picture. Actually, this is like tilling the land. So this is just opposite to what is conservation agriculture. Under conservation agriculture, there won't be any tillage like this. So here that land is tilled. So you can imagine if there is a rain coming, there will be plenty of there will be soil erosion, and also there will be if wind is coming, wind erosion. So this is the conventional method of cultivation, and under conservation system, it is something different. Next slide. Yeah, so under conservation system, we can see a lot of residue there, and the plant is peeping through the residue. So it will be like, in conventional system, there won't be any residue because we till it, and all the residues will be disintegrated, and we won't be able to see such a system like protecting the field. So this residue is actually protecting the field, and plants are emerging from the through the residue. Yeah, next slide. Yeah, so when I worked in Australia, like almost 95% of wheat is under this sort of conservation agriculture system. So I will be presenting some experience from Australia. Next slide. So this is like a machinery. This is a tractor of 400 horsepower, so much bigger than our machinery, because the area of operation is around 10,000 hectares or more than 5,000 hectares, unlike our operational area of 10 hectares or so. So the machinery is also very big here. So just projected a picture, and yeah. So the person that professor is touching a like a knife, like it is like our normal. Sorry, the previous one. Yeah. Yeah, our normal our for cutting coconut, we use that sort of in Malayalam we call kati, like a tool to cut the cut and split a knife. So this is like a big knife. So this is cut into half. So this will instead of in tractor we can see like a cultivator and rotavator. So instead there will be a knife pointer. So when the tractor moves, this will make a split, a slit in the soil. So the seeds will be dropped behind it, and there will be a press wheel compressing it slightly so that the seeds won't be exposed. So this is the machinery. So the tractor, the previous tractor, this is exactly the same tractor with this machinery. Next slide. Yeah, so this is the no-till experiment for conservation, no-till equipment for under conservation agriculture system. So here, there will be like a knife pointer, so that will make a cut. So unlike in our, tractor, there won't be like a cultivator or rotavator or disc harrow that will till the land heavily. So this is the basic unit for this sort of conservation agriculture system. Next slide. So the crop will be looking like this. So in there will be residue stubble standing, and crop will be in the middle. So this soybean crop that is in the middle of previous sorghum crop. So sorghum was harvested, but there was residue. So residue will be falling in the field. So there will be a lot of organic material protecting the field. So this is the way it is done. So if we just imagine now in our system, there won't be any residue standing like this. So it will be like fully like we can see only soil there. So because we till heavily so that everything will be disintegrated very rapidly, and there will be a lot of leaching and erosion as well. Next slide. So studies, already conducted studies. So due to this conservation agriculture, infiltration of water increased by 44%, runoff reduced by 30%, soil erosion also reduced. So different reports are coming from different parts of the world. So if we continue to use this conservation system, definitely there will be more infiltration, because there will be a lot of residue cover. So that will enable soil moisture or rainfall to go down deep into soil. So there will be more infiltration, and runoff also will be less, and soil erosion will be minimum. So next slide. So also there will be microbial, this is another report, minimum tillage, residue retention, increase soil beneficial microbial load. So because it is like a natural system with a lot of residue there. So naturally, when we visited the field, I observed like a soil started to change its color to black, towards black. So the surface layers, because a lot of carbon sequestration is happening, and also beneficial microbes will increase over time with conservation system. So next slide. So whether where India stands in terms of conservation agriculture, that's an important point. So next slide. So it is actually, he's Gurjit Gill from Punjab Agriculture, formerly with Punjab Agriculture University, and currently he's with the University of Adelaide. So he introduced this no-till system in wheat through an ACIAR project, Australia-India collaborative project, and Northern India adopted it, conservation agriculture practices. But of course, we need a smaller machinery, because in Australia or Canada or America or in many developed parts of the region of the world, it will be acreage will be much more. So we need machinery to suit it. Yeah. Next one. Yeah. So this is the happy seeder. This is a smaller version of actually what I presented earlier. So this is a happy seeder of Punjab, developed by Punjab Agriculture University for smallholding farmers. So this is very well adapted in the region, and we all know that there is a lot of stubble burning. So what generally people do, once they harvest the crop, they start burning the stubble to have tillage, to have efficient tillage. Otherwise, this residue will break the, prevent tillage operations, will hindrance to tillage operations. So this is like a happy seeder. So now they adopted it, so that burning residue issue, like a lot of CO2 is emitted through this burning to atmosphere. That's also controlled. So this conservation agriculture is adapted in the northern part of India, and it is increasing, but not in southern part. Yes, next slide. Yeah, so there will be a rapid emission of nitrous oxide. Nitrous oxide is coming from urea. Actually, when we apply urea, we studied that is in the no-till system, conservation agriculture system, because there will be a lot of nitrous oxide emission from urea. So that will increase if there is conventional tillage. But under conservation system, it is less compared to when there will be more tillage compared to conventional system. Next slide, please. Yeah, and so the issue in southern part of India is we are predominantly rice growing. So we are growing rice under flooded system. So, and there will be, of course, there will be on a climate change perspective, methane emission will be there. So from the wetland paddy, so that is contributing to is a major greenhouse gas. So this is the system we follow conventionally. So, and how this the machinery I showed you, that is the happy seeder that is suitable for northern part of India, dry wheat crop. But how it is, we are growing predominantly rice, so how it will be suitable for our condition. So that is the challenge we face, how to introduce this conservation system. And also our holding size is too small. This is a wetland system. So next slide. So we conducted a pilot study in Amrita School of Agriculture Sciences. So this is a rice crop. So this is like a flooded rice crop, and for flooding, to make the paddy like this. Sorry, the previous slide. Yeah, thank you. to make paddy like this, we need a lot of puddling. Puddling need to happen. There need to be a lot of there need to be a lot of tillage and puddling with water. So to make the field itself, it consume about 20% of water, of the total water requirement of rice crop. So this is the way we cultivate. So we tried whether it is possible to have dry seeding with the precision irrigation system. So we compared this method of cultivation with the drip and sprinkler. Next slide, please. Yeah, so this is
wrap up in a couple of minutes, sir.
Yeah, sure. So this is the drip system. So we cultivated here. The water usage is very low. This only there is around 35% of water reduction. So here, instead of tilling the land, we just made a slit and we like sown our seeds and then install the drip system. So the this is like a drip system we compared, and next one is a sprinkler system. Next slide. Yeah, we cultivated in sprinkler using sprinkler system as well. So we got comparable yield. So we got comparable yield compared to the flood system, drip system, and sprinkler system with more than 30% reduction in the water usage. So this is the message we want to carry. And when we harvest, the crop will be like this. So there will be residue. So if we have the right machinery, we can cultivate in between, and we can sow the crop, keeping the stubbles in the field. So that way there is a feasibility, and we need to have undertake multi-locational trials for this purpose. And next slide. Yeah, so the activity will be like this. There will be more earthworms, and there will be more carbon sequestration, less emission of methane compared to flooded system if we follow this conservation agriculture practice in rice farming tract. Next slide. Yeah, so this experiment we conducted with the Living Lab students. So sensors can be employed so that there will be more precise application of water if we can automate the irrigation system with using sensors. So precision irrigation can be combined with sort of drip and sprinkler system, so that there will be even more less usage of water in the dry farm, for paddy cultivation. So by using conservation agriculture system, it will be possible. So that is the study we want to demonstrate. So the approaches here will be identifying conservation agriculture practices through multi-locational trials. So we had this pilot study. So there will be varieties suitable for such system of planting. So we need to screen the varieties, and there need to be sensor technology and simulation modeling so that we can reduce the water consumption, and there can be that is the message we want to convey. No, thank you very much. Namaskar.
Thank you, sir. That was a very interesting talk on how we can scale down conservation agriculture for the Indian context. So thanks so much. As of now, I don't see any questions, but I'm sure they will come up as time goes by. So I would request you to look for questions in the chat window.
Yeah, I have seen one question.
Okay, then go ahead, sir.
Yeah, okay. So the question was whether we are using chemical system or conservation system. That question was from Dr. Maya Mahajan. So the answer is we are not too much to Amma says we are not too extreme to both sides. So we want, if there is an issue, we prefer to be like organic, and we are trying to have this organic packages. So this is towards the climate point of angle, climate change point of view, this system is more resource efficient. So that is the advantage of conservation system. So whether to use chemical in this system all depends on the research and future research, whether can we control a disease with an organic emulsion. That we need to do more research, and that is a different area. So that we need to do through research. So this is like a towards conservation system that is resource efficient. So what sort of technique, whether chemical can be used or not, that we need to do research and see whether that organic emulsion is equally effective as what is available right now. So that is the point we need to do. Thank you.
Thank you, sir. And the audience, if there are additional questions, do post them, and Dr. Manal will be more than happy to answer them. With that, we thank you again, sir.
Thank you.
And thanks for your time. We'll move on to the next speaker for today. Our next speaker is Dr. Daanya. And let me give a brief introduction to Dr. Daanya. She currently serves as an assistant professor in the Department of Physics and in the Amrita Center for Wireless Networks and Applications. She has an MSc degree in physics and an MTech degree in atmospheric sciences. Dr. Daanya served as a project scientist at the National Aerospace Laboratory, Bangalore, for a period of time. She received PhD from the Indian Institute of Space Science and Technology, IIST, Thiruvananthapuram, Kerala. Her currently associated project is Landslide Multi-Hazard Risk Assessment, Preparedness and Early Warning in South Asia, integrating meteorology, landscape, and society. So the project is called Landslip. So now I invite Dr. Daanya to give a presentation on the topic of use of genetic algorithms in rainfall threshold modeling for landslide early warning systems. Dr. Daanya.
Thank you, sir. Thank you very much for your introduction. Let me share my screen. Sir, are you able to see my screen?
Yes, yes.
Thank you. So, hello everybody. Today I'll be talking about a very sort of interesting application of genetic algorithm that is in landslide early warning systems, specifically for creating rainfall threshold models. Before going to the details of the algorithm used, we know that landslides are extremely devastating disasters which causes huge loss of infrastructure, property, and more importantly, lives of people as well as animals. So obviously, early warning of such disasters will help in reducing the amount of loss, at least in the case of loss of life. So, but the problem here is that early warning of landslides is not an easy task because the generation or the triggering of a slide depends on many factors, such as the climatic factors. Yes, sir.
Oh, sorry. I didn't realize.
Sorry, is it anything?
No, go ahead. I didn't realize that I was not unmuted.
Okay. So depending on, there are different factors like climatic factors, geological factors, land use patterns, etc. of a specific region. So the whether a landslide will be triggered or not depends upon the geographic region that we are studying. And and there are many causes also for these landslides. Earthquakes and heavy rainfall being very prominent two causes, direct causes. For landslides that are caused by rain, predominantly caused by rain, there are different ways in which we define what is called a threshold. A threshold means it's a quantity of rainfall that most likely results in a landslide. So we say if it rains over this amount, there is a possibility that landslide will happen in this region. So such amounts, such calculations are therefore very much useful for us to create early warning systems. So if rain crosses a certain limit, you have to be aware that there is a possibility of landslide in a particular region. So what is that amount, which it will depend upon the region that we are considering. So the to consider or to construct such rainfall thresholds, actually there are two different ways. The first one is a physical threshold, which is based on equations of physics equations or dynamics, which when we solve, we get a specific answer. Or there are empirical thresholds based on the data that we have observed historically, we create thresholds. So there are different ways in which these empirical thresholds itself are made. One of the most used one is what is called as intensity duration model, which is which is a classic model used by many people to predict shallow landslides and debris flow. It was first proposed in 1980 by Keynes. So you can see it's a very old method of creating threshold equations. So what this picture that I show here is from the original paper only. So what here we have is we relate the intensity of the rainfall event to the duration of the event, which causes landslide. So the dots that you can see here are all rainfall intensity and duration associated with landslides. So suppose in one place there was a landslide when the rainfall intensity was, say, it may be something like 15 or 20 millimeter per hour for 1 hour duration. So that's the meaning of these dots here. Now the equation that we are interested in is of this straight line. So it's actually, we are fitting a curve here, but the curve is such that it goes through the, it's a lower envelope to the set of points that we see here. So this curve means that below this particular region, there is less or almost no probability of landslide happening. Whereas if the intensity and duration goes above this, there is always a possibility of landslide happening in that particular region. So the equation, this has a general form, I is equal to alpha d raised to minus beta, where I is the intensity and d is the duration. So the problem is to identify the parameters alpha and beta. So what is our aim? Our aim is to find alpha and beta such that when we put in the values here, for every duration that we observe, we should get the intensity value. Or in other words, when we suppose we put some value for alpha and beta, and then the difference between these two should be 0 ideally, or should be the minimum. So this is mathematically expressed in terms of this particular objective. We have to minimize the difference between the two, and the curve should be in such a way that it is a lower envelope. So that's a condition that we put, or a constraint that we put. So this problem becomes a constrained optimization problem. We are finding out an optimal curve as a lower envelope to these points. So there are many methods to solve these constrained optimization problems, and one of the important ones is the use of genetic algorithms. I won't be able to explain the mathematics behind genetic algorithm because of want of time here, but these class of algorithms depend or they are based upon the Darwin's principle of natural selection of species. So what it basically is like that, we have a set of population, and if out of this population certain members may be better fit than certain others. So those who are fit will be selected to further crossover or populate or couple together, etc. Then they will create offsprings. These offsprings may further go through some mutation process, which creates a new generation, which are considerably fitter than the parent generation. So then this generation, again, we calculate the fitness, and this process goes on until some criteria is reached. Our fitness calculation comes to some criteria that we propose is reached. In the case of mathematical problems, it's just like this. So the basic fundamental aspects of our chromosomes, we have genes. So these genes, if we can represent as either 0 or 1, you have gray hair, that becomes 0. If you have black hair, it becomes 1. So these zeros and ones you can combine to form a chromosome, which forms the basis of your genetic footprint, or a genetic fingerprint, basically. So what you have is a collection of binary numbers. Say, for example, one parent has a binary identification 100, the other parent has a binary identification 001. You can combine them to produce an offspring 101. So that is what we call as a crossover. Then in mutation, maybe one of these zeros or ones is randomly changed. So our rule is that every second digit should be 1 always. So instead of the offspring becoming 101, the offspring becomes 111. That's a mutation. So this is the very layman's point of view of how a genetic algorithm works. We populate initially using, so in the case of a mathematical problem like optimization, we initialize a set of randomly selected numbers. These are our initial population. Then we see whether some kind of criteria is met for them. If it is not, we go to we combine them somehow, then to form another set of numbers, then which we call as new generation. Then we go to calculate again our criteria, and so on and so forth. So like this process can go on, so that we say there are generations of offspring may be produced in this process. So in this particular case I'm talking about, we have used an algorithm called NSGA2, which is a non-dominated sorting genetic algorithm, which was introduced by Deb et al. 2002. It is it has a specific rule for crossover mutation, as well as selecting the selecting the next generation using some sort of sorting algorithm. And a crowding distance comparison, it literally means whether one of our solution is close to any of other solution or not. That means one of the offsprings when you have, they should not be in a population itself, they should not be all looking alike, or they should not be all similar in characteristics. There should be diversity in the offsprings. So to ensure that diversity, this crowding distance comparison also is used. So again, I'm not going into the mathematics of the problem here, but let me talk.
Try to
Yes,
wrap
sir.
up in a couple of minutes.
Sure. So a case study, or we have applied it for developing threshold equations for Sikkim, India. So this is a representation of the geographical region, with landslide locations here marked and rain gauge stations marked in blue. Rainfall data was collected from India Meteorological Department. So this is how landslides are distributed. We can see that East Sikkim has a more number, as well as and we can see that during the monsoon months, the landslides are more, which is expected. Now, how we did was we collected the data, then used this NSGA2 algorithm for development of threshold equation, and then we validated our model. So this is the model that we have. I mean, these are the points. These are the green ones. Actually, are the events, rainfall events. There were no landslides during these events. The red points shows that there were landslides during such events with a particular intensity and duration. And using this optimization, we have fitted a curve here. So you can see the equation I is equal to 43.26 d raised to minus 0.78. So this is our model proposed equation for the Sikkim region. We validated this using rainfall data from our own observation system, which is deployed in Sikkim, the place called Chantmari. These are the deployment locations of our Amrita observation system, and we used only the rain observations from this. None of the others were used for this particular study. So using that, we validated from 2015 to 18 whatever landslides we could that happened in the region, and from the rainfall obtained from our observatory, we tried to validate it. What we could find was this is a kind of classification, that is, if we predicted a landslide and it occurred, it is called a true positive. If we didn't predict and didn't occur, it's a true negative. If we predicted but there was no landslide, it's called a false positive. And if we didn't predict but there was no landslide, that's called a false negative. So I'm not sure whether it was clear to you, but anyway, the take-home point here is that we found that we could predict all the landslides that are shown in red points here. But there are some green squares that are false positive. False positive means we say that there is a possibility of landslide happening there, but nothing really happened. That's a false positive. So there were some false positives that was obtained using this method, which is kind of expected because we are only using the rainfall condition alone for our study. So when we combine, if we combine other geophysical parameters also to our model, then we will definitely get a better model out of this. So this is actually Okay, so this gives us hope for improving this. There is a scope for improving this model further by incorporating other observations also. So this threshold equation that we have serves as a first level of assuming that there is a possibility of landslides. So to sum up, we have this presentation just tells you that genetic algorithms are useful in situations like landslide early warning, say for example, like for developing threshold equation. This is illustrated as a case study, and we further need more studies to improve our model further, as well as to develop or to apply the genetic algorithms also further. So these are the references that were used. If anybody is interested, please go and check. Thank you for listening to the presentation.
Thank you, Dr. Daanya. That was a very interesting presentation with real field application and data derived from real deployment being used for the modeling. Now, I have a couple of questions from Anish Rajendran. Very excellent presentation, ma'am. Which tool was used for performing GA-based optimization? Why didn't you choose other OTs like PSO and colony, etc.? He's also asking, what was the population size chosen for simulation?
Thank you, Anish. That is a very interesting question. Actually, why we didn't choose any other algorithm is the primary focus of the study was not on the application of genetic algorithm. To be very frank, the primary focus of the study was to create a rainfall threshold equation. So we used the particular one, NSGA2. That was because it was easy for us to, and many of the programming platforms like MATLAB or I think even C has a installation of this algorithm already available. And we could have done a comparative study for other algorithms also and decided which one is better. But seeing that that was not our primary focus, we used this one, which provided us a fast convergence. And also some of the other algorithms we tried out, some of the more conventional ones, kind of didn't give us a stable answer. There were some cases the minimum was not reached at all times. So this algorithm gave us a consistent minimum in all our trials. Population sample, that's a little more difficult for me to answer because I kind of do not remember what the exact number was, because we out different sample sizes and chose an optimal one. I could probably get back to you after looking at it a little further.
He also wants you to repeat the name of the tool that you used.
Do you want me to?
You mentioned the particular algorithm, right? Yeah, maybe. Yeah.
It's
or maybe you can give the abbreviation.
Yeah, it's called a NSGA2. NSGA2. It's based upon. It's a non-dominated sorted genetic algorithm. 2 stands for an improvement that was done to the original algorithm. Non-dominated sorted, GA. I hope that's clear.
Thank you, Dr. Daanya. So that brings us to the end of this session. We'll have a short break and resume at 2 o'clock. The next session will be chaired by Dr. Sudish Vadhavan. So we take a short break and come back at 2 o'clock. Thanks all of you, and do stay tuned for the next session coming up soon. Thank you. If there are other questions, you can type it in and Dr. Daanya would be more than happy to answer them.
Located in the Wayanad district of Kerala, Modakara is home to 70 families, approximately 300 people, where their main source of income comes from cutting and selling wood and lemongrass. The
പണിക്ക് പോകാനൊക്കെ തുടങ്ങി. പിന്നെ വീട്ടിലെ മക്കളെയൊക്കെ നോക്കണമെങ്കിലും പിന്നെ നോക്കാനുള്ള അവസരം ഇല്ലായിരുന്നു.
Recognizing the hardship of the villagers, students, faculty, and staff from the Amrita Department of Chemical Engineering and Material Sciences, the Amrita Center for Advanced Materials and Green Technologies, and the Amrita Center for International Programs collaborated with international students from Delft University of Technology, Netherlands, to design, develop, and deploy a solar thermal-based lemongrass distillation system. By using renewable energy resources, the system provides a low-cost and reliable avenue for income generation without harming the environment. Approximately 7,000 hours was invested in designing, developing, and implementing the lemongrass distillation system in Modakara.
The entire solar energy which is falling on this solar dish will be focused onto this focal point. So since that it is receiving the energy at a focal point, the temperature at this point will be very high. Water behind this plate will be heated and the steam will be produced. The steam produced will be collected in the steam drum at the top and will be used for distilling the lemongrass.
പഠിപ്പിക്കാനും അമ്മമാർക്ക് കുട്ടികളെ നോക്കാനോ ഒന്നും കഴിയുന്നില്ല. ഫോറസ്റ്റിൽ വിറക് എടുക്കാനോ ഒന്നിനും പറ്റുന്നില്ല. അതുകൊണ്ട് ഞങ്ങൾ അരിപ്രശ്നം തന്നെ മൂത്തിരിക്കുക. ഇപ്പോൾ അമ്മ വന്നതിന് ശേഷം മക്കൾക്ക് ഡ്രസ്സ് ഭക്ഷണമൊക്കെ ഞങ്ങൾക്ക് മെച്ചമുണ്ട്.
Before the new distillation unit was introduced, villagers had to burn 50 kilograms of wood for approximately 2 hours just to generate 100 to 150 milliliters of oil. The new distillation unit decreases both labor and time and enables villagers to produce and sell their own oil. Furthermore, as part of an effort towards women empowerment, the distillation system is fully operated by the ladies of Modakara village.
Om Namah Shivaya to all of you. Mr. Sai, can we start our session?
Yes, sir.
Sir, can we start our session?
Yes, sir. Yes, sir.
Okay, fine. So, namaskar to all of you. Good afternoon. We have a very interesting session this afternoon, and I see a galaxy of real good experts talking on a variety of themes covering our international symposium. So, to begin with, we have Dr. Vasudevan, Dr. D. Vasudevan, who is having a vast experience and a lot of details on his biodata. I'll just briefly highlight that he's basically a civil engineer and with added qualification in various streams of computer science and IT. He has more than 40 years of professional experience in a total of 20 years of information technology and consultancy services. He is currently the General Manager and Head Information Systems, Varanasi Smart City Limited. His last professional assignment was as Deputy Team Leader cum GIS MIS expert with Municipal Corporation of Varanasi in a GICA funded project. And of course, he had provided a lot of consultancy services to different types of clients in different countries, both national as well as international. And he has been a great teacher also. He has been conducting a number of training programs. And he is not only a teacher, but a motivator. And a number of training programs and workshops in a variety of subjects, particularly on information technology, CAD, GIS, organizational development, ITC consultancy, management consultancy, communication and presentation skills, most of great qualifications. He is also a visiting faculty for a few colleges of engineering and consultancy development center. So very impressive data, Dr. Vasudevan sir. May I just request you to please take on the stage and start your presentation, please.
Thank you, sir. Thank you for the good introduction. Good afternoon. Thanks to the organizers for the opportunity to speak on this prestigious symposium on the occasion of the World Environment Day. Ecosystem restoration being a vast subject, I would limit myself to few instances only where we are using technology connected to the ecology and environment in Varanasi. And let me share my screen. You are able to see the screen?
Not yet, sir.
Okay.
It will come. It will take some time, I believe.
Now?
Yes, now it's coming. Please shift it to presentation mode. Yeah, that's right. It's okay, sir.
Thank you. So let me begin by explaining for those who don't know what a smart city is. A smart city uses information and communication technologies, ICT, to improve operational efficiency of the city, and it shares the information with all the city's stakeholders, and the ultimate aim is to provide a better quality of services to the citizens. The main goal of the smart city is to optimize the functions of the city, steer economic growth, and simultaneously improving the quality of life. And in this process, we use smart technologies and the data analytics. So the value lies in how this technology is used rather than simply how much technology is available. Now, we have intensively used the geographical information system in the smart city functions along with the IoT. And the IoT provides a real-time data which need to be put into intelligence to make a decision support system, for which GIS is a cross-cutting tool across all platforms and all other technologies. This real-time data helps in analyzing the trends, patterns which are emerging, and helps the administrators and the technocrats to take apt decisions in the running and management of the city. GIS helps in exploring the data in too many different ways, being a versatile tool. Let me now take few case studies from Varanasi Smart City. We like to, though we do far too many things using technology here, I will being the, considering the time limitation, I will cite one or two case studies here. Let me start with solid waste management system, a challenge which is very common to all cities in the country, and more so in the case of Varanasi. Prior to our implementation of this integrated smart solid waste management system, the situation was very, very pathetic in the city. The city produces as much as 650 metric tons of solid waste each day. The city has a population of 15 lakhs and it has got a floating population of 1.5 lakhs visitors, pilgrims and foreigners and tourists coming from all over the world to the city, adding to the challenges in the solid waste management. So what we have done, we fitted all the solid waste bins with sensors. These sensors are integrated with the GIS and we are always able to track the status of the dustbins. So whether it is saturated, it is filled partially, fully or not. All vehicles, the solid waste disposal vehicles are fitted with GPS and are linked to a vehicle tracking system. The solid waste management staff attendance is also marked to a biometric attendance system, again linked to a central system. The fuel consumption of the solid waste management vehicles are also linked to an automated systems. All these subsystems are linked to an integrated solid waste management system and centrally monitored from what is called a CASI integrated command and control center. This is a overview of how the IoT integration happens across all locations. The complete life cycle of the solid waste, from primary collection to secondary collection to the transfer station and the waste disposal and the processing point. And also in all facets of monitoring, like the biometric attendance, citizens compliant redressal, vehicle tracking, fuel management, inventory management, and all other ancillary activities like even mechanized road sweeping, toilet cleaning, and all these are, everything is mapped. So the IoT is complete and very well integrated as far as the solid waste management system is. And though I am not citing the case study of what we did during COVID pandemic, it was also won a lot of appreciation and awards. We also shared this solid waste management data with Indian Institute of Science Bangalore, who ran a program called IUDX, stands for Integrated Urban Data Exchange for the country. It is on a pilot stage and an experimental stage. And this data is shared on an open source portal, which can be used by the developers and other IT companies and agencies to develop open source applications and value-added applications for use by the vendors and the public. So this is a complete chart of what all the IoT integrations which were done in the, and everything is linked to the so-called CASIC integrated command and control center. So this real-time visualization on using GIS had helped in optimizing the resources of both the pickup and the transportation of the solid waste. And using, since it is on a GIS base, both the public and the waste disposal supervisor, solid waste management staff could easily locate where these bins are located, what is the status, what's the nearby location. So they could plan and optimize the bin pickup. So also this is done ward-wise, what we called Mohalla in Varanasi this wise. So the total waste production in every bin, so how they are picked up, how they are disposed, everything could be mapped very easily. So in a nutshell, we have improved our collection efficiency over 40%, fuel consumption over 30%, and the staff attendance by 25%. This is one case study, and here I will be presenting some pictures from our solid waste management system. Here you find the red, yellow, and green. The red means these bins are already saturated, they are overflowing. The yellow ones are approached, and the greens, there is still some space. So this information, wherever the bin is saturated or overflowing, an alert is automatically sent to the particular ward supervisor and the solid waste collection staff. And everything is centrally monitored at a command and control center. The next pictorial is more or less the same, but in a bar chart form, it depicts a particular bin in a particular ward, and you could see go down and drill down into go to the detail, how much percentage, what's exact location, and so that the resources could be deployed. The vehicle which is picking up the solid waste can also be decide the track based upon the bin locations, and the trips can be optimized. This is another pictorial, and where the complete address and the distance and all other threshold limits and field level. So everything bin by bin you are able to see. This is another pictorial which shows, so on a map, GIS map, we are able to see which is a location where it is overflowing, the one which is marked in red, and the yellow ones are the one where the bins are getting now filled up. So the vehicle, which can pick up could optimize that trip and get it picked up in a most efficient manner. Now, I will talk about another system which we have installed across the city, which is environmental management system. In this system, multifunctional environmental sensors are installed in strategic vantage points all over the city, which provide data on weather parameters, air pollution, sound pollution parameters. It can also measure the temperature, rainfall, and all other information. So this data from all these environmental sensors are integrated, mapped on a GIS, so which helps us analyze on a real-time basis the pollution status at various junctions and various points, and compare them with the thresholds, and the alerts are then generated automatically, and SMS are sent to the police department, the pollution control board, Varanasi Nagar Nigam, and other people who are supposed to take action. So these can be further interpolated with other tools. So if there are any, suppose there is a gas leakage or some severe pollution, so analysis various tools can be, applied to, for example, a weather data and the wind directions could be applied. So how it will be dispersing and what could be the consequences. So all these possibilities, analytical tools are available, and it can be deployed as and when necessary. This is another system which we have implemented in Varanasi. So this is a pictorial showing the various locations, and by just clicking and drilling down, we could go sensor by sensor, the various data available. And in this graph, what is plotted is the particulate matter 2.5 level. Now, as I've already told, the sensors monitor the weather, air pollution, noise pollution, and the spatial distribution of this component and pollution components. So this helps not only in knowing the various parameters of the environmental system, also like managing the traffic congestion and monitoring the construction. If there are dust on this thing, it could mean there is a construction activities are there. It helps in developing, deploying some, water sprinklers, or for reducing the suspended materials and planning the operations. Based on this, Varanasi city police and district measures already sometimes impose certain restrictions on the construction activities and the timing and water spilling. This has already been widely used by the district administration and the pollution control board. This is another pictorial taken from our system. So here it shows the concentration and dispersion of the pollution, and which may locate certain causes, and we can, the concerned authorities could take appropriate action to contain them. and everything available on a dashboard format, and just want us to click and drill down to a particular parameter to get to the data and use it with some analytical tools already included in the GIS. And the last but not the least is also another system which is contributing to the ecology. It's an integrated traffic management system. We have smart traffic lights installed all over the city, and a vehicle tracking control system that combines both traffic lights and array of sensors, and we apply artificial intelligence to intelligently route a vehicle. These are a bigger part of our intelligent transport system. The traffic light monitoring also shows the indicator, the basic indicators like where this light is working, which is not due to power failure otherwise. So this automatically generates an alert sent to the traffic police department so that they could deploy police personnel to those signals which are not working to avoid the traffic congestion, traffic management. And yet another feature is a predictive analysis of traffic at signals, in which the sensors assess the traffic and adjust the signal timings so that the waiting time of vehicles at the traffic junctions is considerably reduced, also leading to a savings in the fuel consumption. And it is also gives the traffic police and the district administration an ability to create a traffic corridor. For example, if there is a transplant, it has to be moved from one hospital to another, or is a vaccine, for the COVID times. So we need to be moved. So we could create a green corridor without obstruction free using the tools so that the system could plan and regulate the traffic in such a way a corridor could be created. This is a pictorial taken from our traffic management system, where the signals or various signals are shown in green, yellow, and red. So indicating whether they are working, not working, or partially working. So all those parameters. So this gives an overview. Sitting at the control room, the traffic police is able to find out what's happening around the city in respect of the traffic lights. And I would like to limit myself to these three, case studies, though we carry out a lot of technology-based interventions, but these are directly related to the environment and the ecosystem. So I would like to stop my presentation here and take any questions from the viewers. Thank you.
Thank you. Thank you, Dr. Vasudevan. That was a very crisp presentation. Varanasi, it's an international city, in fact, one of the oldest city, and you are trying to modernize it through the application of emerging technologies. But are you retaining the heritage character of that old city? It's a religious city, and a lot of heritage value is attached to this. So how are you handling that infrastructural aspect?
Absolutely. A lot of our projects are preserving the heritage, also simultaneously using the technology without spoiling the basic religious, spiritual, and historical characteristics of the city. A lot of projects we are doing, but since that doesn't fit in today's topic, I have not included them here. But we are doing quite a lot of them, sir.
Yeah, sure. Because the old city is having very narrow streets and small gullies wherein mechanization is not feasible unless you do you dismantle and recreate things. Of course, you are avoiding the construction of malls, I'm sure. The old bazaar culture must remain because that is the typical Indian feature. So I'll request Gopal sir to please raise a question or two because we have a real limited time and others can just post their questions here. Gopal sir.
I just have one question about compliance. That was a very great presentation, sir. Thank you. It was a very nice presentation of a great overview. I'm really impressed the amount of work that has been done and integrated. One thing I notice is it's great. We have sensors, we have reporting, and we have reports, and some actionable things come out of it. But compliance, let me give you an example. So you have these bins, and you can know when they are saturated, and you know when they are empty. But can you know that the emptied garbage reached the point where it is supposed to go as opposed to some illegal landfill, for instance?
Absolutely, absolutely, sir. That's a very good question. And in fact, our system covers end to end. We have surveillance cameras, even the entire vehicle movement, solid waste, the moment it is picked up, it's completely tracked because all vehicles are fitted with a global positioning system. It's continuously monitored. We have surveillance cameras, even at some of the, the bin locations and dumping locations. And our last disposal site has got not only video surveillance, the weighing machines, everything is automated and linked to the system. And nobody could get away doing any mischief because everything is tracked digitally and monitored.
Great, great. Thank you.
Right.
So, thank you very much, Dr. Vasudevan.
Thank you very much.
Yeah, if there are other questions, please post them on the chat box or Q&A section. And Dr. Vasudevan will be very happy to be handling those questions and giving us a lot of good information on that. Thank you once again.
Thank you.
Yeah, our next speaker in the afternoon is Mr. Chetan CJ Hali. Is that right? My pronunciation about your name, sir? Dr. Chetan, are you there?
Yeah, I'm here. I'm
okay,
here.
so thank you very much. He's head of the digitization and technology solutions and solution engineering Siemens Advanta India. So very high profile multinational, and they're handling a lot of business dealings, particularly related to the emerging technologies. So with this brief introduction, may I request you to please take the floor and make your presentation, sir?
Sure. Thanks a lot. First of all, thanks for inviting me. Thanks for, I know there's a lot of coordination effort that is needed, especially these days, to make it happen. Thanks to your team. Today's topic, in fact, when I was approached, like what would you want to talk about, specifically related to sustainability, ecosystem, and the emerging technologies, right? Of course, the speakers before me, I'm sure, would have touched upon many of these aspects. Specifically, what I will do is restrict myself to what we are doing. We as an organization, we as Siemens, what are we doing across different geographies to kind of meet the sustainability goals using technology? Okay, so first, probably I'll spend 5-10 minutes on what kind of technologies can be used to tackle these problems. And then I will switch to some of the examples that we have been, examples where Siemens is involved across different geographies in making this happen. So I'm sure there are students who are listening to this and who would want to also go around and check some of the information. So can I go ahead and share my screen?
Yeah, please go ahead. Please go ahead.
Okay. Is my screen visible?
Yeah, it's okay. Just make it full screen.
Okay, just give me a second. I switched over to my other monitor. Sorry.
Yeah, that's it. That's it.
Is that fine?
Yeah, that's fine, sir. Thank you. Please.
Yeah. So like we are an organization that is quite seasoned, 170 plus years. This is like kind of length or duration that many countries also cannot boast of. So we've been here, and there are a few things that have made us relevant 170 years ago, as relevant as we are today. So I'll just like I'm not talking about what Siemens does and so on and so forth. I'm just touching upon some of the greatest challenges of our times. Okay, the mega trends, as we call them. Now, globalization, and many of these are very much in. People have heard about this. People understand what this is about. So I'll not go around digging into the details. But then globalization, right? It is impacting. It is impacting all of us, specifically sustainability, ecosystem, the environment in a huge way. If you remember earlier days, mostly, like people would consume what is generated in that particular geography. Today, it is not the case. Like you get berries from US, from Switzerland, you get cheese. So it's very, very globalized. And then even in 2018, it was around 19 trillion, the volume. Obviously, in the last 4 years or 3 years, it would have gone up a lot. Okay. Now, why are we relevant? Because we, as a company, we are a business-to-business company. So what do? We support other businesses. So that makes our role a little bit more important. I'll come to that point there. So what do? We enable different companies, whether it is an automotive company, it is a power distribution company, it is a power generation company, a company that creates smart cities, mobile infrastructure, mobility, the train system itself. So we are in the business of enabling those businesses. So it becomes very, very important for us to actually think about sustainability, think about how we can make these things happen. Okay. Again, urbanization, for the first time in the world, in the history of humankind, there are more people living in cities than in rural areas. Again, so all of these will tie in. So what does this lead to? This leads to congested cities. This leads to so many people being confined to that small space, and thereby leading to all the other problems that we are seeing today, whether it is air pollution, whether it is overloading of infrastructure, drinking water, anything of that sort, right? So these are all mega trends. And then again, we are in that business. I just skipped this, but then I just want to mention that, like we are #1 in digital grid business. Okay. Demographics change. Obviously, like the world is aging. The death rates have come down thanks to science and all the research that has happened in the past few years. And then, of course, the growth rate has also started declining. So net result, there are many countries which are slowly and steadily aging. So there is a huge shift in the demographics. Now, like you should be living under a stone if you have not heard of this. We have spoken about this. This whole symposium is about tackling how we can arrest this. Okay. Again, we do a lot there. Like we have a set goal that we will become carbon neutral by 2030. Okay. So now, with all of these things happening, and then I don't need that anymore. With all of these things happening, how do we, as an organization, look at this? How do we contribute to some of these goals that our customers also have? Right. The first thing, how do we use technology? Okay, and then I will come to emerging technology. How do we use technology? A very simple problem, and this is available on internet. If you go up, look up for California power consumption real time, right? So you will see there is a trend line that shows. Is the audio clear?
Yeah, it's okay. Please continue.
Okay. So you can clearly see there are different sources of power, and then there is one which is solar. And as the sun rises up, you see that it goes to its peak, and then is there California hot sun, and then goes down. Now the problem is, during this daytime, the amount of electricity generated is so much that the state of California cannot consume this, right? So now, but there are different ideas. People try to solve this in different ways. Now, what I'm trying to say is, like any energy that is generated by sun is extremely, extremely environmental friendly, probably the most environmental friendly energy source that we have. The problem is it cannot be stored, right? As the sun goes down, your energy consumption is still hovering around the same level, but then how do you handle it? Now, The problem is multifold. One is storage. Obviously, you cannot build batteries. The second one is the stability problem that it infuses into the grid, because now the grid starts acting a little different. It is no longer one source of energy, but multiple sources of energy. There are simple things that you can do. In fact, this actually the US grid does this. So what they do is, and you would probably, some of you might already know this, there are hydroelectric dams, right? So you can use this surplus solar energy to pump water up to the dam and then use it, and that is like potential energy, kinetic energy, like all of you know that very well, and then use it when the sun is not shining. So basically in the night, right? So that is not new technology. That's a very old technology, hundreds of years old. But what we are doing as an organization, and there are many other companies of similar nature, what we are doing is we are bringing all the innovative emerging technologies, right, to make sure that the grid is stable. Because there are multiple sources of power, you need to know how much of power will be generated. And this is where our entire AI ML faculty comes into picture, right? Because our data models can tell you how much of energy can be generated by this windmill, how much of energy consumption is happening. And these are factors that are decided by not 1, 2, or 3. There are multiple, n number of factors. So that is one example. Now, the second example is about the production. When I say production, manufacturing of goods. Now, manufacturing of goods, again, you can manufacture a particular equipment or any goods in hundreds of different ways, starting from picking the raw material to the way you design to the way you recycle even. Now, what we do as an organization is we provide these solutions, and this is what our customers also ask. From product, which is basically how do you design the product? So we call these twins, right? A digital twin. It could be a bottle of Coke, it could be a car, it could be a turbine. So how do you design this? And here you don't use any material. This is all done digitally. There are tools and there are products that we offer which can be used to design the entire product, and this is called product digital twin, right? So you not only design the aesthetics of the product, you also apply materials. You see how this particular product behaves under a certain condition. It could be, in case of car, it could be your drag. In case of bottle of Coke, how well does it withstand a fall, maybe like a small one, say maybe a 1 meter fall. How well does it withstand the extreme temperature? So depending on the nature of the product, you not only design the aesthetics of the product, but you also apply different forces, understand how this whole thing is. So that is step 1, right? Now, step 2, digital twin, is this product. Now also pay attention. Now, so far you have not even touched any raw material. All these things are being done on your computer digitally. That is why it's called digital twin. Step 2, now you have to manufacture this product, right? Now, while manufacturing the product, or to manufacture the product, you need a production line, basically, which is what we call factory, right? Now, that is production digital twin. Now, again, what we do is we go in, and even before a single brick is laid, we create the entire production, entire process. Now, it could be discrete. When I say discrete, like piece by piece manufacturing, like a car, or it could be a process industry, like cement, like toothpaste, like your F&B, right? So that is the production way. Now, then it goes into the market. It goes into the real world. Now, most of the organizations stop here. But then what we do is we go beyond that, and then we collect data from the field. Now, what kind of data? How do we collect? That is where all of the emerging technologies come into picture. It could be IoT sensors. It could be, innovative actuators, drives, whatever is available. We collect all of this data, and then we perform complex, advanced analytics on this. So now, product, production, and then the performance of the product itself in the field. Now, in this whole thing, so far, or at least say till the recent past, the customers were more interested about what would be the cost, right? How much would we be able to pass on to the customer? These were the driving factors. But today, the customers are increasingly asking us, how do we reduce the carbon footprint? In fact, there are organizations, and I'm sure some of you might be aware of this, there are organizations which give you accreditation saying this is the amount of carbon footprint that a particular product has. Now, we as business to business providers, we have to make sure that in each of these stages, we make sure that this product is having the least amount of impact on environment. So that is our digital twin story. As I said, the first one was more about grid and how do we handle it. And then the second one is about the product production and the performance digital twins. Again, like end to end. And what factors do we influence here? Starting from the raw material, what kind of raw material is picked? Who is the supplier? Like has it been sourced in a meaningful way, in a sustainable way, in a responsible way, right? And then from there, what is the potential for it to be recycled? How green is the product at the end of the life? It is okay to manufacture something today that is reliable, robust. Of course, none of those factors change. But then at the end of the life, how do you even recycle them? Starting from cars to turbines to anything that you might use. And soon, like you will have, just like when you look at a monitor or a refrigerator, you see energy rating. Soon you will have sustainability index also. So you might have 3 refrigerators which are common in every aspect, power consumption and everything, but then you might have 1 refrigerator that has lower carbon footprint than the others. Now, there is a mad rush among the customers in the advanced part of the world, like the developed nations, to buy more and more carbon neutral, environmental friendly equipments, even at the cost of paying more. Of course, like there are different dynamics in this part of the world, but it will soon change. So now, how are we enabling them? As I said, what kind of material, what kind of performance, all of this will come together. Okay. Now, then there is also a question of track and trace. Again, like you might have seen this in organic or responsibly sourced coffee and so on and so forth. But track and trace is becoming, again, a very, very important requirement from different customers. So when I say track and trace, now let's take the example of a monitor. Okay. So imagine there is a monitor that company A, company B, and company C, all the 3 have brought to the market. Now, company A might be using copper for cables from a particular vendor who has responsible practices, environmentally friendly practices. Now, what happens? The problem with this is, how do you certify? How do you validate that what they are claiming is indeed what it is? This is a big challenge. Now, again, I'm sure there are different approaches, but what we are doing is we are bringing in blockchain. So with blockchain, we are making sure that these distributed ledgers are created and then they become immutable. So every supplier, every vendor in the entire supply chain is certified and is given a particular value. So at the end of it, as a customer, you don't have to just believe the sticker, because that is what we do, right? If somebody says 5-star, we just believe that it is a 5-star product. But then now it is not belief, it is verifiable. So all you need to do is scan a QR code. It tells you who the vendor is, how did this source, and where did they get their raw materials from? How much of transportation did it take? Right? So you might have procured cable or copper for cable from Africa, and then you got everything assembled in China. So there is also transportation, and this transportation leads to certain carbon footprint. So now we are providing these solutions that you can make decisions, and these decisions will be made on facts, not on just a sticker. So now, like, again, this kind of track and trace can be done from food. Like you can, the tuna that you buy, or the packaged cheese, or anything that you buy in a supermarket, to a turbine, to an automotive, anything can be verified and tracked by the technology that I just mentioned. Of course, it is all very, very complicated, because you have to collect real-time data, and for collecting real-time data, you have very good IoT sensors, great connectivity, pull the data, and then put that in cloud. Now, there are different companies which have great algorithms to do predictive maintenance. There are algorithms that can tell you, what will happen in terms of power consumption, in terms of so many other things. So basically, these are all coming together in one point. Then I'll probably take 5 minutes, and then I'll stop for questions. The question is, yes, you guys are doing all of this. When I say you guys, organizations of ours, our type, doing all this, but then will that not itself have an impact on environment? I'll give you a very simple example. All of you probably have been following the rise and fall and the roller coaster ride of Bitcoin. Now, I was just reading somewhere last week, Bitcoin itself is extremely, extremely energy hungry. In fact, Bitcoin mining, if it was a country of its own, just the Bitcoin mining operation was a country of its own, it would have consumed more energy than the whole of Argentina. Just imagine, like, this is something that is not even physically possible to see, look, feel. It is totally digital. And there are a bunch of computers which are churning algorithms. And we as humankind are spending so much of money, so much of energy on something as intangible as a Bitcoin. Now, I'm not disputing the value, neither am I saying the technology is bad. No, nothing of that sort. But just take a pause, try to understand this, which is totally digital in nature, is consuming more energy than the whole country of Argentina, right? Now, as I said, emerging technology, yes, like any other tool, can be used for the betterment of the society, for making sure that environment is protected and we all prosper. Or when you try to do something, it is also possible that you might end up, harming the environment in one way or the other. But I'm a big believer in the collective spirit of humankind to make things better. Now, all of these technologies, if you can just recollect what I spoke about, are nothing to do with, breakthrough science. When I say breakthrough science, it is not about generating energy from hydrogen. It's not about quantum computing. It's not about something that you have to go into the lab and start tinkering. I'm not undermining, but then it is not breakthrough science that comes out of labs. These are things that we are doing within the realms of digital technology, the things that are available to us, right? The things that are available to you, me, all of us. It is not like you and I cannot go into a lab and then start creating, like hydrogen cells. But you and I can go back and start working on a great track and trace algorithm. you and I can go back and start working on how the carbon credits are authenticated. Do they really mean something, right? So so that is what my submission is. Like the emerging technologies are making things more efficient, better, verifiable, reduces pilferage, create a better product with lower carbon footprint, which are environmentally friendly. Of course, there is another horizon where you make things, where you build things like hydrogen cells or quantum computers, which take very less energy, or like there are so many other things. I didn't talk about that. I just spoke about the digital technologies which are accessible to you, me, which are current, which are present, being implemented, which you will see in the coming months and years. So with that, I'll take a pause, and if there are questions, I'd be happy to take the questions.
Hi, sir. This is Sai from Amrita. So I just have a small question. You spoke about digital twin technology.
Yeah.
Can you brief a little bit about what exactly Siemens is looking in for this technology?
Sure. So as I said, Sai, we do it in 3 steps. The first step is the product twin. And when you design a twin, there are 2 things that you consider, right? One is the aesthetics, where you actually design it, right? For example, a bottle of Coke. You need to design the contour. You need to know that it has to hold 250 ml or 500 ml. So that is the aesthetic, the look and feel. So we have the entire product suite that can be used to do this. That's the first thing. The second and the more important one, I'm not saying the first one is not important, but the more important one is the physics around it. In a bottle of Coke, it might be very simple because, as I said, it might have to withstand those extreme temperatures. It has to withstand those falls. But then if you switch to an automotive, take a car as an example, then the digital twin becomes extremely, extremely complicated, right? So you will have to decide what kind of material, what kind of drag, the vibration, how does it fit in, what kind of temperatures. So these things, and like even crash, when there is a crash, what happens? Which part of the car absorbs the impact? So all of this, so there is a product suite that Siemens has for the product digital twin. Similarly for production. And these days, people will not just say, let us build a factory. The whole factory is simulated on a computer. Even before the first brick is laid, as I said, you will know how many liters of Coke will be manufactured, how many bottles can be filled in every minute, how many cars can you make, and how much of cost will you incur, down to the last unit of electricity that you will consume. Even before the first brick is laid, you can do this. Again, Siemens offers all of this. The third and the most important aspect, which is so far forgotten, not forgotten or maybe less pampered cousin, is performance. You take a car and then you introduce it into the market. Now, what happens after that? Unless there is a serious flaw, the car needs to be recalled, you will not know. But today, with the advent of all of these new technologies, you don't have to really worry about that, because we as an organization, we have solutions which collect the data from the field, from the factories, bring it into one central location in the cloud, and then do analysis on that. So we will be able to tell you before a problem occurs, not just with your product, but even in the production line. So this end-to-end life cycle of the product is what we manage, and we call it PLM, Product Lifecycle Management Suite within Siemens.
Thank you, sir.
Any other question? There is one that I can read. What would be the impact of energy efficiency improvement of an appliance or a product on carbon footprint and embodied energy of that product? Will it tend to increase? Meaning I will probably type the answer after this thing is done. But like I don't believe carbon footprint will increase just because you are tweaking the other aspects. On the contrary, I think as we go forward, the carbon footprint will only start decreasing. It is not that we do not have the ability, the technology that to make it happen. It is so far cost was the driving factor. And I believe, and I could be wrong here, we can all probably exchange information after 3-4 years, but I sincerely believe the world is moving towards this kind of awareness. I can recount from my own experience being a South Indian, like even 10 years ago, crackers never had this child labor not used. That label never existed. But today, if you walk into any cracker store, of course, crackers themselves are highly debatable. I'm not getting into that. But I'm saying people actually pay attention to something that has been responsibly manufactured, where child labor has not been used. The same thing will happen, according to me, even in developing economies like us in the future. Okay.
Dr. Chetan, I have a very small query.
Sure.
Of course, your concern, your cement multinational has been dealing with how not to degrade the environment, right? That is the primary concern. But my query is, whether are you dealing with certain organizations who are actually restoring the degraded environments?
Yeah, Dr. Sudish, I think that was you, right?
Yeah, that's right. Sudish Wadawan.
Yeah. So two things, right? Say the restoration itself, globally, the most widely done restoration is carbon credits, right? Now you can always ask me how do you classify this as restoration? But across the world, many multinational companies, to offset their carbon footprint, what they do is they go back to carbon credits. So they will probably fund some farmer, some company in the middle of the Brazilian rainforest or Indonesian rainforest and say, like, I will continue to emit carbon. It's not that I will not emit carbon, but you will compensate by planting 10,000 trees or restoring 50,000 hectares of forest, right? So now we as an organization, we are not in that business. So we do not do that. But when it comes to our own factories, we have quite a few of them spread across the world. Our own factories, our target is to go carbon neutral by 2030, and there we do everything. But like we are not in kind of reversing restoration kind of business.
Okay, yeah, good. Thank you very much. It was a great presentation. I'm reminded of one small change that you mentioned about this crackers fireworks business.
Yeah.
You see, most of these functions, government functions, there is a tradition and a ritual of offering flower bouquets. Now, instead of that, the practice now is to issue a certificate that we will plant so many trees on your name in some plot, so that the green restoration aspect is also taken care. I mean, this is just to add on what you have been mentioning. So thank you very much. It was a very, very illuminating, very inspiring talk. Thank you very much.
Thank you. Thanks, everyone. Thanks for inviting me.
Yeah, great. So our next speaker is Professor Pascal Perez. He's an Australian. He's actually Director, Smart Infrastructure Facility, University of Wollongong, Australia. And he's got a lot of interest in working on various aspects . Yeah, he's actually having a lot of research interest in infrastructure related fields such as water and energy efficiency, future transport and mobility, smart cities and communities, as well as infrastructure system engineering and logistics. He's a specialist of integrative infrastructure modeling social technological transitions. Professor Pascal is a fellow of the Modeling and Simulation Society of Australia and New Zealand, and a fellow of the Royal Society of New South Wales. He is a member of the Executive Council of IoT Alliance Australia and a member of the International Advisory Board of UK's Collaboratorium for Research on Infrastructure and Cities. So Professor Perez is highly decorated, highly experienced expert with us. So I'll hand over the stage to you, sir. Thank you very much for joining our international symposium. We are really honored. Thank you. Please carry on with your presentation.
Thank you, Dr. Kumar. Thank you for this introduction. Very kind. I'll show you. I'll talk about a project that we're running actually in Australia, but I think its deployment and the solution it provides could be deployed anywhere in the world and in India in particular. So let me share my screen with you. I hope it's going to work. Can everyone see my screen?
Yeah, we can see it. Please enlarge it to full screen.
Yep. That's it. It should be good now?
Yeah, it's good. Good. Please
Perfect.
go ahead.
So yeah, this talk will talk about the flood-aware system we've put in place in our city of Wollongong in Australia. But I'll present first the issue we have with flash flooding in our region and the bigger project that we've implemented with the municipalities, the local councils in the region. So for the ones who are not entirely aware of where Wollongong and the Illawarra region are, we're located in Australia as per the left-hand side map here. We located in the state of New South Wales as per the blue arrow, and on the coast of New South Wales, so south of Sydney. Wollongong itself is 90 kilometers south of Sydney. And you can see from the right-hand side map, the region is characterized by a long coastal plain. And the key characteristic here, as you can see on the photo, is that we bordered by what we call the escarpment, which are tablelands with very steep slopes. It's not very high. Let's say it's 500 meters of elevation, but very steep slopes. And as you can see, the coastal plain is very narrow, especially where the capital, regional capital, Wollongong, is located. So in this configuration, no surprise, we have regular and very serious flash floods to deal with. To give you an idea of the region, it's 750 square kilometers in total. We've got 310,000 people living here. We've got a pretty big industrial port, Port Kembla, an export-import port, and BlueScope Steel as a steelwork manufacturing entity, even if the steelworks, like many other parts of Australia, the industry has sized down due to the competition with Indian competitors in particular. So that's for the region. Now, because of this configuration I've just mentioned, we've had to experience, I've been in this region for 10 years only, but over the last 50 years, the region has experienced 3 extreme floods, in particular the 1998, as you can see on the pictures I'm showing you on the right-hand side here, and more than 30 serious floods as per Bureau of Meteorology classification. So this means that Wollongong has always needed early warning systems and mitigation strategies for saving assets, infrastructure, and lives. And so we were very lucky. So that was 98 as well. We were very lucky 2 years ago when the federal government awarded a grant for a project that was a collaboration between the local councils in the region, the University of Wollongong, where I work with the Smart Infrastructure Facility, but also private partners like Lendlease, which is a big building company in Australia. And the project's called the Smart Waterways Management Project. So there are 7 components in this project, and I'll really focus on 3 of them only, but I'd like to mention all of them very quickly. So the first one that I'm going to describe a bit more later on, Stop Block, is about trying to use new technology, in particular AI on the edge, smart video analytics, and fusion of smart data in order to identify and, if possible, predict stormwater culvert blockage, which is a main issue, and I'm sure in India it's the same. This is, you can have the best hydrological model in the world. As soon as on the field you've got a blockage of a culvert somewhere or a bridge, then that's where all your model is going out in the water, literally. And the people on the ground are just left with themselves to try to find a solution. So try to predict what's going to happen with critical culverts. The second component I'm going to mention very briefly as well is GoFlow. And because we're a coastal region and Wollongong is a coastal city, all these rivers we have estuaries and lagoons. And most of these lagoons have intermittent closing and opening due to the sand berm. And as if some colleagues on this talk have some background in hydrology, you know that the fact that the sand berm can close or open at the wrong moment might have critical consequences on the severity of a flood upstream. Flood aware, that's going to be most of my talk, is really the integrated system. So that's a model that takes on all the smart data we're collecting through Stop Block, GoFlow, but also more sensors as part of flood aware. And we try to predict in real time what's going to happen in the next 2 hours in terms of flooding. And here I'm again, for the hydrologist in the room, it's a model that tries to bring together hydrology and hydraulics at the same time in a real-time modeling process. Pollution stop, something I won't talk later on, but that's something that was in particular asked by our colleagues from Lend-Lease for the new developments in the region. They have to establish by law gross pollutant traps, GPTs, in the new developments. And the maintenance and the monitoring of these traps is also it's often an operational burden because they have to send people with their cars and their equipment and check, and most of the time the trap is okay. So what we've just done is to put automated sensors in there that can tell them remotely and automatically the level of debris in the trap, and sending the people when really the trap has reached a critical level of debris in the trap. The smart school is probably the only component of this project which is not an operational one. It's a communication and outreach program because we wanted the community of the region to be really embedded in the project and not just hearing about it through signs on our equipment or pieces in the local newspapers or radio. So what we've done over the last year and a half is to work with schools, with the students and their technology teachers, in order for the kids to be able to build sensors, very simple ones, temperature or water level for the best groups. And then when the sensor is built, they can hook them on to the whole system. So the serious project, their sensors contribute to adding more data to what we're doing. So that's a way of interesting and engaging with the whole community. Quality watch is so most of the project is about water quantity and the flooding and inundation, but we also have one component about measuring remotely and in real time water quality in various rivers in the region. And of course, last but not least, all these smart sensors, they need to communicate the data through a communication network. And we've chosen very early on, actually 4 years ago, the university decided to create a LoRaWAN network for the region. And we're probably the only university in Australia that has not invested only gateways for their smart campus, but we decided that it was our giving back to the region and the communities in the region. And so the university is managing and maintaining the 10 gateways that constitute the network for the whole region. So if I take you now through the technology a bit more precisely, so we've got all these sensors, water levels. There's a LiDAR for the sand burner that I'm going to talk to you later. There's rainfall gauges, and most of these sensors talk through the LoRaWAN network, so the gateways, and all this information is then processed through our data broker and cloud data management system. It's mainly LoRaWAN, not only. We also have 4G solution for especially the smart cameras I'll talk about later on. LoRaWAN has a lot. I love LoRaWAN and the whole team love LoRaWAN, but LoRaWAN has limitations, and especially when you have to deal with two-way communication or relatively complicated packets of data. And so in this case, the information management system deals with the 4G communication and the LoRaWAN at the same time. And then, of course, we've got all the backend dashboards and mapping. So starting with stop block, one of these 7 components I've mentioned. So it's about stormwater culvert blockage detection. As you can see in this photo, unfortunately, because it rains quite a lot in Wollongong and nature is very fierce and the floods are very fierce as well, we always have to deal with culvert blockage. And I'm sure in India, many places have to deal with the same problem, where a culvert is a culvert, but the block culvert is something we can't predict the behavior of. This is what's happening afterwards. So there's 2 aspects to the blockage of culvert and predicting better and faster the blockage. Is during the flood, yes, we need to understand what's going to happen in the next 2 hours, but also after the flood, having a state of all the critical culverts in order to send the teams, the operational teams, to clean up the most critical or the most blocked culverts as the system provides the information about. So what we're doing for this component is using state-of-the-art artificial intelligence, computer vision, edge computing, and IoT techniques together in order to detect and predict culvert blockage. So how it works, so for the ones who don't know what a culvert is a big pipe you're going to have under a road, under a railway track, as we have also in Wollongong, or under even built environment when there's no way for the stormwater to be directed at the surface. And this pipe then will discharge later on back to another channel. So culvert blockage happens upstream. So what we have upstream, as you can see on the right-hand side here, is a camera pointing at the culvert and try to understand the level of blockage and the type of blockage automatically and remotely. And so this is what we call the visual blockage. But again, for the hydrologists in the room, we also need to relate visual blockage with hydraulic blockage, which is a critical one in terms of flooding. And to do that, we're doing data fusion. So we've got a smart water level located upstream, a smart water level located downstream of the culvert. And so these 2 water levels send us in real time the water level upstream, downstream, so we can calculate in real time the difference of water head, and we can analyze at the same time the visuals from the smart camera. All this is processed on the edge at the level of the camera. We've got an edge computer using an NVIDIA microcomputer calculating all this information. This is where the 4G is very important for the camera, because the camera can pick up the signal from the water levels who are discussing with the camera through LoRaWAN only. So this is a pretty sophisticated system. So the way it works is relatively simple at the level of the camera. When you think about it, the camera is pointing at the upstream part of the culvert. First, the camera detects what is the culvert, whether it's a circular one, whether it's a rectangular one, and then the level of blockage that you can see on the right-hand side. And then there's the third step, which is not on that slide. It's okay, with what I see now, I understand this is 30% blocked with this type of material. What's going to happen in the next 5-10 minutes, half an hour, 1 hour, depending on the information I have from the water level sensors. So that's where the data fusion happens. So the first 2-step detection classification is already operational. The third stage, which is the prediction and the data fusion, is still an ongoing part of the project. Going now very briefly to the second component of this project, the GoFlow component. It's an automated and remote monitoring of the sand berm. So sand berm is a sand accumulating at the entrance of your estuary, lagoon, or coastal lake. It is very important for what we call in Australia, I'm not sure where you've got the same name in India, intermittently closed lakes and lagoons, ICOLs. And there's a lot of protocols in place mandated by the government for local councils, so the municipalities, to make sure they manage properly their ICOLs in terms of opening and closing of the mouth of the river. The issue is that if you don't open your, open most of the time, your sand berm quickly enough when you've got a flooding, you have the risk to create even a more critical flooding upstream because you're accumulating water without this water being able to flow into the ocean. So what we've done there is to use a LiDAR camera, as you can see on the top of this gazebo, pointing at the sand berm. And there's an edge computer associated with it. So the LiDAR gives us, as usual with LiDAR, a cloud of points looking at the surface of the sand berm. And the edge computing gives us critical alerts, and only the alerts are sent to the municipality for action. The little spikes you can see on top and around the camera, around the LiDAR box, is to fight our worst enemy, which are not vandals, but seagulls who love flying around the LiDAR, and when they fly in front of the camera, in front of the lens of the LiDAR, it's always problematic for the data. So that's the kind of data that the camera is picking up, and this is processed at the level of the edge computer, and we give critical reference levels that the councils have in their procedural books, and as soon as part of the sand berm is going above or below a certain level, then a specific message is sent to the municipality, and then action can be done. And so finally, we're going to the integration part of this project, so Flood Aware, which is at the same time a data management system and a real-time predictive model. So it's real-time and data-driven flood modeling. This component is for the moment operational at the level of a small catchment of 22 square kilometers called the Ferry and Cabbage Tree Creek catchment, which is at the heart of the Wollongong city, so bang in the middle, so highly urbanized and with massive consequences each time we've got a flash flood that has been triggered in particular, again, by blocked culverts. In order to run the model as a data-driven model, we've got 20 smart water level sensors along so that's all the red points you can see on the right-hand side of on the picture there. Interestingly enough, we managed to have a real-time feed from the Bureau of Meteorology, BOM, who have produced since 2 years ago a product called Rainfield 3, which is a radar reflectance data set they can provide in real time now every 5 minutes to the councils who subscribe to the data feed. And so now we've got a link we're creating with this Rainfield 3 from the Bureau of Meteorology, providing the reflectance radar data in real time. The model itself is an agent-based modeling architecture using the Gamma platform. And Flood Aware, the objective is to provide a 2 hours prediction every 5 minutes based on this real-time data I've just mentioned. So if we go a bit more in detail on how it works, so first is the data, of course, the data management. So it's real-time water level, as I mentioned, real-time rain gauges, real-time reflectance data from the radar from the Bureau of Meteorology. We've got a flexible file format and access in use, and it's a location-based query in the database by the model. The second component itself is WBNM. That's the heart of it. That's the hydrological and hydraulic model. We're very lucky that because of the problem of flooding in Wollongong, This model has been, as a semi-empirical model, has been designed, trialed, and tested over 20 years for the whole region, and it works very well. So it means it works very fast because it's semi-empirical, and it's very well calibrated for the region. So we've just embedded the code and optimized the code of WBNM into the Gamma architecture. We calculate runoff for each subcatchment. We've got 48 subcatchment to these 22 square kilometers main catchment. And again, everything runs in 5 minutes, less than 5 minutes, actually, far less than 5 minutes. Then there's the optimization. How can it work in 5 minutes as an hydrological and hydraulic model? Well, that's where we spend most of our time over the last 2 years, try to optimize every bits and pieces we could. The first optimization is the processing of the rainfall data from the tiles from the Bureau of Meteorology radar data, which took us a lot of efforts to optimize the way we treat the tile in real time. We pre-calculate coefficient of rainfall volume, and now we're at a level where we're relatively well satisfied with the speed. And then that's really work in progress, but this is where we want to go, and that's where this model one day might become a data-only model, a data model, and no longer even a database model, where when we're going to have acquired enough data from our water level sensors on the field, from the radar data, from the rain gauges we've got on the field, smart rain gauges, we're going to be able first to recalibrate the model on the fly. So depending on the differences between the simulation in real time and the water level and the rainfall measured in real time, we're going to be able to recalibrate through an AI module all the parameters for the model. Again, this is not done yet because we will need a lot of data to do that, and we don't know when we're going to be able to have enough data to do it. And of course, when all this is done, you need a dashboard to check all that. So again, this is something we're improving, in discussion with our colleagues from the councils, from the municipalities. So we've got a dashboard providing in real time, available to everyone, the water level at the 20 sites I've mentioned. And we have started embedding, that's just a mock-up version of the visualization of the model. So that's the catchment. On top of it, you can see the tiles from the radar providing the amount of rainfall for a given tile. This is translated into rainfall for each of the subcatchment you can see at the bottom. And the blue color tells you how much water is accumulated in each subcatchment. So the future, we need to have live mapping flood consequences. For the moment, we can predict flooding. Now we need to go to the next step in terms of operation and action, which is a consequence mapping and modeling. Displaying effects of flooding on roads, application, providing essential notification to emergency services through mobile applications, crowdsourcing information for any people living in the region to be warned about what might happen in the next 15 minutes or half an hour, and integrating culvert blockage and entrance conditions data into the modeling itself rather than just for validation. And this is all from me. Thank you for your attention.
Thank you. Thank you very much, Professor Pascal. It was a very nice, very nicely presented. You were so calm and calculated while making your presentation. We are really surprised. You're so confident, and very quietly you have shared so much of information and technical knowledge. And now I'll request for a few questions if there are any. Well, I can raise a small query, that is, are there any engineering solutions? Have you looked around for alternatives? For example, this culverts blockage. In India, I know of certain experiences that wherein, this semi-arid conditions and desert-like conditions, the flash flood is a characteristic feature. So there we don't build bridges and culverts. We simply make causeways, The road level is just touching the stream level, and there is no blockage of culvert business. Have you thought about such alternatives, such engineering
Yeah.
solutions?
I wish we could. I started my career a long time ago in Africa, and that's what I was doing. That was my first job as an engineer, build causeways, and I love them. Unfortunately, as I mentioned, this is a heavily built up area now. It's a city,
yeah.
And so we've got because it's, as you've seen, it's an elongated region. We've got two motorways, one rail line, which is the regional rail line, so a very important one. And they're going north-south, and all the flow of water is going west-east. So it's the perfect storm, unfortunately, and we need culverts everywhere.
That's really great. Other aspect is how about the escape routes? Once you know there are certain hotspots which are really vulnerable for such flash floods. So have you identified the escape routes or safe shelters for community to shift?
Yeah, very good point. So that's, as I mentioned, that's part of the consequence modeling we start working on with our colleagues from the municipality of Wollongong. And this is work in progress, because there are I don't know in India, but in Australia, every council has to have these plans for evacuation. The problem is that these plans most of the time have been drawn from traditional hydrological and hydraulic modeling, which again didn't take very much into account critical culverts being blocked and then the flood being diverted from one place to another one. So that's where it's going to become over the next, I would say, 12 months, an interesting work with our colleagues from council to say, well, according to the model, you've got a chance, if this culvert is blocked, that all your flow is going to be diverted here. Do you have a plan for that option?
Yeah, okay, thank you. Any other question, please? Yeah, but there is another aspect since we have another couple of minutes before we begin with the next talk. That is the watershed management, whether we can build small reservoirs upstream, the catchment areas. This will be just to, give some more lag time for the actual flow rush of water.
Very good point as well. Yes, the council, to be fair, has done as much as they could, but as you've seen on I could show you only one photo. We're talking really an L-shape kind of topography. Okay. So it's very hard to have reservoirs of decent size and volume just at the foot of the escarpment. And then, unfortunately, because of creeping urbanization, it's very hard to have enough space now in the city to create this. So there are few parks that they've transformed literally into these small reservoirs. But yeah, there's a lot of constraints for the council. Yeah, but it's a very good point.
Thank you very much, Professor Pascal. It was a great listening to your talk. Thank you. Well, with that, now we'll come to the fourth speaker. Is Professor Rajiv Ranjan, a very highly distinguished professor and highly accomplished, I would say, because his biodata is such full of such accomplishments. He is a university chair professor for international things, and basically, he's Indian of Australian British. Sorry, yeah, he is an Australian British computer scientist, and he has been actually working on a number of very well funded projects in emerging technology.
today I'm going to talk about some of the work we are doing in Newcastle Urban Observatory, which is UK's one of the largest and most diverse IoT test bed, and see how we collect data and what kind of application we are working on those. What kind of smart city application we are developing using that data, and while doing that, what are the research challenges that we are trying to solve. So I'm going to highlight those things as part of this talk. So that brings me to the title of today's presentation, which is New Horizons in IoT Workflows Provisioning in Edge and Cloud Data Center, using the osmotic computing approach that we invented at Newcastle, along with collaborators from Cardiff University, TU Wien, and Swinburne University of Australia. So I'm going to give you a detail on all these concepts as part of today's talk. So this will be my outline for today. So first, I will give a brief intro to IoT landscape, then I will look into the application context of IoT, and then the interlink concept of how IoT and big data are related. They're not separate things. And then we will look into how we as a distributed system researchers can do in this complex ecosystem IoT application and big data science context, and then what kind of new computing research we can do in this new distributed system scenario. So I will be talking about that. And to that end, I will be talking about the research challenges that we are solving in that context. So I think as most of you are distributed system researchers, so we know that the next trend for our community is Internet of Things, big data, and using both of them to enable smart application. And those smart application, as you see in this slide, that spans across multiple disciplines now. So as you see, if you see from the right-hand side, it goes all the way from smart grids, mining, industry 4.0, smart agriculture, smart transport, connected cars, healthcare, smart home. So you name it, every domain are now using IoT sensors and actuators to make their discipline more smarter, automated, and maybe to some extent autonomic. So that's the whole idea of using IoT system to make the system autonomic, self-healing, similar to how human body or any organism body works. So that's the key enabler of IoT is to make this physical environment, which used to be manually and managed in a static way. How can we manage them in autonomic and intelligent way through intelligent IoT sensing and actuation? So this is the broad overview of like what I'm to say here is the IoT is now being used or being trialed across different disciplines. And that brings me to, okay, so all these smart meters, so water management, smart grids, smart agriculture, they are the application domains. However, they are just where we want to make impact, but the real research for us, for the computing discipline, that lies on the right-hand side, you see here, to really enable IoT application, we need to bring across multiple distributed computing paradigms, right from edge computing, software-defined networking, cloud computing, and virtualization and software as a service. All those things need to come together in different shapes and sizes if we want to enable application across any of those disciplines. And it's very complicated. It's quite complicated than what we used to work in early 2000 about hosting a web application in the cloud data center. That is a very simplistic case of distributed computing application. But if you want to move into the smart IoT applications where you have real-time sensing and actuation, those simple application deployment models which was supported in early 2000 when the cloud computing just evolved in 2005 are not going to work. For example, we cannot take a Hadoop or Apache MapReduce programming model and say we can enable whole IoT application. It's not going to do that. Obviously, something like Apache Hadoop or MapReduce will be one of the small component of IoT application, but on its own, it cannot solve the whole IoT application management challenge that I will discuss in my today's presentation. So obviously, as I said, IoT and big data, they are interrelated concepts. They are interdependent. So the current prediction from IDC says that most of the big data in the next 5 years will be so IoT will be one of the biggest contributor to the big data landscape over the next 5 to 10 years. Of course, this prediction goes till 2025, but we can extrapolate that to 2030, 2035. So as more and more disciplines adopt IoT solutions, we will produce more and more big data. And as you see, by 2025, the prediction is saying IoT related application are going to generate 160 zettabyte of data. And that's too much data. Even if we want to, we are going to provision all the public and private cloud data centers that we have available from Microsoft or Amazon or anybody else, we are not going to be able to store all this data. So what that means is we need to find new data management and resource management algorithms that can do real-time decisions based on this data and then just throw the data, because we can't sit on the data like before. We just need to use the data for our decision making and then move on. And for that to happen, we need new algorithms and new research to enable that thing, because we are going to have a lot of data as you see from this prediction. So this is that was one prediction, but however, at Newcastle, as we run our own test bed that we call as Newcastle Urban Observatory. So some of the numbers I show on this slide can tell you that how big is this big data. And this data that I'm showing here is just for Newcastle IoT testbed. It doesn't include any other cities or any other towns or councils in UK, just for our Newcastle area. And as you see from this one, we have deployed across the Newcastle almost more than 3,000 types of sensors. And as of now, we have more than 1 billion data points, and every minute we produce 2,000 data points from those deployed sensors. And it's growing and growing by the day as we deploy more and more sensors. And if we increase the data sampling frequency of the sensors, the number of observation per minute is going to increase as well. And in our testbed, we collect almost 64 plus variables of data across different application patterns like weather, traffic, water flow, water quality, people flows, air quality, energy consumption, smart building, you name it, we collect all those data. We also work with Newcastle City Council, and we have deployed more than 250 kind of CCTV cameras across the city to monitor the traffic, and from there we get millions of images. So what we are trying to say here is, okay, so big data is just IoT is not a hype. We have a real world example at Newcastle that says that actually big data for IoT is a real problem. And then we need solutions to solve it. And this number actually shows you that example that even for one city, which is instrumented with IoT sensors, you will end up with a lot of data. And we need new solutions to be able to process those data in real time so that we are not being required to store the data for a lot of time, because we are not going to be able to do that. Obviously at Newcastle University, we use this data for many kind of application, from smart city traffic planning to energy management to building management to flood and disaster management to air quality monitoring management. So our School of Civil Engineering, as Professor Zoom might know, is very, very strong in environmental hazards, environmental monitoring in urban environment. So we as a competing school, we work with School of Environmental Science and School of Civil Engineering and enable different kind of application in flood management, landslide, air quality, using this urban observatory data that we showed you. So now our challenge is what kind of distributed computing infrastructure we can build for this environmental science or civil urban infrastructure researchers, so that they are able to use this data in real time for different kinds of applications, such as flood management or landslide management or air quality management. So we take that as the motivation to motivate our next generation distributed computing research. Right, so this is just one of the example. We use urban observatory, CCTV image, we use social media data to detect real-time flash flood in Newcastle City Center. For example, this is one of the tunnel in Newcastle City Center, and this happened in, I think, 2013, when we had a flash flood in Newcastle, where the tunnel got flooded and people were not made aware of this flash flood, and as you see, a lot of people were stuck in that flood. So we are developing solution based on monitoring the CCTV images and the water level sensor and social media feeds to be able to detect this flash flood before it happens, and then send warning signs to the drivers in that area. So this is one of the application which is funded by, one of the project funded by National Environmental Research Council of UKRI Research Council, where we are looking to use urban observatory data to develop real-time flood modeling system. This is just one of those examples. Right, so that was the application context, but of course we are computer science researcher, we need some computer science motivation, why we want to do this new kind of research. So traditionally, around 2013, 2014, when this IoT came into existence, the most of the IoT data processing paradigm were cloud-centric. So what I mean by cloud-centric is those IoT data processing paradigms such as Amazon AWS IoT, Azure IoT, Google Cloud IoT that you see on the right-hand side, they required all the IoT sensors to send all the data in real time to the centralized cloud data center. So obviously that's okay when you have few sensors like 10, 20, 30, 100, but that's not okay when every city is having thousands of sensors. Just imagine every city sending millions of data points every minute to this centralized cloud data center. So there are many problems with that. The first problem is wasting of bandwidth. So the issue is you do not need all the data all the time. So there's no point having a computing paradigm where you have to send everything to the cloud all the time. So that's leads to waste of bandwidth. And second problem is high latency. So based on the network uncertainty, the network protocol, you can have variable level of latencies with IoT data. And why that is a problem, I will be covering in my later slides. Why IoT networking is challenging, and we need some way to manage it. It's not a best effort. It's not, you cannot ensure that IoT network always give you good latency or constant latencies. It always changes because of the mix of IoT protocols and networking architecture, which is implemented by different IoT systems. So this paradigm, which was supported by these big companies, didn't work, doesn't work for real world IoT applications. So putting all this thing together, so we came up with this something called osmotic computing paradigm that actually glues together this IoT layer, cloud layer, and edge layer. But of course, this is conceptual one. Now we need to look into what kind of research we need to do to actually enable this vision of osmotic computing. So I will go into that. So now before I go into those osmotic challenges, I want to highlight that at Newcastle University, we have developed something called abstract IoT data analysis patterns. So for example, if you want to create a flood modeling application or air quality modeling application, you as a researcher, say you're from civil engineering, you need to know what kind of data analysis patterns I need to create my application. That's the first question. So I need data capture, I need data store, data inference, data filter, data aggregate. So what we did, we interviewed the different domain experts from healthcare, smart cities, industry 4, and we come up with what are the different data analysis patterns they need to deal with in their IoT application. We captured that requirement, and from that requirement, we came up with abstract data analysis patterns and abstract data flow patterns. So data analysis patterns means that what operation you're doing on the data, and data flow pattern means how data is transmitted across the layers. So as you see in this one, data flow pattern includes edge to edge, edge to cloud, cloud to cloud, cloud to edge. And we then validated our data analysis patterns and flow patterns across different kind of application. If you want to know more about that, you can refer to the paper given in the below in the slide, and that gives all the details about that. So for example, we validated our data analysis patterns in context of air quality modeling project, which is funded by Research England at Newcastle University. So for example, the workflow for air quality modeling includes you collect data from CCTV and sensor, then on the you use filter, convert data, remove anomalies from the data, then you use some kind of image processing model, then you use air quality model, and then you visualize the results. So these are the human readable analytics you want to do in air quality modeling. Then we converted, and we can capture those using our abstract patterns, like CCTV can be mapped as a data capture, filter convert can be mapped as data aggregate, data filter, data translate, data inferencing, and air quality model can be mapped as data inferencing. So then once you capture the abstract pattern, then the next point for you is to convert those into cloud, edge, and IoT microservice and bring it together. Similarly, we have validated our abstract data patterns for flood modeling workflow as well, as you see in this picture. And you can use our patterns to create as many different kinds of smart IoT application that you want. Obviously, when you develop this kind of pattern, you want to do certain user study and say whether these patterns capture the requirements, as you see in this picture on the right-hand side. Most of the domain experts with whom we validated our data flow patterns, more than 80% of them agree or strongly agree that our data analysis patterns and the data flow patterns capture their requirements. So we believe that the data analysis pattern that we developed is quite generic, and it would be used across different IoT application disciplines. Right, so that was in terms of IoT application graph composition related research challenges. Now, coming to more traditional distributed computing research issues, one of the hard challenges, how do we characterize the performance of microservices? For example, if I'm to deploy a microservice at the edge layer, at the cloud layer, or the IoT layer, how do I do the performance characterization? And why, as compared to traditional distributed benchmarking research, why this is hard? This is hard because each of those layers, IoT layer, cloud layer, they have different performance goals. If you see in this slide, so the network stability, throughput, optimality, routing delays, fairness in network resource sharing are some of the important parameters for the edge and the cloud layer. So if I'm going to deploy my microservices on edge and cloud layer, I need to benchmark my microservice for this parameter. Similarly, if I'm going to deploy my microservice on the cloud layer, I need to benchmark it for response time, platform scalability, reliability, virtual service utilization. And based on how many microservices are part of your application graph, you have to do that for each of them. So as you see, it becomes more and more challenging if you really want to optimize your microservice deployment on this 3-layered IoT infrastructure that we call osmotic computing. And each of those, you have to repeat and calibrate the performance of those microservices. And then it's also dependent on what kind of computation you are doing inside the microservice. If you're doing simple aggregation and statistics, perhaps they're easy to benchmark. But if you're doing some machine learning or AI technique inside the microservice, then that's harder to benchmark. So it just increases your complexity more and more. So going back to literature, of course, literature has certain benchmarks that you can use. For example, you can use TPC-X IoT to benchmark data aggregation pattern on the edge layer, or you can use Google ROAD for linear load kernel for benchmarking stream processing queries. But what is the problem? The problem is these benchmarks only represent performance of a specific kind of IoT workload, like stream processing or database workload. They don't represent the behavior of IoT graph, which can include a combination of those. So then what is the solution? The solution is we need to identify and collect this kind of different suitable benchmarks. We need to connect them either hierarchically or logically, and run them together to generate a real-time conclusion about performance of our IoT graph across the 3 layers. So we have a project ongoing with that. However, doing real-time benchmarking on real infrastructure is hard because of many reasons. Those reasons includes how do you replicate different kinds of IoT protocols like Wi-Fi, 4G, Bluetooth while benchmarking? How do you scale your benchmarking experiments to thousands of devices or thousands of servers? That's also very hard in real infrastructure. So obviously you can do real-time, real infrastructure-based performance characterization. It's not impossible, but it's very hard, and it's very hard to generalize. For example, no one will give you access to the IoT testbed to do this characterization. For example, at Newcastle Urban Observatory, we provide people with our data, but we don't give them our hardware to run their experiments because it's our production environment, and we cannot just lease that to students or researchers to benchmarking. So it becomes a problem if you want to use real infrastructure for your benchmarking. To solve that problem at Newcastle University, we are looking at a project called IoT Sim. So what we are doing in this project is we are developing a collection of discrete event simulator where each activity in IoT system is modeled as a discrete event. And then you can combine these simulators together to model your osmotic computing algorithms or your data management or networking algorithms. For example, in this picture, we show that you can include IoT Sim Edge to model the edge layer of your edge and IoT layer of your IoT application. You can use Big Data Sim SDN to model the SDN networking between your microservices. You can use IoT Stream to model real-time computation of IoT data. So you can pretty much glue together multiple kinds of simulators, and then you can validate the performance of your IoT graph under different networking scenarios, different hardware scenarios, different software scenarios. We have released the software code of some of this simulator you can find at this link. You can download and start testing the performance of your algorithm as part of this discrete event simulator. So by using this discrete event simulator, you have 2 advantages. For example, you can scale your IoT infrastructure to millions of devices or millions of servers, which is quite not possible with real infrastructure. And secondly, because we are using simulator, you can reconfigure your IoT network with different protocols. You can use Bluetooth, Wi-Fi, 4G, and you can change those configuration in the matter of minutes and seconds. So you don't have to set up those things manually, which can take weeks or months, even for small scale infrastructure. So this is one of the big research project we are doing at Newcastle. We have released the code base a few months ago. So you're happy to go to this link, download and try it out. And if you have any problem, we are happy to talk and help with your research, how to use this tool to validate your IoT algorithms. The second challenges that we're working at Newcastle is about how do we optimize the deployment of microservices across different layers. Why this is hard? As we have all worked on cloud computing, any mapping problem is NP hard. Why it is NP hard? Because we have a lot of options and we need to select a few based on our constraints. And why it becomes harder in case of IoT? It becomes harder in case of IoT because we have 3-layer system, an IoT layer, edge layer, and cloud layer, and each layer has its own constraint. For example, at the IoT layer, we want to save the life of the battery of the IoT devices. At the networking layer, we want to save the network bandwidth. At the cloud layer, we want to save the cost of hosting our AI engine or cost of storing our data. So when you formulate those things in an optimization framework, you will end up with a lot of conflicting optimization function. And as your search space is very high, it becomes really infeasible to solve this optimization problem in real time. So we need to come up with new multi-level heuristic to solve it. And one of the approach which has been investigated in literature is about distributed optimization, where you have optimizer at different layers of the system, and they do local optimization for the IoT layer, edge layer, and the cloud layer, and then they use federated learning to combine the global decisions. So this way, you can speed up your optimization. So this is one of the trend in our community, looking at how do we optimize the deployment and how do we make decisions faster as compared to what we have done before. So as I said before, the whole value of IoT lies in the data, right? How fresh is your data? How new is your data? Because if your data is old, doesn't matter how expensive is your test bed, your result means nothing. For example, in the flood modeling, if I have the data from my sensor which is 1 hour old, then it might happen that the flood has already happened and I'm just modeling something based on stale or old data. So in this case, so age of information becomes a critical factor of IoT application. And the age of information defined as the data freshness. How fresh is the data? And this data freshness is the function of the two network US metrics, including throughput and delay. So these are the two metrics that combined together gives you the data freshness. And at the same time, you are hoping that your system is cybersecurity secure. No one has hacked it. Otherwise, someone can just replay the stale old data and then you will not realize. So the age information becomes a critical issue in context of IoT application. Why ensuring age information IoT is hard? You can see from this picture why this is hard. This is hard because you have different kinds of networking system across different layers of the system, and each of them have different latencies, different throughput, different energy requirements, and then your data can become slow at any of these layers. So right now, we don't have any methodology that can make sure that okay, I want to ensure for my IoT infrastructure, my age information is less than say 10 milliseconds. We don't have any such solution available, but we need such solution if we want to make this real-time decision-making application really feasible for our future application. It's a hard issue. Your age of information can be affected by many other factors. That includes device dynamics. For example, the battery life failure of your IoT device, the software failure of your edge device, the hardware failure of your networking device, the link failure, the network can get congested. For example, if you don't provision your IoT network and devices in optimal way, you might end up overloading your network connection and your age information will degrade. So you need a lot of complicated network provisioning algorithms to make sure that you preserve the age of information, which is critical to your IoT application. So this is other area of research that we are working on with Leeds University with Professor Zhu, and we are working on a paper on this topic that we work in collaborative way, and we believe this is a very important problem to solve in context of IoT application and the age of data.
I don't know if you can hear me, so happy to take questions, if any, based on the talk.
Yeah, I just said it is a very elaborate presentation. The modern emerging technologies, most advanced techniques you have been sharing with us. So I'm sure, Manisha ma'am, are there any questions from your end?
Hi, Rajiv. Very nice to hear from you, and it was very insightful talk. And I believe the faculty and students and all the participants must have enjoyed it thoroughly. I would like to hear a little bit more about when you are talking about the Newcastle deployment, about 3,500 sensors for the different aspects. On the edge analytics side, what are the major challenges which you had faced to retain the connectivity, to retain the computing, the resource-aware computing? What are the major challenges which you were finding?
So you're right. As I said in last part of my talk, the worst part was the communications. Our communication keeps breaking down, and based on the device capability. So your question is also very timely. Richard Dawson, some of people know him, is a flood modeler, and myself, we just got £2 million from UPSRC looking at how can we make edge analytics fault tolerant against those dynamics. So right now we are working on best effort. So if something fails, we go and fix it. But what we have done right now is to make edge analytics fault tolerant. We are looking into deep learning with methods in terms of fault diagnosis and prediction. So that project has just started. As of now, we just do the way other people do. Just if some COM fails, we go replace the router or put a new kind of COM infrastructure. This is what we do. We right now don't have any automated solution. As you say, this is a very hard problem, right? Especially with our sparse distribution of sensors, like 3,000 across the northeast of England. There's no automatic solution right now, but we got funding from EPSR to solve this problem using AI techniques. So we are just starting to look into that.
Okay, are there some more questions, please?
Also, your concept about osmotic computing, I think it's a really good idea to take forward and with looking at the different challenges which we will face when we take forward.
Yeah, thanks, Manisha. Thank you.
Thank you, Professor Rajiv. In fact, I had a small doubt, although I'm not in the same field, but I was just wondering how fresh data you should be requiring, the freshness of data or age of data. You know, that is because we sometimes use a lot of empirical data to work on certain models and thresholds. So I was just wondering, can you please elaborate on that?
So in our recent paper, we defined what is quality of data or age of data. We have defined, and freshness actually depends on your application domain, what kind of analytics you want to do. So for example, for the flood modeling application, when we talked to the flood modeler, they said we use historical data. But when we explained to them that what you're doing is not going to make any sense in terms of smart city applications. So we told them how fresh has to be your data. So if you talk to every other person, it will give you a different answer. So I need a data which is 1 minute old, some say 2 minute old. So it's based on what context they are collecting data on. So if it's like rain intensity, you can have 1 hour old data. But if the data is about monitoring the river breaches for the flood, that needs as fresh as possible. So it's based on what kind of modeling you want to do and how urgent it is. So as I said, in my current project where we're looking at fault management, we are doing workshop with different kind of stakeholders. They include people from universities as well as government. And we are trying to figure out in our tolerance range, how much tolerance they can have on the age of data based on this mission critical applications such as landslide, flood management. So as I said, it's an open question still, there's no answer. But my perception is depend on the application you're trying to model. It's really tightly coupled to that.
Yeah, a corollary is just emerging. Can you also distinguish between the natural phenomena, data related to natural phenomena, and the human interference aspects?
Yeah, so that goes to the cyber aspects of it. So you are saying cybersecurity. So they are like two different aspects. So even for that human interruption and changing of data, I mean, making the data quality poor, we have started investigating this adversarial machine learning, where we are trying to say in the simulator, what happens when someone try to corrupt my sensor, what kind of data flow we will get, and can we train our classifier to detect those patterns at runtime when we connect that DNN deep learning classifier to urban observatory. So these are very interesting and new problem, and we have just got funding for that and have started working on that. Obviously, there's no solution available right now to do this automatically and on large scale.
Okay, yeah, thank you. Thank you very much. We are indeed really grateful to you for having shared such huge amount of knowledge that you are already having and working on such a leading edge technological research. So with this, we are coming to close of our present session. Thank you very much, Professor Rajiv Ranjan. And back to you, our headquarter team.
Thank you, Professor Sudish.
Thank you.
Very much, sir. So now we have a 15 minutes break and we will resume at 4:15.
Okay, thank you.
In the break, the videos will be played.
town located in the Idukki district of Kerala lies along the famous Western Ghats and has experienced multiple landslides in its history. Over the past several decades, many homes have been destroyed and many lives have been lost as a result of the rainfall-induced landslides. European partners of the Windsock project visited Amrita in June 2009. Amrita University's landslide detection system monitors 7 acres of unstable land and currently includes 20 sensor columns, 20 wireless network nodes, and around 150 sensors. The sensor columns are solar-powered and include many geotechnical sensors which are buried underneath the ground. The data from these sensor columns are aggregated and combined at the Field Management Center, which then transmits through the satellite network to Amrita University's Amritapuri campus. The data are then analyzed, stored, and streamed to the university's web server. The system has successfully given warnings 3 times. Amrita's wireless landslide detection system has also been featured in several leading Indian newspapers. The team is currently working on implementing a landslide detection system in the Himalayas. Based on the initial survey of population distribution and slope vulnerability, the Chandmari region in Sikkim was assessed to be the most needed area to install the detection system. The pilot phase of the project has been completed. The system will be fully deployed and operational by the end of 2017. Once completed, the system will be able to monitor landslides in an area of approximately 130 acres.
டைம்ல எங்களுக்கு ஒரு இன்ஃபர்மேஷன் கிடைச்சதுனால இங்குள்ள மக்களையும் வந்து ஒரு பாதுகாப்பா இருக்கிறதுக்கு முடிஞ்சிச்சு. அதனால இப்போ வந்து என்ன செய்யும் மக்கள் பயம் இல்லாம இருக்கிறாங்க. இதனால இது வச்சதுனால அமிர்தானந்த அம்மாவுக்கு அவங்களோட இன்ஸ்டிடியூட்ல வேலை செய்த எல்லாருக்கும் ரொம்ப நன்றி.
நன்றி. அமிர்தா அம்மைக்கு வளர நன்றி. ഞങ്ങളുടെ നന്ദി ആസ്വദിക്കുന്നു.
Marine fishermen along India's 7,517 kilometer coastline spend several days on the open seas as far away as 120 kilometers from the shore. They are completely isolated from their families and other service agencies on land during these days. They don't have a way to communicate during emergencies such as accidents, illnesses, vessel breakdown, etc. Also, there is no way to alert them about impending storms, potential collision with another vessel, potential fishing zones, etc. They cannot afford to use satellite phones because they're very expensive. So what they're looking for is a very low-cost solution that will enable them to communicate to the land. So the researchers at Amrita Center for Wireless Networks and Applications have developed and deployed a very low-cost communication infrastructure called OceanNet. It can provide connectivity up to 60 to 70 kilometers from the shore using a Wi-Fi network on the boat. The fishermen can connect to this network using the smartphones that they own already. This solution has been field tested 7 times so far using up to 4 trawlers, and it has also been permanently deployed on 9 trawlers already.
Historically, India has been dependent on energy imports to meet its national energy requirements. However, the last few years has seen India make rapid strides in bridging the gap between available energy and energy demand. To sustain the progress achieved and to ensure reliability, the stakeholders are placing a lot of emphasis on energy efficiency and demand-side management. There is an immense need to move from traditional, centralized, static energy grid towards a decentralized and dynamic grid, which gives more freedom to producers, distributors, and consumers. Our research targets distributed multi-scale smart networks, which facilitate the integration of low-cost, real-time monitoring and control devices into the grid. This work integrates ICT techniques to empower power grids with the capability of real-time information and two-way energy flow. In this project, a campus-level smart distribution grid has been developed and deployed to demonstrate the capabilities to provide stable energy. The research outcomes from this project include a radial distribution grid testbed offering complete flexibility to sectionalize via remote operated switches, IoT-enabled smart metering and control architecture, wireless interoperable heterogeneous network, M2M ready and AI-based demand forecasting and fault prediction, line breakage detection, fault section isolation, and automatic grid reconfiguration, power quality assessment and power theft detection using ICT, learning techniques and decision models, real-time and historical visualization of distributed system data, self-similar ICT systems architecture, ICT gateway for simulation platform offering co-simulation possibilities where systematic interactions can be studied effectively. These outcomes will aid stakeholders to analyze, decide, and reconfigure the grid in near real time in the event of any irregularity or fault. This will immensely help in improving fault management, energy wastage, and eliminate load shedding in case of glitches and irregularities. We hope that the results of this research will serve as a benchmark for stakeholders to adopt, demonstrate the benefits of smart grid systems, and pave the way for a reliable power system that meets the growing demands of the people.
A university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University. Success. It's the buzzword today in all walks of life. In your journey towards success, the university you choose plays a major role. With top-class research infrastructure, PhD faculty, and high-quality education, Amrita plays a major role in its students' success stories. Come, join Amrita University, an institution of eminence by UGC, ranked as the top private university in India by Times Higher Education World University Rankings and the 4th best university in India by NIRF Rankings 2020. Through our specially designed Chancellor's Scholarship, we provide up to 100% fee waiver and help you learn from the best. Our dual degree program in association with top universities from US and Europe can get you ahead of the curve. Come, start your journey towards success. Visit www.amrita.edu. Success starts with Amrita. Education has the mighty power to move millions of minds from darkness to light, from limitations to limitlessness, from finite to infinite. Our country is believed to have had a higher education system as early as 1000 BC. But today, only 26.3% of the total eligible population enroll for higher education. Only 8.15% of people are graduates. Amritam Kamea. Now is the time to revolutionize, rethink, redefine education. Fourth best university in India introduces new normal in delivering education to the masses. Amrita Ahead. Online degree programs. Unlimit yourself. Get ahead.
കഴിഞ്ഞ വർഷം അനേക പ്രകൃതി ദുരന്തങ്ങൾക്കും സംഘർഷങ്ങൾക്കും ലോകം സാക്ഷ്യം വഹിച്ചു. പ്രളയം നമുക്കൊരു താക്കീതായിരുന്നു, സന്ദേശമായിരുന്നു. സ്വാർത്ഥമായ താൽക്കാലിക ലാഭങ്ങൾക്ക് വേണ്ടി പ്രകൃതി ചൂഷണം ചെയ്യാൻ തുടങ്ങിയിട്ട് കാലങ്ങൾ കുറേയായി. അതിൻ്റെ യുദ്ധഫലമാണ് നമ്മൾ കണ്ടത്. ഓരോ വൃക്ഷം വെട്ടുമ്പോഴും അത് നമുക്ക് ശവപ്പെട്ടി ഉണ്ടാക്കാൻ പറ്റുന്ന വൃക്ഷം പോലായി തീർന്നിരിക്കുകയാണ്. പ്രപഞ്ചത്തിനൊരു താളമുണ്ട്. ഈ വിശുദ്ധം അതിൽ അകലജീവിയാളും അഭേദ്യമായ ബന്ധമുണ്ട്. പരസ്പരം ബന്ധപ്പെട്ട് കിടക്കുന്ന നെറ്റ്വർക്കുകളാണ് ഈ പ്രപഞ്ചം. 4 പേര് ചേർന്ന് പിടിച്ച് ഇവരുടെ കോണിൽ സ്ഥലമുണ്ടായാൽ അതെല്ലായിടവും പ്രതിഫലിക്കും. അതുപോലെ നാം അറിഞ്ഞോ അറിയാതെയോ ഒറ്റയായോ കൂട്ടമായോ ചെയ്യുന്ന എല്ലാ കർമ്മങ്ങളും പ്രപഞ്ചമാകുന്ന വലയുടെ കോണിൽ പ്രതിഫലിക്കുന്നുണ്ട്. അവർ മാറി നമ്മൾ മാറാൻ നടക്കില്ല. അവർ മാറില്ല, നമ്മൾ മാറിയാലും മാറ്റം കൊണ്ടുവരും. നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റുമെന്ന് നോക്കണം. കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതി സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
ഒരപേക്ഷയുള്ളത്, യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവർ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളവർ ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ട് നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെച്ച് വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ള ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മികപ്പടി ഗ്രഹിക്കുന്നത്. ഇപ്പം നമ്മുടെ തലമുറയ്ക്ക് ഇപ്പം കുറച്ച് വെള്ളമെങ്കിലും ഉണ്ട്. നമ്മൾ പൈസ സമ്പാദിക്കുന്നു, കുട്ടികളെ സൃഷ്ടിക്കുന്നു. പക്ഷേ കുടിക്കാൻ വെള്ളമില്ലെങ്കിൽ എന്തായിരിക്കും? ഇതിൻ്റെ കൂട്ടത്തിൽ പണസമ്പാദനം കുട്ടികളെ സൃഷ്ടിക്കുന്നത് പോലെ തന്നെ അതിനേക്കാളും കൂടുതലായി നമ്മൾ ചിന്തിക്കേണ്ട ഒരു കാര്യമാണ് ഭാവിയിലേക്കുള്ള പ്രകൃതി സംരക്ഷിക്കുന്നതിനെ പറ്റി.
Experience is the final evidence for knowing. Shraddhavan labde jnanam.
All right, let's get started. It looks like I am having some trouble with my video. It's okay. I hope I can be heard. Can you hear me?
Yes, we can hear you now.
Okay. Okay, so good afternoon to all the participants. We are about to get started with our next session. The first speaker in this session would be Dr. Mauro Rossi, and he will be talking about Land Suite, a set of tools for landslide susceptibility zonation. Let me give a brief intro about the speaker. Just a second. All right, so Mauro Rossi is a senior researcher of the National Research Council, CNR of Italy, and carries out his activity within the research group in geomorphology of the Research Institute for Hydrological Protection in Perugia. Mauro Rossi develops diversified scientific research activities focused on the mapping, analysis, modeling, prediction, and forecasting of natural hazards, and specifically landslides, floods, and erosion processes in relation to different geo-environmental and anthropic contexts. Mauro Rossi has developed new methods of statistical and deterministic analysis of the susceptibility and hazard posed by different geohydrological phenomena and for the estimation of the related impacts. New approaches for the definition of rainfall thresholds for triggering landslides, early warning systems, approaches for the definition of optimal models for the estimation of landslide susceptibility and for the estimation of the social risk posed by landslides and floods. Particularly significant are the activities carried out in the joint modeling of landslides and erosion processes in relation with different geomorphological, climatic, vegetational, and anthropic change scenarios, with the main purpose of an adequate characterization of the dynamics of slopes and hydrological basins. Mauro Rossi has proposed, won, and coordinated some research projects, working packages, tasks, actions, and activities in the context of international and national projects. So with that, I invite Dr. Rossi to start his presentation on Land Suite, a set of tools for landslide susceptibility zonation. Dr. Rossi?
Yes, good morning. May I share my screen?
Yes, please.
Can you see the screen?
Yes. You may go to the presentation mode. Yeah.
Okay, good morning, and thank you for inviting me to this interesting conference. So I will skip my presentation. Today I will present some activities, some of the results of these tools. Actually is formed by different tools that are mainly devoted for the susceptibility zonations. Just a recap on what we intend for landslide susceptibility. Landslide susceptibility is the likelihood that a landslide will occur in an area. And this is normally done based on a set of local terrain conditions. It basically predicts where landslides are expected. No information on when landslides are expected. This is, as you could imagine, really fundamental information for disaster risk management. In the literature, there were proposed a lot of different methods and criteria and approaches to model landslide susceptibility. Here, mainly, we will discuss statistical modeling, and in particular machine learning modeling. But lens-less susceptibility has to be seen as a sort of recipe where you mix mapping unit methods, thematic variables, and you run in a statistical way to get a final map, the final zonation. We recently did this analysis. This is a review on the statistical based lens-less susceptibility models used in the literature. For sure, now we have much more than this. But as you see here, there were a lot of different criteria and approaches used. Many of them, there were classical statistical approaches, and some of them are machine learning approaches. Among all of that, logistic regression analysis is one really used method, but there are even a neural network analysis and other machine learning criteria that were used for this kind of zonations. Despite these huge efforts done in preparing a statistically based zonation, the quality of this zonation is not always the best. This analysis tried to quantify the quality of the zonation that were prepared in the literature. We have a rank that goes from 0, from the lowest quality, to 7, the highest quality. And here we have the evolution in time of the quality of zonation that were performed in the literature. And we see that just few of them have the highest quality. This is basically the main reason for developing LandSuite. LandSuite is basically a set of tools that want to support researchers, and I even mention technicians, for generating less subjective and hopefully high quality statistically based susceptibility zonation. But this tool doesn't want to substitute the geomorphological inference experience that is so much important when preparing zonations, in particular lens-light zonations. LandSuite, it's an acronym that stands for Lens-Light Susceptibility Inferential Tool Evaluator, and include 3 main components: LandSE, that is susceptibility for the susceptibility evaluation; LandSIP, that stands for susceptibility input preparation; and LandSVA, that stands for susceptibility variable analysis. All these together wants to give tools to prepare good and high quality zonations. Let's start from the core of the tools, that is lens-light susceptibility evaluation. This is actually the older tool that I developed, and it's basically a tool that is mainly devoted to the preparation and to the final zonation of the lens-light susceptibility. We have different portion of the tool that we will describe later. What I want to mention is that this is an open source code. It's actually coded in R, an open source language. And it basically can use a different kind of cartographic unit, pixel-based or polygon-based, and it may exploit different dataset subdivision as training and validation datasets. Basically, this information are used in a multivariate statistical approach where we have a dependent variable or a grouping variable that is the presence or absence of lens-light in a given mapping unit in a given area. And we have a set of independent variables that are our explanatory variables that we use for predicting the presence or absence of landslides. Actually, the tool can be used for several training and validation exercises. Here we see the spatial validation. So basically, we train the model in an area, the dark gray area on the left, and we apply the model, we validate the model in another area, the light gray part on the right. Alternatively, we could have a model training in an area, and we can validate the model in the same area, but using a different temporal data set. We call this temporal validation. Or we could use this in a cross-validation mode. So basically, we train the model in areas that are randomly selected, and we validate the model in the remaining areas. The model may use different kind of mapping unit. Here we see on the left a sort of representation of a raster of a matrix, where you see that each pixel is classified as 0 or 1 depending on the overlay on known landslide distribution that are shown in red here. But you may even use polygon-like subdivision, like you see in the right, and where a polygon is classified as prone to landslide or not, depending on the presence of a landslide polygon in the mapping unit. The model is able to use different kind of variables. It may use continuous variables, like for instance, slope, curvature, elevation, or whatever other continuous variable. It may use categorical variables. These, in general, are transformed into dummy variables in the modeling. Whenever we have prepared and we have split this training and validation dataset, we can run the susceptibility estimations. We have 4 different modeling approaches here: a linear discriminant analysis, a quadratic discriminant analysis, a logistic regression, and neural network model. And then we combine this. So basically, these are the 4 main machine learning techniques that are implemented in the model. Basically, for each of these that are listed in this slide, we get a zonation. Here we see on the left a possible zonation that we get for each one of these single machine learning techniques. And clearly, we need to decide which is the best model for the susceptibility analysis. But as we see in the literature, there isn't a model that outperforms among all the others. So we came up with the idea to combine them. The basic idea of combining this kind of forecast or prediction implicitly assumes that a single model could not identify in the better way the underlying process. But different forecasting models are instead able to capture different aspects of the information available for the prediction. This is basically in a more cool way called ensemble modeling. Actually, if you go in the literature, the combination of different models is something that is known since the 60s. So we are not really inventing nothing. We are just using what was already discovered in the past. In our approach, we selected a combination model that is a logistic regression. Basically, all the probabilistic outcome of the single machine learning model are used as explanatory variables and are used in this combined modeling scheme. So basically, combining all this single modeling, we get a final combined model that you see here that actually is restituting exactly the same information, that is the susceptibility level at which each mapping unit is subjected to. We really take care a lot of the evaluation, on the model evaluation. And we implemented a series of metrics that you could use to evaluate the model, either in the training and in the validation phase. Here we see contingency plots. Contingency plots are basically a graphical form to see a contingency table. These assume the choice of a threshold, a probabilistic threshold, classifying the probabilistic outcome of the machine learning approaches. So basically here we show graphically the true negative, the true positive, and both the kind of errors that a model could do. But we can use these plots to either in the training phase, so to see how the model was able to explain the data that it was used to calibrate the model. And we can see even the spatial distribution of the correct prediction of the model or the erroneously prediction of the model. We can also see in validation phase the same. To fully exploit the probabilistic nature of the susceptibility zonation, we could use rock plot shown in the left. I'm pretty sure that many of you know this plot. So the area on this curve is basically a measure of the goodness of the model. But we can realize this evaluation plot that is really helpful, particularly when one wants to identify optimal binary classification threshold to classify the model that is probabilistic in nature. There is even another metric that is called success rate curve or prediction rate curve, depending if it is applied on the training, on the validation that is implemented in the model. Again, this is an additional way to judge your model, to evaluate your model. It's really important to take care about the uncertainty and the model uncertainty. This is why basically we implement an uncertainty procedure that is based basically on statistical sampling and resampling techniques. And basically we perform susceptibility estimation several times, each time introducing a perturbation on the input data. And what we get for each of the mapping unit we are trying to investigate, we get mean standard deviation of the susceptibility values, and we use them to generate an error, a model, an uncertainty model. And we do this fitting all this information that you see on the left with a parabolic model. We may use this model to assess the uncertainty of each prediction that we do in each portion of our study area, as you see on the map on the right. We come out to the second tool. We recently realized that the tool that we realized that Lance is a good tool, but is difficult to apply. And in particular, we realized that researchers should have support in preparing a good dataset partition. This is why we realize these tools that is called susceptibility input preparation, LAND-SIP. Its main role is the preparation of input data for Lancet, but this can really help you to experience or to implement different training and validation dataset partition. First, you may use this to prepare balanced or unbalanced dataset partition that assume a different number of 0 and 1. That means with the presence or absence of landslide in each mapping unit. It may help you to reduce the dataset. It may help you to prepare different spatial dataset partition. The model is able to work with different spatial data, raster, in particular GeoTIFF or grass layers, and polygons. And it can even help in using mask to extract data. What is really important here that this LANSIP is able to execute in cascade the other two models. Okay. Let's come to the last tools, that is LAND-SVA. At the beginning, I was saying that LANSUite doesn't want to substitute the geomorphological inference of the user. And we think that it's really important to understand, to start from the variable analysis before starting really to prepare a zonation. So LAND-SVA wants to provide tools or information that help you to decide if a variable is helpful or not for your susceptibility zonation. So basically, the main role of LAND-SVA is helps in selecting the optimal set of explanatory variables to be used in the analysis. This is done performing several analyses. In particular, we perform conditional density analysis of the input variables. It is able to perform the pairwise correlation analysis of the input variables and even the multicollinearity testing of the input variables. It's even able to exclude automatically those variables that are correlated, because basically it doesn't make sense to include correlated variables in the analysis. Here we saw some examples just briefly, just to see the kind of output that you can get from these tools. Here we see the density. We have two variables here. We have the slope on the left and the georange, that is a geomorphometric variable on the right. And the tools immediately help to decide and to see what is the distribution of the mapping unit that have landslide or not, and how those are distributed depending on the value of the variables that you are analyzing. You may easily check that in this case it makes sense to use slope more than georange in the analysis. This is a pretty different elaboration that we can call conditional density plots. Again, we have the two variables here, and you may check which is the repartition of the stable or unstable mapping unit depending on the value of the variable. Clearly, the case on the right, that is geoazimuth, show that is really useless using this variable in the analysis. Whatever value the variable takes, the proportion of stable and unstable pixel and unstable mapping unit is always the same. It's 0.5. How this variable could help in modeling? So clearly, this should be excluded from the analysis. This is a pretty diversified plot, at least graphically, but it's really similar to the previous one. This is a spine plot, but it's exactly showing the same content of the previous plots. Is basically having a difference that is the fact that the two variables are categorical and not continuous, but the content is exactly the same. Again, here the litho 20 FR, that is a lithological variable. Here we have different classes, different lithology classes, and you see clearly a variation, a distinct variation of the proportion of 0,1 with the value of the variable. This is the perfect case. This is the perfect behavior we want to from a variable to use. We have even facilities to exclude correlated variable. Here we have an implementation of a correlogram. So basically you can immediately realize which variable are correlated or anti-correlated. And you may decide to exclude some. Doesn't make sense to use correlated variables. The impact on the model will be nothing or nil. Clearly,
Dr. Rossi, sorry to interrupt. If you could wrap up in the next couple of minutes, that will be great.
Yeah.
Okay.
We are closing.
Okay.
The last one is this kind of analysis that is similar, but helps you to exclude correlated variables, multi-correlated variables. Okay, then this kind of suite was applied at different scale, at different resolution, using different mapping units, using different validation sets, and and applied even to different kind of processes, not always landslide, but even floods, forest fires, rockfall source areas, etc. Here I will show just really briefly the kind of outputs that you get from the modeling in a study area that are in Italy. This is called Lazzone. This is where the variable we started from, elevation, basically, and some geomorphometrical variable. And these are the results that we get from the single susceptibility zonations. We see 4 actually here. And we have even the validation application that we see. All this plot you have seen before. And but then you have even the validation, and you have the combined model. Here we saw just 2 cases of combining model. Here we are using all the 4 models. And here, in this case, the neural network model was having the higher significance. But excluding this, we see that the quadratic discriminant analysis and the logistic regression model are basically much more significant for the model, for the combined model. Again, this is the same results in terms of validations. Okay, these are the kind of outputs that you can get. You can find more information in this plot. This is the paper describing Lancet. This is another paper describing the concept of the optimal combination of the models. And this is the paper that was showing the review. We are actually preparing a paper on Lancet. We are close to submit, and soon we will have even a paper for the entire tool. Okay, I'm done.
Thank you, Dr. Rossi. That was a very rich presentation with a lot of information on different models. At this point, I would like to open up the forum for any questions from the audience. So while we are waiting, Dr. Rossi, one question: what are your primary data sources for all this modeling?
We are mostly using environmental data. So basically, we use landslide inventory maps that are basically maps portraying the spatial distribution of landslide in an area. This is really fundamental because it's the dependent variable in our analysis. So it is a geographical layer. Then we have some thematic layers that are describing our study area. We have elevation, we have a digital elevation model, and we have variables that are derived from this digital elevation model, like slope, like exposition, like aspect, like curvature, and a different kind of variables. And then we can have some classification of the territory that are normally done by experts, like, for instance, lithological maps or land use, land cover maps, or similar kind of information. So those are the main kind of information that are used. But you may have many. Eh? You may have many.
Thank you. Thank you. There's a question from one of the audience. The question is, can you suggest some software for doing these LDA and QDA? And then what other applications can be there for these two?
Okay, LDA, QDA is, okay, I don't know if you know R. R is a language that is devoted for statistical analysis. It's a language, actually, but particular for this kind of classification or multivariate statistics as a lot of tools. So instead of using a software, I suggest to put a bit of your hands on R and see how it will works there. This because it will give you a lot of potential information that you may use. And all the LDA, linear discriminant analysis, LDA, are normal tools used by R. So this is the suggestion. The second one, sorry, was?
What other applications can be there for these two?
Okay, there are this LDA and QDA are basically discriminant analysis. Here used in a classification mode. So as you could imagine, the classification exercise that you can use are many. You may use for classifying images, for instance. You may use for classifying data, whatever data. In this case, I'm using this in a sort of a binary mode, so 0 and 1. But you may even have this different kind of classes and a different number of classes that you may predict. So all the classification analysis that you may think can be done using linear discriminant analysis and quadratic discriminant analysis.
One more question has come up. Does the model consider soil characteristics and weathering history as parameters?
It's really up to the user. to use this. You may provide this information actually in as arithmetic variables. So it's really feasible. And the tool will help you to see if these variables that you think are important will be really related to landsliding. Because the point here is that if we start to think all the variables that may be helpful to explain landslide susceptibility, there are many. The point is that you should have data to support this kind of analysis. And sometimes what you think is really helpful or really meaningful it is not in the reality, because you don't have, for instance, a good landslide map to see and to check without this relation. This is why a part of the code that is called LandSVA is helpful. But actually you are free to use this.
Great. I don't have any other questions at this point, but I would definitely encourage the audience to keep typing questions in the Q&A window, and I will request Dr. Rossi to check maybe for the next few minutes for any questions and try and answer those if possible. And with that, I would like to thank Dr. Rossi again for taking the time and giving us a nice presentation on his research. Thank you, sir. Thanks a lot for taking the time.
Thank you. Thank you to you for inviting me.
Thank you. So now we will move on to our next speaker. Our next speaker is Dr. Manisha V. Ramesh. Let me give a brief introduction about her. She is the director and professor at Amrita Center for Wireless Networks and Applications and the Dean of International Programs at Amrita Vishwavidyapitham. She is also the chair of the School of Sustainability and also the UNESCO chair for Sustainable Development at Amrita. She got her PhD in computer science from Amrita Vishwavidyapitham and authored a research thesis titled Wireless Sensor Network to Detect Rainfall-Induced Landslides. Her research work was instrumental in deploying the first ever wireless sensor network system capable of issuing landslide warnings. She has received US patents for this work, network-based system for predicting landslides and providing early warnings. She has an MBA in Systems Management and Financial Management from Amrita Vishwavidyapitham. She completed a BTech in Production Engineering from Kerala University. Dr. Ramesh is the Dean of International Programs. She heads all the activities of Amrita Center for International Programs. The center has been in charge of developing collaborative initiatives between Amrita Vishwavidyapitham and other international universities. The main work includes developing MOUs within international universities for faculty and student exchange programs, dual degree programs, research collaborations, etc. As of now, Amrita has signed 153 MOUs since 2005. Dr. Manisha had given distinguished lectures in different reputed universities during visits to international universities. Since 2007, she has published more than 94 publications, including 3 Best Paper Awards. Dr. Manisha was awarded the prestigious Young Faculty Research Fellowship under Vishwesvaraya PhD scheme for electronics and IT for the year 2015-16 from the Department of Electronics and Information Technology, Government of India. She has received the National Award, NABARD Award for her work on landslide monitoring and early warning system. She is the editor of Ad Hoc Network Journal published by Elsevier. And in a recent study conducted by the Stanford University, she was chosen among the top 2% of the scientists of the world. So with that introduction, I would request Dr. Manisha to take the stage and give a presentation on IoT systems integrated with ML techniques for ecosystem monitoring and disaster resilience. Dr. Manisha Ramesh.
Thank you, Professor Setu. Let me just share my presentation. Give me a second. I hope the presentation is visible to all of you.
Yes, it is. Yes.
Thank you, everybody, for joining this program. It's indeed very warm and very happy to see so many eminent professors, researchers, industrialists, practical ground reality of people working on the ground, talking about the different areas and systems and solutions, being very heartening to see this many work which is happening for the ecosystem restoration. In this regard, let me start my talk on IoT systems integrated with ML techniques for ecosystem monitoring and community-based disaster resilience. I will try my level best to bring in the points as quickly as possible. I know that there is time constraint. Professor Sethu, feel free to inform me when I have to stop. I come from Amrita Vishwavidyapitham, which is one of the youngest university in the country. Even though it is the youngest university, in over the last 16 years, we are able to climb the ladder and reach the number 4 in the country, and also world THE world ranking number 1 as private university. And in the latest impact ranking in 2021, we are ranked first in India in world's top 100 as 81st ranking. And in SDG 5, we are able to SDG 4, we are able to get 5th in the world, and SDG 5 in 8th in the world, and SDG 3 37th in the world, and SDG 6 52, and in top 200 in both in industry and innovation and infrastructure, and also in partnership for goods. How come this university, which is existent only for 16 years, is able to achieve these ladders of research excellence? All this because of our guiding light of our Chancellor, Sri Mata Amritanandamayi Devi, who have laid the foundation with the 3 main principles for this university as education for life, and also compassion-driven research, and also global impact. So she believes in that we have to provide value-based education, not only education for living we have to give education for life, which will have the values which will make them to handle the situations and stresses arise in this lifetime, and at the same time motivate and encourage and give them a pathway to look at compassion-driven research, see what the society needs, and then provide those solutions by holding hands with the global partnership, with the global partners, looking at global challenges, so that this compassion-driven research can lead to love, light, and also sustaining peace in the whole world. So that is what was the motto for this university, which made us to actually have a trajectory which is a little bit different from several other universities. I have multiple hats. As of today, what I am talking is mostly from the Center for Wireless Networks and Applications, which is an interdisciplinary center where we have faculty from multiple interdisciplinary areas, wireless, physics, electronics, geology, working on advanced technologies for humanitarian applications such as IoT for extreme environment, wearable medical systems, smart city infrastructure, and immersive learning. With that knowledge in the work, with that expertise and the knowledge or experience in that work, let me just talk about the today's topic of ecosystem degradation and multi-hazards. As you all know that the human beings' usage of land or sea, our direct exploitation, each of our culture, our social characteristics, how our institutions and governance policies, and all this lead to the today's climate change, which is also bringing in conflicts and epidemics. As of today, the natural ecosystems have declined by 47%, and there are species which has been more around 1 million species are already facing extinction. And with respect to water, almost 1/5 of the world population live in areas of physical water scarcity. To aggravate this, the natural disasters are happening 3 times more often than 50 years ago. And the magnitude during the past 20 years, around 74% of all natural disasters were water related, leading to deaths of 166,000 and a total economic damage of $700 billion. Plus, this impending threat is now attacking more on the child survival because of the changing disease environments, greater food insecurity, and threats to water and sanitation, which is a major impact on our future. So why is it? How can we handle it? How can we at least reduce this faster rate of climate action, which is bringing in ecosystem degradation and also multi-hazards. So as I earlier said, the degradation is both natural and man-made, and we are having a lot of degraded ecosystems with wetlands, with polluted rivers, deforested landscape, overexploited forest, non-fertile agricultural land, etc. How is it all happening? It's all happening because of our unplanned daily activities. We think ourselves, we don't think about others, which is the major cause for all those things. And that is making the ecosystem to degrade. When it degrades, you have impacts on short term and long term. And short term, we see it as extreme weather variability. And then the long term, we call it as climate variability. Now we know that these changes are happening and I need to reverse it, which is a long process. It's a continuous process. If we want to do that, we need to do, we are required to do, track every action we do, the impact on each of the services we need to analyze, learn from the dynamic behaviors which you see based on your actions, initiate automatic corrective actions, and track the impact of the interventions, which is these 5 parameters by itself is a very large job for the human community. So to capture the transitions, to devise and implement strategies for transformations from ecosystem degradation to ecosystem restoration, we really need to monitor continuously, we really need to detect, we need to intervene. But as usual, we don't know everything what is happening in this earth system. So there is a need for us to learn and continuously learn and use intelligence, artificial intelligence, to understand some of the unknown parameters also. For that, it really requires systems and solutions. So to achieve all these things, one of the framework which we can look into it, we need a framework for revival. For this framework for revival, it will need monitoring and detection, where you have to monitoring and early detection of degradation to adopt best approaches to revival, deploy technology for early warning and detection, technological interventions through IoT, AI, ML, and ensure use of sustainable technologies. Governance interventions needs to be brought in by incentives and capacity building, multi-actor participation, governance laws and implementation decision-making in case of hazard resilience. And to implementation and restoration, we have to create community awareness, interaction and implementation across local, national, and global scales, and establish balance and harmony with nature. So for the whole ecosystem restoration, you need to look into what are the ecosystem drivers, ecosystem functions, and ecosystem services, so that we understand the ecosystem variability which is contributing to the multi-hazards. And to handle this multi-hazardness, we need to get prepared. We have to be ready for the response, recovery, mitigation actions. For this, you need to develop a knowledge on how to measure, monitor, interrelationship of factors, threshold development, early warning procedure, participatory approach, empower the community. And all this need to be implemented in a scalable, sustainable, and resilient manner. So the technology requirement you need is, as I earlier said, you need to measure. Measuring can be through either participatory sensing or virtual sensing or physical sensing. Monitoring, you need to monitor continuous data collection or adaptive data collection, multi-level type of heterogeneous data aggregations. You will need real-time communication and visualization. With these things, you are only getting the data which is not going to tell you anything. You need to do the knowledge discovery, which will actually need social models, statistical models, geological and hydrological models, signal processing, data mining, machine learning models. And all these learnings and the knowledge discovery should help us to do the forecasting. For that, we have to build models for weather forecast models, hydrological models, slope stability models, expert models, etc., which has to be the results from those should give us the early warning. And to build that early warning, we will need artificial intelligence model, multi-phase, multi-scale decision model, real-time communication, services, and alerts. So if we look at the technologies that need for ecosystem monitoring to measure and monitor, as of today, the key technologies which everybody is interested or everybody is trying to use are Internet of Things, wireless sensor networks, geophysical sensors, geodetic monitoring, and several other things are there. These things are used for the different ecosystems to be monitored. So if we take the case of agricultural sector, we will have to monitor, or we will have to measure and monitor the rainfall which is coming in, so that we understand the crop production, the temperature, the wind speed, the solar irradiation, soil temperature, the pH level, the nutrition, the moisture level, etc. If you want to monitor with respect to water, because their agriculture and water is interconnected, to understand the water sustainability, you have to look into rainfall, water level, water quality, consumption level, demand level, water storage level, what is the runout. But to do agriculture or water, you need energy. So if you want to look into the energy sustenance, you have to look into what is the solar irradiance, how much water flow so that I can do a micro hydro, what is the energy generated, what are the other hybrid models, energy consumed, demand and usage. With all these things, we also know that it's not only the ecosystem we need to know, because already the climate change has started and we are impacted by multi-hazard. So we need to look into floods. So the flood, when you want to monitor or the measure flood, you need to know about the rainfall characteristics, its water level, water flow, topography, dam network. And the connected ones like landslides, you will need to know rainfall, moisture, pore pressure, vibration, movement, elevation, slope angle, etc. Now, it is very clear that to measure and monitor any of these things, we need technologies to do if we want to do it continuously. Let me come to a case study of landslide monitoring, which is the design, development, and deployment of Amrita IoT system for landslide detection early warning in Western Ghats in India and Northeastern Himalayas in India in Sikkim. We have in both the places together, we have more than 400 plus sensors, which is continuously monitoring both the areas and provide real-time early warning, and that is helping us to do the disaster risk reduction. So if you look into how do you select an appropriate techniques for data collection, integration, or analysis, the data acquisition is through sensors. You need to decide for each of these type of applications whether you need the data as continuous or periodic. You need to understand the data acquisition challenge, like which is basically a domain specific. What is the spatial area you have to collect, at what temporal frequency you want to connect. So if you think of like rainfall, do you want to collect every 5 minutes, every 1 minute, every 1 second, or if the soil temperature? It depends on how it is varying with respect to the domain. The edge computing, it is also domain specific, where you will do the analysis of homogeneous parameters, analysis of heterogeneous parameters, because you will have multiple types of sensors, as I earlier mentioned, because I have to measure different types of parameters, and each of them behave differently. So their analysis has to be brought into the edge level to understand. But the moment you bring in the edge level analysis, you have to understand what is the edge storage. So real-time wise historic data trade-off will come in. And not only that, at the edge, you have limited resource, which will have the trade-off between how much I can sense with respect to the energy availability, how much I can store with respect to the computational energy it is going to, how much edge computation wise energy and data transmission wise energy needs to be understood and appropriately used. So you have to have a data acquisition layer, which will dynamically acquire the sensing data about the monitoring parameters. So domain specific, Amrita has developed an Amrita IoT edge node for landslide monitoring, where we looked into the sensing, the data acquisition, spatial measurement, and temporal frequency. And for the sensing, we have come up with geophone, pore pressure sensors, strain gauges, as dielectric moisture sensor, rain gauge, etc. And not only that, you get the sensors, you have to have the low-cost earth probes. So low-cost systems means either you develop yourself or you understand what is available off the shelf, and then integrate this heterogeneous sensing and have this heterogeneous sense data through the real-time wireless connectivity. You transmit it so that you are able to real-time get the data and analyze. So all those things need to be integrated with the edge computing, so that data analytics and local decision can happen, and localized warning can be given, so that even if I lose the network, I am able to inform the community. And with, as I earlier said, power optimization is required for lifetime maximization of the system. Otherwise it will die, because most of the time we are deploying these systems in hostile regions, and fault tolerance and data collection, memory, and wireless connectivity. So edge computing for lifetime extension, we have built a context-aware energy management, which will actually do adaptive data management by dynamic prioritization and real-time scheduling, and then communication. And you can see how it is saving the energy levels. And this is sent to the edge using the edge node services. It is sent. And once, how do you send it? You need to have real-time monitoring. So we have built a 24/7 monitoring by integrating IoT, fog, and cloud with sensors, wireless network, which has automatic capability to handle the fault tolerance. If I lose Wi-Fi, it will use satellite network or the broadband network, so that still I will get the data. So we have to look into we have built our own software which is able to handle the service delivery, the traffic management, the bandwidth management, etc., and also handling all the heterogeneous devices and the protocols which is needed, and by which we are able to make a 24/7 operational landslide monitoring and detection system, delivering real-time warnings via internet and local alarms. And the whole data is also, we are able to get the real-time visualization of data by the software developed at Amrita. It can be with respect to different fields, all the sensors, or per sensor, or at different levels. So with all those things, is that enough? If I get that, I collect the data, I monitor it, and I am visualizing it, is that enough? No. To understand the ecosystem services, the needs of the services, and also to understand the multi-hazard detection, we need data science approaches to understand, to derive the knowledge discovery and forecast. So in this case, we will have to use data analytics, data mining techniques, machine learning, artificial intelligence. So if you look at the services for the agriculture, we may want to build a weather-aware crop monitoring, crop deployed, crop selection. We will need to do the controlling the pest. We need to detect as fast as possible and take the action. Crop yield, we want to change according to the nutrition level, according to the current climatic levels and the smart irrigation aspects. In the water side, from where you are sourcing, do you have enough water or not? How do you distribute it? What is how the river water is? What is the quality? On the energy side, what is the energy consumption? How can we manage them with respect to the available energy? Whereas as a hybrid approach from the micro hydro to the solar microgrid to the state electricity board, how do you do the energy trading? All these things, all these services has to be handled through the knowledge discovery. And in the flood, you have to understand the extreme weather, or how it is behaving, what is the flood level in a dynamic manner, and how the dam management needs to be brought in, and the landslides with continuous rainfall, pore pressure thresholds, vibration monitoring, movement detection. All these things we are able to do through statistical analysis, data mining, machine learning, and AI. So we could use clustering techniques to understand how the behavior changes with respect to the extreme weather, how is it changing. We could use regression analysis to understand how the forecast is varying, what is the changes. We can use classification to understand what are the different patterns of data you are seeing, what are the faults you are seeing in the data, how do you actually classify and tag them, and so that we don't use them for the real-time analysis. Support vector machine, we can use it for actually forecasting and predicting the different sensor data, neural networks, genetic and AI will be used for the decision models. So in our system,
Dr. Manisha, if I could interrupt, could you wrap up in a couple of minutes if possible?
Yes, sir. So in the decision support system, we have continuous enhancements for decade-long data, real-time data analysis, and adaptive learning and forecasting. So we use different decision models for meteorological, geological, and hydrological, for spatio-temporal analysis and machine learning models. This has been already explained by Dr. Daanya in the morning, where we have developed the local rainfall threshold and regional rainfall threshold. And for the forecasting of landslides, we have used artificial intelligence. We try to understand the different parameters like water pressure and daily cumulative rain. You can see the blue color is the water and the yellow color is the pore pressure. And what you are seeing is like you will see rainfall continuously. There is a point where the pore pressure is getting raised. So how do you capture that? So for that, we used SPR approach. And you can see from the graph, we were able to have the actual pore water pressure, and we have built the historic, using the historic data model and also an adaptive model, which follows almost same path. And the decision models has been integrated with the laboratory result. And we integrated the AI methods for coming with the artificial intelligence with a 4-level warning, giving the automatic warning dissemination to researchers, government, media, and public. Through the slope stability, landslide, laboratory, and field data is used for validation, and then the warning is issued with the different thresholds. And we are able to give the decision models with respect to each of the level. It automatically generates the decisions, and it disseminates the warnings to the concerned people. All these are possible because of the IoT framework for multi-scale monitoring, where we have the edge node capabilities, fork node, and cloud node capability. All this has been attached to the IoT framework for multi-scale monitoring with a layered architecture, engaging sensing layer, data acquisition, communication, network information, decision layer, and service layer, which is capable of handling interoperability, heterogeneity, and scalability. And not only that, we also use the participatory approach, where the early warning of hazards using social media mining, multi-hazard tracking, mobile app, and real-time disaster management, rescue and relief through 24-hour call center. And Amrita Kripa mobile application was also used for the disaster management. This is during the 2018 Kerala floods, where we have used our application Amrita Kripa app, which will be dealt later in detail for the relief, rescue and management. And under the landslip project, which where we have multiple partners, where we are tracking landslides using the mobile app called Landslide Tracker, so that the data can be tracked and the enhanced collaboration among the communities can be brought in. And we are also helping in training training aspects. Input and output is looked into it, so that we can get the spatio-temporal landslide events, map the landslide events, track landslide summarization and adaptive dissemination using the mobile application called Landslide Tracker, which is available in the Google Play Store. And as part of landslip, we are also doing social media data collection and processing architecture, through which we are trying to find, can we capture any of the early warning signs from the social media? So we are doing it in a multi-language specific. So with all these things, we are bringing in the community resilience as an integrated approach, from the data collection from multiple sources of site-specific sensor to the crowdsourcing sensors through the event detection framework and alert dissemination and the alert service by adaptive learning and pattern extraction, threshold development, event detection and multi-scale early warning. And we engage the community for the capacity building aspect, and thus the ecosystem restoration, which is taken care, and we are trying to work through the landslide risk reduction approach by looking into vulnerability mapping and meteorological, geological, hydrological analysis, real-time monitoring, multi-scale decision models, and community resilience. And not only that, there are so many other initiatives which has been initiated by the university on the ecosystem restoration and hazard resilience. And technology-driven initiatives are also there with respect to flood and offshore communication for fishermen, etc. And which all has led to 4 joint research centers and 10 international projects and 25 research partners, leading to scholarly outputs of 357 journals in the last 5 years. And the key performance is we have 20 projects with 24 crowdfunding with 20 plus partners, leading to 20 US patents and 6 products with 900,000 people impacted. And our center has been confirmed with World Center of Excellence on landslide disaster reduction. And also the current Prime Minister has lauds our innovation at National Science Congress 2018 for our landslide detection system. So with this, I try to bring in the thought process of ecosystem restoration and how it is connected to multi-hazard, and how can we bring in the resilience by bringing in continuous measurement, monitoring, and also interventions, and again remeasuring and looking at the impacts, so that we will be able to bring in the disaster resilience through the community in a participatory way. Thank you, everybody.
Thank you, Dr. Manisha. Very extensive talk covering a lot of topics. We have a couple of questions. One from Dr. Bruce Malamud. He says, excellent wide-reaching talk. A question about uncertainty. Many low-cost instrumental monitoring methods come with large uncertainties, often much more than higher-cost instrumentation. How are these uncertainties cascaded through the models appropriately, including the final decisions made?
So one of them, the first step which we are doing for the handling the uncertainty itself is through the heterogeneous sensing approach. So if we have only of sensors, that uncertainty will percolate as along the models. But here what is happening is each of the sensors are triggered with respect to the conduct. So our data's validity for a particular model is for a specific period of time. So you have the first level warning, which comes with respect to the rainfall aspect. And then the second level will come only when you see also the pore pressure variabilities and its dynamic enhancements, which you are seeing. On the third level, you are having the movements and also the vibrations. So these are helping you in a spatio-temporal. So you are not seeing with one sensor. So now as the number of sensors increases and your wide reach and the heterogeneity is helping you to actually handle the uncertainty, which normally come from a particular one set of sensors. Plus, we have a fault tolerance model. So take the case of like a power variability in your system. So when you have a power variability in the system, you can have either regular spikes, or you can have a fault where it remains at one value. If you are not able to capture, you will always use it for that. So we have an algorithm which automatically captures that, tag it and remove it before it is taken for the analysis. So as much as possible, all those faults are captured before it is sent to for the analysis. That's how we are handling the uncertainty, and we are still improving at different ways and taking forward.
Thank you. Another question on how do you determine the depth at which to place the sensors, and also how many sensors to place?
So basically the depth of the sensors is through geological survey, which we do. So we do ERT surveys. We also do the field evaluations, and based on that, we understand where is the slip surface. And with respect to that, we deploy systems way below the slip surface. And most of the places where it is reachable, we had gone to bedrock. Like if you take the Munnar, the toe regions, we were able to reach the bedrock, whereas the crown region, we were not able to reach the bedrock. So we had, wherever we were not able to reach the bedrock, we went down way below, and based below that up to the weathering layers, so that it is still hard enough for it can hold the deeper probe. And also when you are doing the borehole drilling itself, we do in situ testing to understand the different soil layers, how their behaviors, and based on that we decide where the sensor has to be there. So it is very specific, site specific decisions are taken on where the sensors on what configuration we need to keep the heterogeneous sensors.
Thank you. Another question is data stored in the cloud?
Yes.
Okay. And another question, many thanks for the excellent talk. I'm curious if satellite-based remote sensing is used in your approach. There are numerous satellites that provide high-resolution data, example, Sentinel.
Yes, I understand your question. I have not used satellite-based remote sensing yet. We are looking into it, because earlier the project which started off was as the FP6 funded project from the European Commission as WinSoc. That's when we started. So at that time, the project demanded as an in situ monitoring, because they wanted to look into the usability of wireless sensor networks. That's how we started off. So we are more into in situ based looking into it. But now my other colleagues are looking into satellite based aspects, not me.
One last question. Please explain the type of control system used for the installation of sensors for acquiring real-time data.
Control system means, so we have, I don't know what you are intending to say as control systems, because we developed, we have bought off-the-shelf components. So we have used VASP modes, we have used MiCA-Z modes as the things were changing. We developed our own interfacing circuits. We developed our own renewable energy systems with the solar microgrid systems. Each of the DEP is actually charged through the solar microgrid system. So, and the controls and everything is done from the Amrita side.
Okay, I think we can stop with that. I don't see any more questions right now. I do encourage the audience to keep posting questions, and Dr. Manisha would definitely look at them and answer them. So I would like to thank Dr. Manisha for her talk and move on to the next speaker. Thank you, Dr. Manisha.
Thank you, everybody.
Our next speaker is Dr. Dilip Krishnaswamy. Let me give a brief introduction to the speaker. Dr. Dilip Krishnaswamy, his research interests include developing and applying new and emerging technologies to solve new problems. Current areas of interest include distributed information processing, 5G networks, edge services, network slicing, microservices-based systems, blockchain technology, machine learning, deep learning, AI, autonomous systems, parallel processing, quantum algorithms for optimization. His current affiliation is, he is the Vice President, New Technology R&D of Reliance Jio Platforms Limited, India, exploring new technologies such as 5G, blockchain, quantum processing, AI, ML, developing microservices-based platforms for applications of such technologies. He got the Technologist of the Year 2020 award from IEEE Bangalore. He has been recognized for team effort at the 11th AG's Graham Bell Awards, the Leading Lights 2020 Awards by Light Reading, and the Enterprise Blockchain 2020 Awards. He's an adjunct faculty at Indian Institute of Technology, Delhi. His prior work experience includes the following. He was a senior scientist at IBM Research, worked on research and engineering solutions related to machine learning, deep learning, blockchain technology, distributed function virtualization, IoT, smart cities, smart energy, gravitational waves, data processing. Senior staff researcher in the Office of the Chief Scientist at Qualcomm from 2006 to 2013. Worked on research and engineering solutions related to personalized machine learning in mobile devices, self-aware systems.
Yeah, I think
okay.
we can.
Maybe I just mentioned that, the heading. So before that, he was a platform architect at Intel Corporation from 97 to 2006. And before that, he was part-time faculty, not before that, in parallel, he was part-time faculty at the University of California, Davis. So with that, I would like to, invite Dilip to the stage, and his topic of presentation today would be distributed edge microservices based IoT and ML platforms for managing ecosystems and multi-hazards. Thank you, Dilip.
Yeah, can you see my screen?
Yes, just switch to, yes.
Oh, great. Thank you, Professor Setu, Professor Manisha. It's always really nice to connect back with both of you. You've been doing great work with the OceanNet and the landslide management and all of that. I just wanted to bring some perspective based on some current work that I'm doing that perhaps may be useful in terms of how you actually architect and design some of the systems that you've already worked on, hopefully it will be useful. The work that I'm describing is actually being implemented for India's 5G deployment with IoT-based support and machine learning being support and all of that. So this is active work, and some of the learnings from that I just want to convey to you, so that maybe some of the applications that you might develop might benefit from some of these thoughts. A lot of it you probably already know, but just wanted to review some of it, especially for the students who may not be fully aware of these some of these trade-offs. Our emerging infrastructure, beyond 4G, has, especially in the cellular space, has become increasingly virtualized. And so even scaling 4G is now with virtualized network functions, for example, and as opposed to, say, hard Intel server boxes, actually implementing the function. And with 5G, it's completely virtualized. Every function, and you might have seen reports, we have actually completed the implementation for the 5G core, different functions. All of that need to come together, and all of that is implemented in software. And all of these functions, whether it's authentication or user management, mobility management, and things like that, all of those functions are all implemented independently and all put together and stuff. So that's with the core network. And then there is the radio access network, which is in the research community is just being developed. So you see, normally we talk about remote cloud, in-network cloud, an edge cloud. There's also an access cloud. As we go forward, we have what are called intelligent controllers for the radio rig. They're called rigs, and they could be near time or non-real-time rigs that will actually manage the wireless access at very low time scales, and some of the optimization functions that will operate we have to be very close to what are called the central units and distributed units that would actually serve users. So what was normally like an just an base station or an access point, all the functions that were there are actually getting split into what's called a CU, DU, and an RU, central unit, distributed unit, a radio unit. So a central unit could manage multiple distributed units, and the central unit may implement some higher levels of the protocol stack, like RLC, PDCP, and stuff. Then the distributed units may operate more of the lower level MAC and upper PHY functions, and then the radio units might do the lower PHY and RF kind of functions. So, and then there's programmability across all of these levels and control, and that is currently being defined in consortiums like ORAN, Open Radio Access Networks, and stuff like that. So a lot of virtualization is happening everywhere. We've had cloud applications and things like that with support from Google, Amazon, Microsoft, and all of those guys. Our in-network virtualized infrastructures, the network itself is being virtualized in the in-network cloud, and the edge cloud was being developed for edge applications, but now the access cloud is also being developed for really low latency optimizations, because with 5G, we have what are called URLLC based applications, ultra reliable low latency applications with, turnaround times of the order of milliseconds. And that you have to really, the data has to come in your process really quickly, if it's the mobility of a drone and things like that. So, so all of these things are happening, and everything is getting virtualized at all levels, as you see. And so we have local and distributed processing at all of these levels. The lower levels are more resource constrained. As you can imagine, there'll be less compute storage bandwidth, less energy, and very high latency sensitivity at the lower levels. You have to manage and orchestrate functions at each level and across the levels. We have what's called end-to-end slicing. So you would allocate resources. So if it's very low latency, disaster management, that needs extremely sensitive resources to be allocated for that dynamically. So what would happen is, most of the time those resources will not be there. But the IoT warning system from, Manisha's landslide detection system says, hey, you got to do something about this, inform all the people, to move and, start sending messages and get movers to get people out of there and things like that. So you'll have to suddenly start allocating resources for all kinds of communications and computation and things like that. So that would be a dynamic network slice that would operate at multiple levels depending on the latency sensitivities and the performance requirements. So so you would allocate that slice and then utilize the virtual resources across the slice. Now, and so at each level, though, you have microservices-based solutions, and they would work across these levels and typically use Docker containers and Kubernetes or Docker Swarm for orchestration that helps in auto scaling. These distributed microservices-based solutions would work across levels. Now, any level can connect with any other level. The reason I say that is because the networking stacks can be collapsed. So that what is, say, in 4G, you have the S gateway, P gateway, and things like that. All of those things can be collapsed, right? So you can directly communicate from a lower level directly to, say, Google YouTube or Google Cloud or something like that. So you don't have to go through those levels that we saw in this, right? You can just bypass directly, say, from the edge cloud to the remote cloud by collapsing stacks. So one thing about the microservices-based paradigm is we really want to break down what's a typical monolith project into different functions that are realized as microservices. Say it's authentication or IoT, event, data processing, data storage, learning engine, prediction engine, a warning function, and so on. Each of them, you create a different microservice, and then you chain the microservices to realize an overall required capability, right? Maybe the event processing says, nothing much to do, just store it. So then you don't go through the whole thing. But if the warning function needs to be triggered, that's a different service chain. But you shouldn't create microservices blindly. Like, if you just want to do the square root of a number, you should have a microservice for that. So, you should have some coarse level of granularity in each microservice, and we should focus on independent scaling. That is, if you notice that two capabilities of services always go together, then just keep them together. You don't have to break it down, because every time you break it down, you have communication costs for one microservices to call the other, and that increases the end-to-end latency. But then if you see that one function can operate independent of the other, like the warning function does not always have to get triggered, then that can operate independently of the IoT event data processing service, right? So we can keep them as separate microservices. And some of the key considerations are like these microservices interact with each other via an API gateway. Typically, they're RESTful APIs that are used to call between them. Now, each microservice can scale independently, so that you'll have multiple instances. So depending upon, so let's say a microservice can serve 100 devices. Then if you need 700 devices to be served, you need 7 instances of the microservice, for example. And so depending on the dynamic performance requirements, you would scale it. Now, a load balancer front ends these instances, and typically these microservices are stateless, so that, and I'll come to that in the next slide on state management. But the so as an event comes, the load balancer can just route to any instance of the microservice. Whichever microservice may be less loaded at that time could get that task, that kind of thing. And these implementations are done RESTfully with one microservices, making a REST call towards another microservice. But there's an API gateway on top of all of this. It receives a call on behalf of a microservice and sends it to another microservice, but it's the load balancer that front ends the microservice across that actually receives the call and then routes the call to one of the microservices. So a lot of stuff can be done RESTfully and things like that, accessing resources from one place to another. But you also need pub subsystems, for proactive event management, such as an MQTT or AMQP broker. This can trigger a chain of microservices that can take action based on an event. So think both RESTfully and PubSub when you do these implementations. Now, stateful versus stateless and state efficient, I wanted to say, typically we try to design it to be stateless so that any instance can take on any task. So that means that when you want to process a task, you actually have to fetch the current state, take the current input, and then decide what the next state of the system is. So the state comes from somewhere else, like in 5G, there's what's called the UDSF, or the unstructured data storage function. So all the microservices operate statelessly on top of that. They'll fetch the current state and then update it if required. But then you have to be careful in terms of managing data consistency, coherence. That will come into play as you design the system. Now, if the microservices are stateful, then they keep the state internal. And then it becomes difficult to scale because you have to know which microservice contains which state and go to that. Now, it does become necessary, though, to maintain state from a latency perspective. For example, if you have to manage the mobility of a UE or a drone, and the drone is really moving fast, and you can't afford the time to go to a data storage function, fetch the state, modify it, and things like that. So every time an event comes for the drone, you actually have to go to a specific instance that's actually actively managing that drone at that given time, and then change its state. So you try to be state efficient at that point. So at low time scales, you try to manage the state within the microservice, but on a larger time scale, you're like still operating in a stateless manner. So think of it that way. So, and then, so the event router will have to actually, or the API gateway will have to remember which microservice is supporting that drone's mobility and manage that state and route events to that instance. So it becomes a little tricky, but you have to do that, and then latency becomes important. So to actually then bring it back to the theme of this event, I think we can apply all of these concepts and develop solutions based on microservices. And we are seeing that, as people are presenting, different teams are working on different capabilities. One is for a flood warning system, one is for landslide management and things like that. And if each team builds a microservices-based paradigm in their respective geographies, potentially, we can build, combine capabilities across different teams and integrate that to support multi-hazards across the globe. And then also maybe, as you fuse information, you can also design some intelligent microservices that help with research collaboration, or just fusing information, the climate or rainfall information with sensor information, like Manisha does for line side management, to create a warning system. So you would attempt to fuse information across different systems and create microservices that utilize that. And latency insensitive learning engines can slowly adapt, based on aggregate batch data in the background in, say, in a remote cloud. But the inferencing engine, for example, can be at the edge and actually doing things at a lower time scale. So, so this is the last, slide. So overall in this framework, you would be doing distributed processing and adaptation. The timescales for adaptation can vary significantly for the scope of this, the theme of this event. Hazards have to be managed very proactively at low timescales, while climate change is impact happens slow, but it's predictable as to what's happening on a larger time scale. But so the models that you implement are operating at different time scales. So, when you think about this hierarchical architecture, you really want this resource constrained edge resources to be utilized for low latency services to take proactive action, for warning systems and stuff like that, and sensing and all of that. And, URLLC technology can be, in 5G can be used for very fast communications. But also you can use distributed learning, and then edge models can be different from an aggregate cloud model that learns across the edge. And then the cloud model could be propagated back to the edge, saying, hey, use this as more of the average model across different areas, and maybe have an additional weightage for your own local edge model to come up with an overall model. So the aggregate cloud model performs an averaging effect across the edge models. Now the learning processing can be done for deload tolerant applications at a remote cloud. And you can study the impact of human actions in global climate change, with cloud resources. You don't have to actually utilize edge resources for the same. And then network slicing can be utilized to allocate resources at these different levels for compute, storage, latency requirements, as I mentioned earlier. So to summarize, I think we can think about how to partition different functions and microservices at different levels in our virtualized networks to best utilize the resources that are there. And we can support IoT processing, learning, prediction, adaptation at different time scales with different resource constraints, and distributed processing and managing state as well. So, and hopefully, we can build these solutions and collaborate globally. And also, as part of the collaboration, think of some fusion microservices that goes across some of the learnings of different groups to actually create something more interesting to help with research collaboration for multi-hazards or ecosystem and climate management. So thank you. That's all I had.
Thank you, Dr. Dilip, walking us through the power of microservices-based architectures and what they can enable, and how they can help with collaboration. Let me see if I have any questions. Yes. Well, it's more of a comment from Dr. Manisha. So while we are waiting for questions from the audience, I have a question for you. When we talk about 5G enabling the softwareization, virtualization, granularization of services, in terms of microservices and all that, what are the enablers in addition to the obvious ones such as high fast compute and faster communication links? What other enablers have made it possible for this kind of architecture to be realistic?
See, as we as things move forward, we see like different technologies coming together, and not independent, operating in isolation. As data is coming in, you're actually performing some learning on it actively, some prediction based on some inferencing model that has already been learned and things like that. So that's where and maybe we also use blockchain technology to record something that's trusted and things like that. So when you develop different microservices based platforms for different capabilities, you can invoke any capability you want and create a larger service chain of tasks that actually gets executed and scaled as needed. So it helps in actually creating more interesting solutions, putting it together, because the best solutions come when you actually collaborate and bring different ideas together. And each of those ideas might have been developed in isolation. Somebody might have developed a really good optimization algorithm that could be applied with if the input is provided in the right fashion to that optimization microservice. And the person who developed the microservice may not, for optimization, may not be aware of the domain knowledge that is there for that particular use case. But the person who understands the use case is not knowledgeable about optimization per se. But the two can work together through an API saying, hey, just give me this and I'll do this for you, give it back to you, that kind of thing, right? So it really helps in building solutions together and helping collaboration and things like that, and combining technologies, I think.
I mean, my question was this kind of a thinking has been there. It is not new, but somehow there were overheads and things were not feasible, but now it has become feasible. So what is the difference?
Oh, well, actually, the biggest thing was that, it was that all these networking protocols and all of that kept going through release 11 to 12 to 13 to 14. And every time, you have, you certify a hardware box for release 11 and then a hardware box for release 12, and then you take out the old box and bring the new one in. That is too cumbersome, right? So instead you just take down one virtual function and start off another one, right? So for the new release, so the virtualized, see the hardware cycle for changing, say Intel's compute is, if you buy a server, it will work for a few years. But these, the software development is much faster than hardware changes at this point. So it makes it easier to reuse hardware through this kind of cloud, so-called cloud deployments at all levels in the infrastructure. And then you can also add additional resources for for machine learning, acceleration, and things like that, and augment that infrastructure as well. So yeah, it's mostly the software development is happening very rapidly, and compared to the hardware. So it makes sense to do something like this.
Okay. Okay, here is a question. Is 5G technology safe for the flora and fauna as compared to 4G?
Yeah. I think, see, but I worry about 6G though. I mean, these frequencies are fine. We are, and there are, so we are, to actually dislodge an electron from its orbit, we have to go past into maybe hundreds of terahertz or something like that to actually cause ionization. But when you're operating, our Wi-Fi and all has been operating at say from 2.4 gigahertz to 5 gigahertz as well, right? So we've been using that. It's now getting into, so in 5G there are two bands, right? One is a sub 6 gigahertz band, which is essentially the same frequency that Wi-Fi is operating, but the bandwidths are lower. So but if you operate in the tens of gigahertz, maybe say at around say 30 gigahertz or something like that, the frequency is slightly higher, but it's still several orders of magnitude lower than what is required for ionization. So it's not a problem, though. In 6G, I think they talk about terahertz. I think we should restrict to maybe the lower end of terahertz and not not be too over ambitious in terms of how much bandwidth we want to leverage. But I think 5G is okay, definitely.
Okay. At this point, there are no other questions. So I would encourage the audience to continue to type in questions, and Dr. Dilip would be available for some more time. So, you can directly take your questions and respond in the chat window. With that, I would like to thank Dr. Dilip Krishna Swami for taking the time and walking us through the work he has been doing at Geo. Thanks, Dr. Dilip.
Thank you.
Thank you. So I guess with that, we are coming to the end of this session, and we move on to a panel discussion now. So I'll hand it back to the central team to take it over from here.
Good morning, good afternoon, good evening. I guess I'll take it over from here, if that is correct, with the team.
Yes, please go ahead.
Okay. So my name is Joost Monks. I work at the University of Geneva. I'm very privileged and honored to chair the first panel discussion that we have as part of the symposium. We've had a very rich program so far. It feels like embarrassment of riches. I've learned so much, and we will certainly learn more in the very compact session that we will start now. The idea is to move ahead, but also try to see whether we can start picking up some learning points, some takeaways that can feed into the rest of the symposium, but also in the concluding remarks that will be given at the end of the symposium. So the panel has the name Impact of Climate Change on Ecosystems and Multi-Hazards, Challenges and Approaches. We would like to focus in particular on three issues. That is, one, to develop techniques and strategies for disaster reduction, sustainable restoration and monitoring of multi-hazard and interrelated effects. That's one. Two is, what are innovative approaches to tackle multidisciplinary impact of climate change, both on the local and on the international level. And third, and that is a very important topic that has been running through the symposium so far, what are new technologies? What are the promise of modern technology, such as IoT, machine learning, and artificial intelligence, to protect biodiversity and enhance safety and food security across the world? To do that, we are very lucky and very honored to have a distinguished panels of speakers. We'll have 8 from India, Sri Lanka, North America, and Europe. I will very briefly present them now. I'll say a bit more when each of the speakers will get the floor. We'll do this as follows. After this very short introduction by myself, each of the panelists will have a 5-minute presentation on key research or work that they've been performing. Then I would like to open the discussion, the panel for discussion. And I would first like to invite the panelists among each others, maybe to ask questions, also in terms of clarification, before opening it up to the larger audience, where we can take questions through the Q&A functionality that is provided by Zoom. So, as said, 8 speakers. Let me just first present Dr. Casagli from Italy. He's the president of the International Consortium of Landslides, and I think we see him online. Yes, hello. Hello, Professor Casagli.
Hello, everybody.
Pleased to meet you. Then we will have Mr. Hovale, and you have to apologize if my pronunciation is not correct. He's the country general manager for Bosch Rexroth. Then we have from Japan, Mr. Yasukawa. Do I see him? Not yet. I guess he will join shortly. Who works with UNESCO. So that is the international perspective. Then we have Dr. Vishwanathan. Hello, thanks already for putting on your camera. Landslip lead investigator at Practical Action in India. Then I have Dr. Sankaranarayanan. Sorry for my pronunciation. Adjunct professor at the Amrita Center for Wireless Networks and Applications, Amrita University. We have Mr. Dr. Matjas Mikos, all the way from Slovenia. Pleased to meet you, sir. Former Dean of Faculty of Civil and Geodetic Engineering at the University of Ljubljana in Slovenia. And finally, last but not least, from Sri Lanka, Mr. Diaz, who is the Additional General Manager, Natural Resource Management and Laboratory Service of the Central Engineering Consultancy Bureau, Ministry of Irrigation of Sri Lanka. Pleased to meet you, sir. So without further ado, I would like to give the floor to Mr. Yasukawa from UNESCO, as said, program specialist on disaster risk reduction, earth science and geohazard risk reduction section of UNESCO in Paris, France. So Mr. Yasukawa is the program specialist for the DDR at UNESCO since 2013. He's in charge of coordination of DRR activities across different sectors to promote multidisciplinary, multi-stakeholder and multi-hazard approaches. I mean, this multi-approach is really something that we need, and we'll very much look forward to hearing more on that from Mr. Yasukawa. Before joining UNESCO, he worked at the Ministry of Land, Infrastructure, Transport and Tourism in Japan, and at the Cabinet Office of the Japanese government on infrastructure management and international cooperation. So without further ado, Mr. Yasukawa, the floor is yours. With your permission, do I see him actually online here? Are you with us?
So.
Oh, there he is. Yeah, there he is. Yeah. Mr. Yasukawa, are you with us?
Yes, I am with us.
Okay. Please.
Sorry, no, yeah, because the connection got disconnected, so I share with my screen first.
Pleased to meet you. With your agreement, distinguished panelists, since we are 8 speakers and we have a good hour, I would like us to stay within the time limits. And with your permission, I will also sort of try to guide the discussion so that we stay within those limits and that everybody has the opportunity to express and also to give the floor to the audience should there be further questions. Without further ado, Mr. Yasukawa, the floor is all yours.
Thank you very much for your introduction, and good evening, good afternoon, ladies and gentlemen and colleagues. Yes, today I would like to share with you what UNESCO is doing concerning the subject of this symposium. So, as I introduced, I'm working for the UNESCO for disaster risk reduction. So UNESCO is a UN organization which has a mandate on education, science, culture, communication, information, and social science. And under its mandate, UNESCO is working on disaster risk reduction on different manners. So our intervention on disaster risk reduction, DRR, has a three big approach. One is a multidisciplinary approach. Second one is a multi-hazard approach. Third one is multi-stakeholder engagement. Yes, for the first approach, multi-stakeholder engagement, yes, as I mentioned, we have a different mandate: education, culture, science, etc. So in our intervention, especially to try to support the member states, we try to combine a different perspective for the solutions from science, education, or education, culture, and so on. For multi-stakeholder, multi-hazard approach, UNESCO is working on different early warning systems such as flood, drought, tsunami, or earthquake and landslide. Yes, I think we need to work separately, but at the same time, we always try to make sure that we have a same understanding of what the earthquake early warning system is. So we try to bring drought and the landslide at the same time when we approach the government. And multi-stakeholder engagement, yes, I think this is one of the Sendai framework priority of action number 2. Yes, our UNESCO's primary customer is the government or policymakers to support, to reduce the risk. But at the same time, we try to engage as many stakeholders as possible, not only on the government, but also like academics or citizens or civil science, civil societies such as youth or vulnerability groups. We think it is important to engage as many stakeholders as possible in the planning phase, so that when we implement the planning, I think it has less trouble, or we can implement the plan smoothly. So these are the three basic approaches of UNESCO. And then maybe you see my screen of our UNESCO's DRR poster. So I just scroll up and down to share with you what UNESCO is doing concerning the subject of this symposium. So first one, I want to go to this STI, Science, Technology, and Innovations. Yes, UNESCO is trying to explore the possibilities of ICT. Here, ICT includes artificial intelligence or big data. At the same time, we try to include local indigenous knowledges. So we see this ICT to, we are exploring the ICT, their possibilities on disaster risk reduction. And one of our flagship project is in East Africa. We are trying to develop a mobile application, which is an AI chatbot. So this AI chatbot, citizens and the government or decision makers can communicate each other to get the information, to send the information. For example, after the disasters, citizens can communicate with this AI chatbot, which is powered by the language analysis tools by artificial intelligence. So, yeah, for example, citizens can ask this chatbot, AI chatbot application, where to evacuate, where they can get food, or where they can get medical support. Then, powered by this AI chatbot will tell you, based on the locations the user is there, they tell you, okay, so from where you are, maybe this is the closest shelter, etc. So we try to, and I think this UNESCO chair, Amilat, I think they are working heavily on Internet of Things. I think we have things to collaborate for this domains. And the second one, I want to go to the pillar 6. This is about the ecosystem-based, nature-based solutions. Yes, there have been many pilot project, not only by UNESCO, but many organizations to test nature-based solutions. And UNESCO or other UN agencies as well are now thinking that it's time to scale up not only the pilot, but try to make it like a, regular solutions, like gray solutions, infrastructure solutions. So we are now working with a big project in targeting the European countries on nature-based solutions to try to test solutions by engineering. At the same time, we try to do a multi-stakeholder approach because conventionally nature-based solutions are always discussed among environmental experts. But now we are expanding the stakeholders to the government or citizens or even private sectors so that people are more familiar with these nature-based solutions. And UNESCO is a member of the PEDO. PEDO is a platform for EcoDRR platform, which is an interagency, UN interagency platform, which is chaired by UNEP. And so UN organizations are trying to work together how we can promote this ecosystem DRR. So we are doing like advocacies or research and capacity buildings. And I think UN agencies are working together how we can promote and scale up nature-based solutions. I think I still have time, so this is going to be the last one. So I want to go to the second pillar, which is an early warning system. As I mentioned, UNESCO is trying to work on the multi-hazard approach, and UNESCO is working on the early warning systems on multiple hazards, namely tsunami or flood and drought, earthquake, and I see many colleagues from the International Consortium landslide today, but we also try to explore how we can work on the landslide early warning systems. So these are, yes, these early warning systems, yes, as I said in the beginning, yes, we cannot mix tsunami and flood on the early warning systems, but at the same time, we need to have like a baseline. What will be the basic steps for developing the early warning systems? UNESCO is a member of the International Multihazard Early Warning System, which is also an interagency international platform to discuss about the possibilities of multi-hazard early warning systems. So many organizations like WMO or UNEPs are working on the meteorological hazard. So UNESCO is trying to bring the element of geohazard such as earthquake or tsunamis, so that we try to discuss the differences or the commonalities of the early warning systems on geohazard and weather-related hazard. I don't know if I have time, but yeah, so this is my presentation.
Thank you very much, Mr. Yasukawa. You know, I'm very aware that 5 minutes is very challenging, and I thank all these panelists in advance, you know, for taking on this challenge. And it's really about, you know, it's fire sessions, bringing out the key ideas. What I retain from you, and I'm not summarizing the whole thing, but you really stress this need for holistic, multidisciplinary, and multi-stakeholder approaches. And I think this is a theme that will run through our panel. And on this, I would like to give the floor to Professor Casagli, if that is correct, pronounced correctly, the president of the International Consortium of Landslides, professor of engineering, geology, Department of Earth Sciences at the University of Florence in Italy. Very impressive CV. I don't want to list everything, but he, amongst others, he was the president of the National Institute of Oceanography and Applied Geophysics, founder and president-elect of the International Consortium on Landslides, founder and associate of the UNESCO Chair on Prevention and Sustainable Mitigation of Hydrological Hazards, Currently professor of engineering geology with the Earth Science Department in University of Florence, as I already said. Author of more than 500 scientific publications, holder of 4 industrial patents, and also very important, he was awarded the Order of Merit of the Italian Republic. So we're very privileged and honored to have you with us, Professor Casagli, and without further ado, the floor is yours.
Thank you very much, Mr. Chairman. Can you hear me well?
We can hear you loud and clear.
Hello to everybody. Activity of the International Consortium of Landslide for Disaster Risk Reduction. Landslide are slope movement of earth and rock, which very often are part of multi-hazard chains. This is, and we can see from this list only of the biggest slide are socio-economic problem and main threat for the safety of. This is the last landslide who took more than 1,000 victims in Sierra Leone, Freetown, a debris avalanche. The landslides are particularly major problems in less developed countries. What is the International Consortium of Landslide? Governmental and non-profit scientific organization supported by the main organization of United Nations and as almost 30.
Sorry, Professor Casagli, there's some interruptions in your intervention. We can't hear you all the time, but that should be fine. But just be aware. Thank you very much.
Is my connection that is not good?
It's okay, but just once in a while we can't hear the whole sentence. But please carry on.
Okay, the International Program on Landslide is the program of the Consortium for Landslide Risk Reduction. It is managed by a global promotion committee and supported by 5 United Nations organizations, 2 global stakeholders, ICSU and WFEO, and the International Union of Geological Science. Since 2004, the consortium ran its own journal called Landslides, 12 issues per year, full color. It's, the impact factor is quite good and is the #1 journal in the category of geotechnical engineering. Every 3 years, the consortium organizes a World Landslide Forum. The next will be in Kyoto. It should be in, but it was postponed, like the Olympic Games, in 2021, in November, 6 November. And every year we organize a ICL, IPL, UNESCO conference, usually at the UNESCO headquarters in Paris. Every year we award the Varts Medal, the highest provided by the International Consortium of Landslide, to recognize professional excellence in landslide research. And also we recognize every 3 years a number of World Center of Excellence on Landslide Risk. Coming to policies, we signed together with 90 intergovernmental, international, and national organizations, the Kyoto 2020 Landslide Commitment. This is the signature ceremony at the UNESCO headquarters in Paris. And this commitment is based on 10 actions in order to promote the knowledge of on landslide, the knowledge and the understanding of landslide process, and also the transfer from science to the policies at level, national, regional, and local level. The consortium also has its own series, and these books are dedicated to practical aspects of landslide science. For example, this is one of the last teaching tools, tools for helping teachers in order to better teach in the schools, in the university, landslide science. The next World Landslide Forum will be in my city, in Florence, Italy, in 2023. Thank you very much for your attention.
Thank you very much, Professor Casagli, for a very to-the-point short intervention. You really stayed within the 5 minutes. I think there's much more food for thought and discussion as we go, but I really appreciate your conciseness. Actually, I think I recognized a few people from Amrita University and from this audience on the prize picture, so that is nice to see. So without further ado, I would like to give the floor to the next speaker, Dr. Vasudevan, who currently serves as adjunct professor at the Amrita Center for Wireless Networks and Applications. He has served the Geological Survey of India in various capacities with exceptional merit and devotion. He has vast experience in geological, applied geological, and geochemical mapping and seismotechnics. He is engaged in writing research books, pursuing research interests in geohazards, in particular mineral exploration, geoscience policy issues, promotion and protection of geoheritage sites, and development of a geopark in India, which is very interesting. He has published over 50 research articles in reputed national and international journals, besides writing 40 scientific reports for GSI. So, Dr. Vasudevan, the floor is yours, and thanks again for joining this panel.
Thank you, Professor Monks. Thank you very much for a very lengthy introduction. So I'll straight away focus on the theme that is given to us. It is impact of climate change on ecosystem and multi-hazards. And in particular, the focus is to be on challenges and the technologies, right? So I would pose a couple of challenges that we have been seeing through various presentations that have been made in the International Symposium, which our Amrita Vishwavidyapitham, Amrita University is hosting. One is on geodiversity. You know, geodiversity is the variety of geological environments, and it is the phenomena and the various processes which are operating on the surface of Earth, which is actually gaining ground as part of the Earth surface science nowadays. This is the latest branch. And this supports the biological activities, the biodiversity. So this is the bedrock. This is the foundation of totality of our natural diversity or natural heritage. So we, whatever considerations we discuss on ecosystem restoration must also consider the preservation and conservation of geodiversity also, because geodiversity is the foundation on which various types of soils are formed and different landscapes are developed, various processes are operating. Therefore, we need to conserve and restore the various degradation levels which have occurred because of the destruction of the landscape. And through destruction of landscape, the ecosystem is also getting degraded. So therefore, our statement must also consider conserving the geodiversity. So this is the first challenge on which I wanted to emphasize. The other aspect is since India is an emerging economy, not many people in India are still living in the rural conditions. So there is definitely a digital divide, which was very amply brought out by our National Development Authority member during our inauguration program. Now, this digital divide is more akin to the divide between urban and rural societies. So we, on one hand, we talk about the smart cities and the application of emerging technologies. On the other hand, we still have a lot of conventional heritage-related people which are really grounded to the nature, to the actual rural conditions, and the ecosystem is essentially related with these rural backgrounds. And we know with traditional knowledge, these ecosystems, they were really taken care, particularly in several Indian conditions. We have a lot of rituals respecting the nature and going slow on degradation. But because of the with the latest technological innovations and the kind of speed with which the human beings are accelerating these changes, a lot of landscape changes, a lot of land use changes are happening, which is also one of the major reasons for overall degradation of the ecosystems. So any attempts for ecosystem restoration must please consider these challenges, and our technologies must be so evolved to address both these major points which I have just shortlisted. So thank you very much, Professor Monks, for giving me this opportunity. Thanks to the Amrita University also for having such galaxy of experts attending this panel discussion. Thank you.
Thank you very much, Dr. Vasudevan, for being so to the point and so short. And I join you. I mean, this is an exceptional event. I've learned so much in the very short time that I attended this session. So I totally underline and underwrite the two challenges that you raised and that already came up in previous sessions. That is, one is conserving geodiversity is something that maybe we don't talk enough about. And which should drive our work. And the second is this issue of digital divide that Dr. Thiru Pugas in particular mentioned yesterday in the opening ceremony. And I think this is a very important element, not only between countries, but also within countries. As you say yourself, the rural and the urban divide is something that we need to keep in mind. And we'll get back to that as we go into the discussion. May I now give the floor to Dr. Vishwanathan, landslip lead investigator at Practical Action in India. So presently he's the lead scientist and international climate change specialist with Practical Action India. He has over 35 years of experience in India and abroad in the broader areas of natural resource management, climate adaptation, disaster risk reduction, sustainable agriculture, poverty reduction, and rural development. So it's a very rich background. His early assignments included Principal Director, Armed Forces Ministry of Defense of India, and Joint Commissioner in the Ministries of Agricultural and Rural Development. And in addition, and I find that particularly interesting being based in Switzerland, he also served as Country Director for the Swiss Agency for Development Cooperation, SDC, of the Swiss Ministry of Foreign Affairs. Also like to mention that you are a holder of the prestigious Vishit Seva Medal Prize conferred by the President of India for outstanding services rendered in the armed forces, having served as one of the youngest commissioned officers to be decorated. So without further ado, Dr. Vishwanathan, the floor is yours.
Can you hear me? Thank you very much. Distinguished panel members, participants, at the outset, grateful thanks to the Amrita University for having provided me an opportunity to share a few thoughts and experiences. Although I work now substantially on landslides, and I'm sure you heard a lot of my colleagues speaking yesterday on landslip project, but what I'm going to speak here relates to gender equality and climate compatible development. When I say climate compatible development, a concept which includes mitigation, adaptation, as well as development and disaster risk reduction. So, these experiences were gained in the frame of a multi-country project with case studies in India, Peru, as well as in Kenya, implemented through the Practical Action in collaboration with Overseas Development Institute, London, and also the Institute of Development Studies, Sussex. Well, so I would like to share some parts in terms of the lessons and experiences from this. It also gives me a great pleasure to be talking about gender equality in an institution, I mean Amrita University here, which prides itself as one of the top 10 universities, which figures in the top 10 universities as far as gender equality is concerned. And I think it's important that more and more of men should be talking about gender equality. Also, we have all men panel here, unfortunately. Well, when we talk in terms of response to climate change, adaptation, disaster risk reductions, etc., often the discourse gets confined to the scientific aspects, the economic aspects, the technical and the technological dimensions. But then I think it's also important to consider the social as well as the institutional aspects. I say this because of the differentiated vulnerability. I mean, men and women are not equally vulnerable to impact of climate change. Women are much more vulnerable as compared to men. Women are affected first, and then they suffer the most, actually. But then some of the lessons that we gathered from this 3-year project was that in all our initiatives relating to climate change, especially response to climate change and disaster risk reduction, women are perceived more as victims, and therefore solutions are suggested as women as victims, with little consideration for the knowledge they have, the information they have, the skill set they have, etc. So one important lesson is that we need to consider the women's needs, views, perspectives, participation, knowledge, etc. when we design and plan climate compatible development projects. That's one. Two, often in projects which are responding to disaster risk reduction and climate change, simply the word gender is inserted. No? Like, for example, when you talk in terms of policies or actions or strategies, etc. But then what is important is that we need to go beyond this. We need to ensure that if we want better outcomes for climate compatible development, we need to ensure that the gender sensitivity is integrated right from the conceptualization, design, planning stage, right up to the monitoring and the evaluation. I think this is really important to ensure that the gender sensitive, or even you could say gender transformative approaches are integrated into the project if we want qualitative outcomes, if we want sustainable outcomes. So gender just doesn't mean that we focus only on the needs of women and girls. Certainly not. What we need to recognize is that men and women have different needs, they have different capacities, they have different levels of knowledge, information, etc. And in addition, we also need to take into consideration the existing power relations between them. This is important because this is already imposing a certain level of vulnerability on women, even without climate change in a development situation. So kind of when you have equal power relations and you have climate change coming in, disaster coming in, and that I think they become much more vulnerable. So gender is more about men and women working together to find solutions for disaster risk reduction and towards climate compatible development. So I think it's important that if gender transformative or gender sensitive approaches are integrated, the outcomes become much more transparent, much more sustainable. Another point I would like to mention is that the vulnerability of this is a point which is following the one which I had already mentioned. Vulnerability of people subjected to environmental hazards are rooted in everyday inequality and poverty. I think we need to consider this, because when you look at the adaptation, because there is what we call as a current vulnerability and current adaptation deficit. This is something one could say that this is a current adaptation deficit, and we need to address this before we go into addressing issues of climate compatible development. And finally, often you will find when you go through the project documents, gender is also integrated as something like a cross-cutting thing. There are many cross-cutting things. So gender is also integrated as a cross-cutting theme. No, not really. I think it's important to, if you want to promote gender equality and then in turn get qualitatively better climate compatible outcomes, then I think it's important that gender equality should be an explicit goal at the very start of the project, one of the explicit goals, because otherwise what happens is that during the process of implementation of the projects, it's just possible that these existing vulnerabilities get exaggerated. There is also a danger of perpetuating the status quo and gender equalities. So it is important that gender sensitive approaches are laid down. Gender equality is stated as one of the explicit goals, and it is monitored and evaluated for successful gender balanced climate compatible development. So with this I conclude my inputs. Thank you very much.
Thank you so much, Dr. Vishwanathan. Thank you so much, actually, also for bringing in the gender perspective, the gender lens. I'm not sure, I haven't seen all interventions, but I'm not sure we have spoken a lot about this. The fact is that our panel is 100% male, but bringing in that gender perspective, sensitivity, having it as an explicit goal towards which you also organize your project work, including your whole monitoring and evaluation, is an important aspect. Because as you say, the most vulnerable in case of a disaster first tend to be the women. So I thank you very much for bringing this in. I would like to move to the private sector perspective, so to speak, and if I may, with Mr. Hovale. Mr. Hovale is an engineer, a graduate from Mysore University in electrical and electronics engineering. Currently, he serves as the general manager at Bosch Rexroad India in marketing function and partner management functions. Prior to this function and work with the Bosch, he worked in the automation field in very reputed international organizations, corporations such as Siemens and Rockwell. I think it's also important to mention that you are deeply interested in transformational leadership, meditation, support society through education, and have this compassionate perspective on your engagement. And I always like to say Amrita is compassion in action, and I think the participants also show this. So without further ado, Mr. Hovale, the floor is yours. Please.
Thank you, Chair, for giving this opportunity for me and also to the Amrita University. I come from the industry, so I talk from the industry perspective, but the performance of the industry has a huge bearing on the way we use the very scarce resources or very rare resources around our environment, right? So when we talk about leveraging the artificial intelligence, the IoT in keeping our ecosystem in place, the industrial automation and the data handling takes very important role to be of most critical actually. When you talk about artificial intelligence, what matters the most is the amount of data, the quality of data, and how relevant is the data, right? If you look at this actually, this is the bottommost level where large amount of data is collected about how my manufacturing or a plant is performing. If my plant is performing to the highest efficiency, that means it consumes less water, it consumes less compressed air, it consumes less energy, it consumes less steam, it consumes less of other resources, and it is performing it to the optimal efficiency level. Then I say there is a sustainable productivity and it is a sustenance on the environment also, so that there is no loss of energy over there. To make it workable, to measure how their various equipments are performing, are they up to the mark, are there any deviations, we get all those data collected through the sensors and actuators up to the machine level, to the ground, across the shop floor. Okay, so this is where really the big data starts collection. Then we get into the different processors, get them processed, clean the data, get it to the remote access or to the cloud, where I convert this big chunk of so-called big data into a decision-making version, or where it will help in such a way that the decision makers are able to take a informed decisions, so that the positive outcome is really visible across. So this is really the IoT architecture. It can be scalable to any extent. If you look, the big data starts from here, then the data cleansing. As we go up and up the decision level, the data level is less. It will be more of a visualization form, where we use the visualization system to get to know which are the pinpointed action to be done to get the desired outcome. So this is replicable across different industries. We can emulate into the other industrial area also, even to the non-industry. We talked about biodiversity and protecting the environment. We implemented similar system where different sensor data of the humidity, the temperature was captured into a tomato plantation plant, which will give an indication based on the AI whether there is going to be a fungi attack on those plantation. So that's how we are able to protect the plantation from the very disastrous attack from these insects, so that we take early preventive measures. Farmer gets advance alert. He takes the advance action to keep the temperature low and use the right preventive measures to avoid these fungi. So that's how we are able to contribute towards ecosystem also. So that's from my side. Thank you very much.
Thank you very much, Mr. Hovala. I think we'll have the opportunity to listen to you also after this session.
Yes,
you'll do
yes,
a keynote. So, but thank you for just pitching this. Very concrete. What kind of practical use and what kind of practical use your corporation works on.
Thank you.
Most welcome. I'm now very honored and pleased to welcome Professor Matthias Mikos from Ljubljana. He's the former Dean of Faculty of Civil and Geodetic Engineering. He's a really renowned international expert in the field of engineering, of hydraulic engineering and hydrology. Technical terms sometimes for me. He is the chairman of the UNESCO Chair on Water-Related Disaster Risk Reduction at the University of Ljubljana. Presently, he's a full professor of hydrology, chair of hydrology and hydraulic engineering at that same university. Last but not least, maybe I would like to mention that he has been working extensively with the Slovenian Research Agency, where he participated in 21 research projects, of which he led 8, and he's been the head of the Water and Geotechnics Program Group of that research agency. So without further ado, Professor Mikos, thanks again for taking your time and for joining us.
Thank you, Chair. Thank you for this introduction. I would like to, of course, congratulate at this moment the Amrita University to organize this international symposium, and I hope that I can bring some ideas to this panel discussion. What I've put together is basically based on my past experiences when I worked as a hydrologist and as a hydraulic engineer. During my fieldwork in ungauged experimental basins, and from my own understanding what climate change is. So I can see some of challenges with regard to multi-hazards and water as a constituent part of the ecosystem. So firstly, I think that better understanding is needed of the dynamics of climate change, and especially to comprehend its diverse impacts on the water cycle and as a triggering factor for a chain of multi-hazards. Secondly, better deployment is needed of the existing cutting-edge technologies and of course of the emerging ones that will come to monitor climate and environmental changes. We heard already a lot of that yesterday and today. I believe that we shall find ways to take advantage of remote sensing techniques, including drones, and Internet of Things, machine learning, artificial intelligence in our so-called digital twins, let it be of water or earth, to live in a safer world. I think that the importance of early warning systems for DRR of many versions, local or regional or national wide, will raise based on ensemble predictions and possibly artificial intelligence support systems, but they should be used by experts to minimize automatic errors or false alarms. We do not want to have them. I think that cyber risks are also important. They should not be neglected in these times of new technologies. And of course, possibilities like cloud computing, big data, and so forth. To add something maybe new is that improvements are needed in our educational system. I'm coming from a university. I think this is needed to better integrate climate change related questions in our curricula at all levels of education, starting in primary school, and to develop open technologies for and to use already existing open educational resources and open learning tools to a larger extent. Already mentioned by Mr. Yasukawa, UNESCO chairs and networks are playing, I think, a crucial role in these efforts. Adding to that, lifelong learning should be supported and promoted to enhance different policies, as already mentioned, like active citizenship, lessons learned, building back better, nobody's left behind, gender equality was mentioned already. To mention that in higher education in Europe, we are trying to establish several networks of universities from different countries with similar visions and strategies to develop joint programs. I think this is a good way. And it is important to open their own sources to a larger number of students. So I think that internationalization of education sector is an important part or a contribution to deal with climate change. Furthermore, during this epidemic, virtual universities will emerge, but I don't think this will be the right answer, but maybe part of it, so-called virtual laboratories to enhance competencies of a large circle of students without access to different labs at their own universities where they are enrolled, may be a potential breakthrough in selected fields of engineering and natural sciences, not everywhere, but in specific fields. Furthermore, open science should be supported as much as possible, especially, I think, by opening data repositories so that research data will be freely available to researchers around the world. Multi-hazards, I think, can be comprehensively understood and mitigated better by joint international efforts, especially in case of large-scale transboundary events like tsunamis, large floods, heat waves, or droughts that hit many countries, let's say, just in Europe. We need partnerships. One example can be Water for All partnerships in Europe that is developing in the field of water science or water sector, or the ISDR-ISCL Sendai Partnerships 2015-2030 for global promotion of understanding and reducing landslide disaster risk, all, of course, in our efforts to overcome just small-scale research or national and local policies to bring them to the international level. We heard from the president of the ICL that Sendai framework for DRR is a good joint platform that asks for different commitments, and one was already mentioned by Professor Casali. This is the Kyoto Landslide Commitment 2020 that was initiated by the International Consortium on Landslides. One thing is, I think, also important that the definition of risk as a multiplication of hazards, vulnerability, and exposure of elements at risk should go into adaptive risk management, where we do not directly combat nature or hazards, but we will adapt to natural laws by understanding risks as consequences on nature and society, and to decrease these consequences or minimize negative consequences. We can promote so-called culture of living with natural disasters. They should be promoted In which way? By increasing especially social resilience in all forums to lower their negative potential consequences. And this should include individual self-responsibility for disaster risk reduction, of course, if possible. There are many there is multiple hazards available. There is a short photo or drawing from Van Westen paper recently, well, in 2013. So it's not very easy to deal with multiple hazards, but I think that an important part of our further dealing with them should be fully acceptance of uncertainties in our models. When we plan structural and non-structural measures, we heard that already. There were some questions in discussions today. And especially tricky in our models are unknowns that show that our understanding of mutual and compound hazardous events is of course not perfect. I think to conclude that we will advance our society resilience against multi-hazards only by decisive and smart steps. We have seen quite a lot of them today, where technologies play a major role, but not, of course, the only one. Thanks for your attention, and I think that we will discuss some of these issues later at the panel discussion. Thank you.
Thank you, Professor Mikos, for this very rich material that you presented, which would lend itself to a full day of discussion. I note in particular, I mean, technology is very useful, but keep the human factor. Look at cyber risks also, and in particular also build understanding through education of not only climate change, but also how technology and how we can sort of deal with that. And I think that is important, came through on various occasions, particularly important probably at the community level. That's where it has to be grounded. But maybe we'll come back to this issue in the discussion that we'll have. I'm now very pleased to welcome Dr. Sankaranarayanan, who is an associate professor, Faculty of Business and Information Technology in Ontario Tech University in Canada. Thanks for joining all the way from Canada. You are an interdisciplinary researcher whose current focus is on the use of machine learning algorithms to build better decision aid models in particular. Working with Amrita, so you're also part of this community. We very much look forward to your brief presentation.
All right, good morning. Am I audible? Wonderful. A very good morning to all from the East Coast of Canada. And Dr. Monks, I don't envy your position of speaking all our names. So I appreciate you taking that effort to say our names properly. I appreciate it. And a big Namah to all the other members here. So my name is Karthik. I am an associate professor, as Dr. Monks already mentioned. My role here in Canada at Ontario Tech University is to pretty much work with the industry and use emerging technologies like machine learning algorithms or NLPs to provide them with the tools with which they can make decisions. Now, I'm not going to talk too much about it. There are a lot of work that I do with the power generation companies, with smaller businesses as well, in order to help them with data collection as well as visualization of data and things like that. But today I want to concentrate more on the work that I started at Amrita Vishwavidyapeetham, and I would like to thank Amma for giving this opportunity. And in 2019, Amma inaugurated the School for Sustainable Development, which I am an adjunct faculty and I'm a part of. So I'm going to talk about a couple of projects there related to it. And I would like to remind people about Amma's talk at the United Nations, where she mentioned that we should send students to these rural communities and let them work at least for 2 months in these communities so that they understand what is going on in these communities. So that's where I would like to start, because that is the basis of this E4Life scholarship that AMA created for the School for Sustainable Development. And we have about 52 to 55 doctoral students. And each of these doctoral students are assigned a community in various parts of India. And because AMA has adopted over 100 villages across India. So this acts as a test bed for these students to work on. So one of the projects which is led by a doctoral student, Debashish, is on the use of drones as a technology for disaster management. And now, if you remember, in February 2021, some of you might remember this news wherein a glacier broke. And as a result of it, there was landslide and flooding. So the goal of this project is to see whether technology can help us in, let's say, early warning systems and other ways in which we can help the community. So that's one project, a research project that I'm involved in. And there is another project, and this is, again, this Uttarakhand region is in the northern part of India. And there's another project that we are working with, and this is led by another doctoral student. Her name is Anushri. And we work on the eastern part of India, wherein we are looking at ecosystem restoration. And especially those of you who are aware of those areas, I'm talking about Kalinagar as a village, which is closer to the Sundarbans. And so the goal of this is also the use of technologies like GIS to map these ecosystems. Okay, and see how degradation is happening and how we can help the community. So one of the important things in both these projects, which I would like to emphasize here, is co-creation of sustainable solutions. And I think a few of the panelists already talked about this. Dr. Vasudevan talked about, ecosystem, biodiversity. We need to be aware of these things when we try to go and find sustainable solutions, right? And the other important thing is also the cultural aspects of it. We do not want to get rid of that in the aim of bringing technology. We do not want to dump technology onto them, but co-create solutions with the community in order to make sure that when we leave, they are still able to carry on what we started. And that reminds me of a professor who once told me that they had funding and they went into Indonesia to help a community. But then when the funding ended, all of them left and the community was left in a lurch. What do I do next? Right? So the goal of all of our projects should be to provide sustainable solutions by creating solutions, by co-creating solutions with the community. And I'm going to end my brief statement by talking about a few points that have already been mentioned so that it acts as keywords for our discussion later on. One is digital divide that we already have talked about. And the second one is, which Dr. Mikos mentioned, OERs, right? And there is a lot of fragmentation in the work that we do. And when students come to me and ask, hey, where do I find these information? They're running around different places. So because of the fragmentation, it'll be a great idea to create a central repository. Because this is interdisciplinary work, we need to bring together different know-hows in order for these budding researchers to go there and gain knowledge. That's one. And the last and final point I want to emphasize this is the co-creation of sustainable solution, keeping the communities in mind as well as the biodiversity of the region that all of us are going to work on. So I'd like to thank for giving me the opportunity to speak here. And I look forward to learning from all the panel members and the participants as well. Namaskar to all.
Namaskar. Thank you so much, Mr. Sankaranaraya. Many important points. let me also congratulate you with the great work that's been done at the Amrita School for Sustainable Development. Part of that is also the Live in Lab program, which allows students from around the world, and is very popular actually even among Swiss students, to spend time really in the field and really learn what it's about. It's good to read and to look, but you have to live it to really know what's happening. Hopefully we'll take some of your points back in our discussion, but I think we're already starting to be a little bit short on time. So I would like to move on to welcome and thank Mr. Diaz from Sri Lanka, Additional General Manager, Natural Resource Management and Laboratory Service of the Central Engineering Consultancy Bureau of the Ministry of Irrigation of Sri Lanka. Mr. Diaz was the former project director of the Integrated Watershed and Water Resource Management Project of the World Bank, and the scientist in charge of the Landslide Hazard Mapping Project, UNDP UNHCR program in the late 90s at the National Building Research Organization in Sri Lanka. Mr. Diaz graduated from the University of Moratuwa in Sri Lanka and obtained his Master of Philosophy, Earth Sciences from University of Daanya with the collaborative research work with ICT in the Netherlands. So without further ado, thanks again for joining, Mr. Diaz. The floor is yours.
Sorry, Dr. Juice, just sorry to interfere. This is just to tell you that we can extend the panel discussion till 7:30 p.m. IST.
How much more time would that give us, just to be clear?
Half an hour more, 30 minutes more.
30 minutes more, okay.
Yes.
Okay, thank you so much.
Yes.
Mr. Diaz, please. You have to unmute. It's the bottom.
Okay.
There you are. Thank you.
Thank you, Chairman. Thank you for inviting me for the panel discussion on impact of climate change on ecosystem and multi-hazard challenges and approaches we are going to discuss today. It is my pleasure to bring it the message with the disaster resilience, with the subject to the landslide disaster management. In common, the disaster resilience is the ability of individual, communities, organizations, and states to adapt to and recover from hazard. When the community living started from the most sustainable environment. They choose the best sustainable environment without affecting from the floods or without affecting from the landslides. So that is the starting point of the community living really. But with the time of community expanding, increases of the population trends, so we start moving to the hill slopes and capturing the better views, sometimes the architectural views and better views, and moving upward from along the slopes. So that end up with a very unfortunate situation. It transforms into the hazard area because of human violence against ecosystem restoration. So because human needs start expanding, so they move into they are not only the living location, so they attract the move and move from the environment. Ecosystem restoration and the data requirement is a landslide hazard resilient is one of the major point discussion under me. So I think it's a very, very prominent pattern of the landslide. Is a displacement is a key parameter, capture the interaction between the landslide deformation and hydrometeorological conditions. So when you deal with the landslide, I'm not going to bring it to the more information. First is the ground, second is the hydrology and the water, and the third is the ecosystem. So all three together, a composite, bring it to the nature for understanding the requirement of the data requirement of landslide hazard resilience. So coming to the picture of the ground deformity. So this is one of the best information which will give a very straightforward information in landslide, potential landslide incidents, or the identify of many key key prominent parameters from the landside activation. So therefore, there are large number of devices and developed in order to conceive the review of data for landside prediction, monitoring, and early warning. So you can see my slides, which give the enormous way of capturing the many surface information of the ground surface information. But at the same time, the technology comes to the inactive stage at that level. So that is the point really. Multi-sense instrumentation for monitoring of landside is bring it to the very high level. So without having the multi-sense instrumentation for monitoring of landside, we are very far behind the interpretation of landside prediction and the landside monitoring. So therefore, that's the point of IoT and ML, machine learning. So that part come into the picture with the landside monitoring and disaster risk reduction instrumentation. So which link with the surface to the ground surface, and also subsurface. All these points start acquiring. At the same time, not only the just covering up with the single landslide phenomenon, but we had to live with the spatial environment. So then the modern technologies for multi-sector geographical data techniques, which ultimately improve the accuracy of an interpretation of the landside hazard. So a good example, few example is one is the close range photogeometric technique for deformation measurements and mapping. And also the fixed terrestrial photogeometric system for landside monitoring, also bring it to the picture today. And the multi-temporal terrestrial laser scan survey for landside also giving the acquiring of the large databases, which links to bring it to the more accuracy of the landside disaster management and ecosystem planning. But at the same time, one point is fairly important. We're always trying to do the getting the more information with the landside prone zones, but at the same time, we not forget the stable zones of the ground. But we are always having the more zones are stable than compared to the unstable zone. But this is the time for start learning from the stable zone to get it more information in order to planning for the ecosystem management and ecosystem restoration. So I'm sure that there are many places from the each continent or each country having the very critical, even the slope is critical. In the physically, you can see the critical, but at the same time, there are a lot of stable forms are not visible. Therefore, now the time is need to incorporate more sensors and more technologies to identify those parameters in order to do the more accurate mapping and prediction. So I think with that, I will conclude my presentation.
Thank you very much, Mr. Diaz, for sharing your insights. Right, so we've had 8 presentations in less than an hour, which is already quite an achievement. I think we touched upon many things. We can build upon various elements of our discussion, also integrating the very rich discussions and presentations that already occurred. I have a few questions, but I would first like to give the panelists the opportunity themselves, maybe just to ask a question or add an important point they would like to make in addition to some of the statements of the other panelists. So is there any questions or statements, additional statements from the panelists at this point? Just open your microphone and feel free to speak. Yes, please.
Can I?
Can I say Kartik?
Oh, yes, please go ahead.
Yes, thank you.
I'm absolutely fine with that. Thank you. So this is to Dr. Yasukawa. I know UNESCO does a lot of work, and this is going to my point about fragmentation of work. Are there any databases or repositories that UNESCO is working on so that researchers and industry people can access? So are there things that are being worked on, or does it already exist, which I am not aware of? If you could elaborate on that, that'll be extremely helpful.
Yes, I think data depository is like a thing that everybody is fascinated to do, and not only UNESCO but other UN agencies try to take a lead for the data depositories. And honestly, I think no one is doing it perfect. I think because the more we collect data, the more we close to become like a Google. And then I think then usabilities or accessibilities, it's kind of difficult to navigate. But from UNESCO's point of view, yes, we have several databases. For example, WINS, which is called WINS. This is about water-related data, which is about groundwater data informations or like accessibility of the water to the people, etc. So WINS is one of the scientific data depositories that UNESCO is working on. But at the same time, I have to admit that I think FAO, like agriculture agencies of UNESCO or UNEP, which is working on the environment, I think they are also trying to take lead to make some data depositories. So so I think there is some fragmentations of this data, data depository or data, database. But at the same time, I think we also need to understand that the more we collect data, I think it's more, unusable or accessible it becomes. So yeah, I don't know. I think we, because Professor Mikos also mentioned about open science. I think we are now, are familiar with open science concept, and then I think we really need to think about how to, how to collect data, how to, make it open to people. But I think this is one of the things we need to think about this data, data source or data depositories. So, sorry, I think it's not an answer, but
Thank you. Just to mention, sorry, Dr. Monk,
yes,
and that's the direction I was going, because Dr. Mikos mentioned an important point, right? Open educational resources, because a lot of research are walled. And many people cannot access those research, let's say, articles or databases and things like that. So only when we open up, then we are going to have transparency in research, and we'll have different stakeholders coming in and working together towards a common goal. Hence, I initiated this conversation around, openness and providing access to everyone, not just researchers, industry people, but everyone, so that they can work together with other stakeholders. So thank you for your answer.
I think Professor Mikos wants to react to this.
Yes, of course. Just to add, there are several directions, of course, where to go. I would say what Soichiro Mr. Yasukawa said. It's not very easy to to establish an overwhelming data repository. So one way to go maybe really would be for developed countries to support open science, that all public universities will start. We have that in Slovenia, we have that in Europe, that you are obliged, if you work at a public university, that all your publications should be freely accessible. Maybe you should pay for open access. This is another question, how to deal with that some big guys are not gaining a lot of money for that. But if public research institutes and universities around the globe would publish all their research papers as an open access paper, that's the first step. The second one is the supplemented data which is of course then transparency, that you really have done that, no problem. You have been elected to a professorship position. That's really transparent also from this habilitation point of view at universities. This is one way. Another, of course, would be, let's say, I don't know, geological surveys in Europe are putting together, are trying really to get remote sense data like Copernicus. You have also a very good satellite company in India, so that the remote sense data are available in databases. If they are put to a higher level, they should be also available to any researcher and of course any stakeholder. There is a problem of interpretation of the quality metadata about that if you want to compute something out of it. But I think that European Commission Union is doing great job in that direction by several products. And of course, UNESCO is another even world player for that. And we should really go into it. And I would vote for that these some keywords are going to, I don't know, some conclusions of this symposium. Thank you.
Well noted, Dr. Mikos. Any other question or comment of the panelists? If that is not the case, I would like to ask the question. I think it came up a few times. The use of technology also has, backsides in terms of digital divide, in terms of the ecological impact of the use of these technologies themselves. Some raised the question whether the cure technology can be worse than the disease. And my questions to this audience, and I would like to start with Professor Casagli, if you would agree, looking at it from the ICL perspective, is what kind of guardrails, what kind of regulations do we need, if we do, for the use of these technologies, Internet of Things, machine learning, AI, in DRR? Maybe it's a very broad question, but of course, technology is taking an increasing role, offers a lot of potential, but it also has certain elements where you can really wonder, data privacy, extrapolation, predictions you made on very limited data, bias in data, maybe absence of women, for instance. So is there thinking around this? What kind of guardrails would you see and recommend for the use of new technology in DRR, if we say it that way? May I ask the question to you first, Professor Casagli?
Yeah, of course. Thank you for this question. The first point is the understanding of the hazard. People, policymakers, technicians should understand very well the problem. Landslides, floods, earthquakes, volcano eruption, and also the relationship among them in multi-hazard chain. This is the main problem. When you understand well the physics of the phenomena, you can use the new technology in a proper way. The basic point is the access to the broadband. It's not easy, this, because even in developed countries, the access to the broadband connection is not guaranteed to everybody. And this is a major problem in less developed countries, because broadband wireless connection is very useful for monitoring system and to dispatch early warnings. Also, 2 points have been already discussed in previous interventions. The open access and the open science. Publication should be accessed in the wider possible way, and also satellite data. Luckily, the recent policy of European Commission are in this direction. If you receive grants from the European Commission, you must publish in open access way. And also the remote sensing data, the imagery acquired by satellites from European agency, the recent European agency satellites are distributed without costs. In order to obtain an effective use of this data for early warning and the safety of population, is necessary to reduce data processing costs, and all efforts should be dedicated to this point, to not only to the data acquisition, but to the data processing and to extract useful information from data.
Thank you very much, Professor Casagli. Anyone else wants to react to that question that I raised, a broad question, or take a dimension of that? And in the meanwhile, I invite the audience also to think and submit questions. If you would like to ask the question directly yourself, please raise your hand, and I think the team can unmute you. But I have a hand from Professor Mikos here. Is that correct?
I already said, sorry, it was still hanging on, but it is different color than the others I used.
Yes.
Thank you.
Anyone else wants to react? I think Kartik, maybe you want to add to the question that I raised. Yes, please.
See, there are two aspects I would like to emphasize here. This data repository is a very important point, which was discussed earlier. And in that, my suggestion is most of the university institutes and research organizations, they believe in publishing. They are very possessive of their data which is generated. Once it is published, then it is in public domain. Okay, and we find the publishing houses also charge quite a lot of money for sharing the data. So my suggestion here is, I've seen a number of good books being compiled on landslides and various methodologies and good practices which are being adopted and good outcomes which have been discussed. Well, we should develop some mechanism, maybe UNO can also help in this, on compiling these research works under one roof. Let's have a review compilations wherein all this data which is available scattered in public domain is brought together and is also made into a useful document for future reference. And most of the research scholars who are actually involved in, who can be involved in such projects, need to be funded for the scholarships and things like that. It should be facilitated, right? This is one. And other is it feasible to develop some good guidelines for ecosystem restoration or geosystem restoration? In fact, the geodiversity is very important here. So therefore, of course, I'm aware that each community, each region, each territory has its own specific requirements, and each ecosystem is having its own ways to be tackled separately. But then broad guidelines on different ecosystems can be released for public participation and for further development on those guidelines to make it region specific and to make it acceptable to the local communities. I'm also aware that, for example, in India, the National Disaster Management Authority, NDMA, they are in the process of bringing out such guidelines for various types of disasters. But then they are more on the policy aspects, But what needs to be done on ground, the practical aspects, how things are done, and what are the good practices which are actually accepted by the community, and they should be brought out in such compilations as a broad guidelines. This is a small solution. Thank you.
So I think that there's a few points here around access to data, central access or centralizing or having a repository of data. Then, of course, the question of the quality of this data is raised. And there's a second point also that comes back a few times is access to education around this. including publications. I think that is something that should be taken on as one of the recommendations concluding of this panel, but we'll get back to that later again. Kartik, you wanted to add something here?
Yes. So when we're talking about technology, right? So I had the opportunity of working with Dr. Stephen Marsh, who's considered as the father of computational trust. So two things that I want to bring to the table here is trust and ethics when we are using these technology. And when I talk about trust, just not to get into the political side of things, we know what happened with Cambridge Analytica and things like that. So the question is, can we trust these systems, especially when we are going and using it in certain vulnerable locations? So that's one thing that we need to be careful about. Just because we have this technology doesn't mean we have to use it. It has to be used in the right way. And that's where the ethical point of view comes into picture. Because I represent the academic world, we always go through the research ethics board before we go and collect data. And that is an extremely important thing. And especially when we are dealing with technology and with vulnerable groups, when we go to the rural parts of any country for that matter, we need to keep these things in the back of our mind. And why I raise this point is proper guidelines need to be set by, let's say, the local government or international bodies around the use of these technologies, because it is a double-edged sword. It can go either ways. So we need to have clear guidelines and procedures that all of us get to follow so that we are not abusing the system as well as not abusing the ecosystem. I just wanted to put that on the table so that people can discuss, because those two things are extremely crucial because Dr. Vishwanathan talked about gender equality, right? So those are some of the things that should be brought in when we are discussing about sustainable development and sustainable goals and things like that. So I just wanted to bring that point to the table. Thank you.
Thank you so much. I think it's a critical question. And I wonder, and I think this is the opportunity to ask that question, if there is any initiatives in this sense. Is there sort of thinking or even already structuring of ethical sort of principles or guardrails, as I called them at the beginning, for the use, in particular in fragile contexts of this technology? And I think UNESCO has been trying a few things, so I see a raised hand here. Thank you.
Yes, thank you very much for raising this ethical guidelines, etc. So UNESCO is right now working on the two big ethical recommendation for the technologies. One is a recommendation for the open science, I think, which we have been discussing a little bit, because I think around the last decade, this idea of the open science has become, especially from Europe and North America, then UNESCO is trying to generalize these ideas globally. So we are now working on the recommendation of open science, which is still under discussion by the expert groups, but we also touch on digital divide or importance of depositories, etc., etc. I think right now I saw like 7 big pillars of the principles, but we hope we will finalize it and publish it this December. But we are working on this open science recommendations. At the same time, we are working on the ethics of artificial intelligence, because many scientific domains, I think they have their own ethical principles for engineers, for scientists, etc. But artificial intelligence is a kind of new ideas. So UNESCO took a lead to make a recommendation or ethical guidelines how we utilize artificial intelligence. Unfortunately, I haven't seen the draft. I saw a draft, but I don't remember how exactly it was structured. But they try to touch on any possible domains which could utilize artificial intelligence, and then they try to make some recommendation or some, try to make some recommendations how we scientists can use artificial intelligence. So still not finalized, but we are working. Yeah, as I just wanted to share with you that we are working on the guidelines or recommendation for open science and ethics, artificial intelligence on ethics. Thank you very much.
Thank you so much. Thank you, Professor Mikos, also for sharing this website and additional information on geoethics. Anyone else wants to add to this? And actually, I take the liberty to maybe ask the private sector representative how they look at this, because I mean, ethical guidelines, if they're made by UNESCO, that's voluntary. I mean, it's soft law. There is no enforcement mechanism, and it will depend on the field and industry how they pick it up. Is there anything you would like to add at this level? Mr. Hoval, if I can be so free to ask that question directly, please. Yeah.
Sure. I can add to that actually. This is still it is much under debate, right? Most of the organizations are governed by their own corporate data, access to data, distribution of data. Even within those organizations, we have digital data handling ethics training also for all our associates, right? So we are aware actually what is big data itself is a money itself, right? That's the way you might need to use it. Though we call AI is really productive and it should be impacting positively to the whole society, but it has its own the other side of the impact, right? So we need to be very delicately handling this set of data, the access, the control, distribution, reuse. I think today, if you look at the whole of economy, it is driven by the digital data. So I think it will take some more time to see to what extent it gets democratized on the data access. So that's my comment. Thank you.
Thank you very much. I think we are starting to conclude, and I always like to give the opportunity to all the panelists maybe to make a final remark. But before we do that, I was just checking whether there's any questions from the audience. I haven't seen anyone, any question coming in. So if there's any question left, please feel free to ask. And I invite the panelists as a way to conclude this session, maybe one or two key takeaways that you would suggest to carry us through the symposium, also in terms of possible recommendations we would like to make. This is just an invitation. I mean, you're not obliged to take this question, but feel free to have any concluding remark or concluding recommendation.
Yeah, panel chair, I will take this for one comment from my side. I think if you look at the diversity of the participants, the whole contribution of this IoT and ML and using the technology for the better versions of our ecology is really a big subject. It needs wide participation. It needs very strong collaboration to get the best practices shared among different networks, right? This itself is a more neural network where we have today, right? I think it has a high potential. I think we need to harness it. Thank you.
Invitation heard. I think it is about holistic, multi-dimensional, multi-stakeholder. We can't work in silos. Any other comments, final remarks, suggestions, recommendations? Karthik, please.
Yeah, just one point that I want to emphasize on is that, and I cannot agree with all the panel members, it's a multi-stakeholder terrain, right? So many people working together. One of the main goals would be to co-create sustainable solutions and not just dump technologies onto communities. So that's something that I want to convey here, so that just because of the availability of technology doesn't mean we have to use it. But keep in mind that we are dealing with vulnerable communities. So co-creating solutions with them is the right way to go. And that would be one of the key messages that I would like to convey in this forum. Thank you.
I mean, that means the technology has to be also taken ownership of from the bottom up. It's not dumping technology, as you say. You know, sometimes I get the sense that, you know, we push technology as a goal as such. une fin en soi, you would say in French, but it's just a tool. And sometimes we forget because we are little, I mean, it's very hypey, the buzz is around AI, but we have to test with the communities for which these solutions are meant, to what extent they can take ownership or at least co-create the use of these tools together with them. Very important point. Thank you, Kartika. Mr. Yusukawa, please.
Yes. No, thank you very much for your, handling the sessions, Mr. Monks. No, I think the DRR could be more profited or benefited by using technologies, because compared to the business which is using AI for IoT for maximizing their profit, so they have incentives to invest on the technologies for their business. But on the contrary, on the disaster risk reduction, it's mainly on the domain on the public service. We still think that we don't have enough investment on the usage to see the potentiality of the technology for disaster risk reduction. Yes, I understand that we have concerns about privacies or digital divide, etc. But yeah, but with this, yes, I understand these concerns. But I really wish, we really wish that we have more investment by the technologies to be used for the disaster risk reduction. I don't know how we can do this, but I think one of the Sendai framework priority action number 3 is an investment by private sectors on DRR. So I really wish that not only the academic, but also the private sectors will try to invest on their technologies for disaster risk reduction. Thank you very much.
So that sort of hints towards building public-private partnership around this. Where the industry also becomes stakeholder in developing appropriate technology. Anything else? Any other final concluding remarks as we are about to close this session? Please feel free. Yes, please. Mr. Diaz?
Yeah, I wish to add something. I think community level of technology awareness is very much important in many levels. Because sometimes the technology very much move with the technical people, but at the same time, the people who are living with the disaster zones. So those people clearly require some use of application of the technology. So that level of awareness is very much important.
Thank you for this addition, and it joins this sort of bottom-up comment that was made by Kartik. All right. So, thank you very much, distinguished panel members, for taking the time for this very rich. We spent 1.5 hours together, actually. I didn't see the time go by, which is always a good indicator for the liveliness and the interest of the discussion. The symposium will go on till the 8th, if I'm not mistaken. So I'm sure that some of the topics that we raised or we touched upon will come back. And without further additions, I think the organizing team, you take it over from here. So that being said, thank you very much. Namah Shivaya, as they say, as we say, wish you all a wonderful continuation of the symposium, and thanks again for taking the time.
Thank you, Dr. Monks. I'll take it over from there. Thank you. So my pleasure to introduce our next speaker, who is not a stranger because he's been part of this panel discussion. So we are going to host Mr. Virupa. He's an engineering graduate from Mysore University in electrical and electronics engineering. He started his professional journey as a maintenance engineer at a large process industry. Further, he worked through various roles in manufacturing industry, in quality, sales, marketing, product management in a multicultural and multinational environment. Intense focus on furthering his academic quest, attended important management programs from XIM Bhubaneswar, IIM Kashipur, and those helped him in his career. deeply interested in transformational leadership, meditation, supporting society in education and other needy people. Currently serving as general manager at Bosch Rexroth India in marketing function and partner management functions. Prior to this, he had worked in automation field in esteemed organizations like Siemens, Rockwell Automation, with varied responsibilities. Mr. Virupa will be speaking to us on the topic of IoT and machine learning as enablers for sustainability this evening. Mr. Hovale, please take the stage.
Thank you very much. Thank you. Thanks for this introduction. I appreciate. I thank Amrita University for giving this platform to present whatever we know little about the topic. And I hope this will be a more encouraging one. My topic looks to be more of a higher periphery level, not too deep, because there is a wide spectrum of participants. So I'm not taking too deep, but definitely I will cover most aspect of the relevant topic today. Thank you very much. I will share my screen. Can Setu Rao can confirm me it's visible?
Yes, sir, it is visible. Please get into the presentation. Yes, yeah.
Okay. Okay, thank you very much. So I will take through the topic of IoT and machine learning as an enabler for our sustainability. If you look at the sustainability question, we started talking off late. For 10,000 years, the Earth's relative stability was enabled with the civilizations to thrive. We thrived a lot, very well. We became rich and poorer, we remained poorer. I think 10,000 years we went through a good stability. But most critical process and systems that control stability of the system are the climate change, the loss of biosphere integrity, the land system change, and the altered cycle in the global chemistry, or the global chemistry, the way we get the things from the nitrogen, hydrogen, or the water, or to the carbon dioxide, right? So above critical elements have crossed the boundary levels, which are impacted by excess human activities, or maybe abuse by the humankind. This elevates the risks that may lead to the deterioration of our human well-being in many parts of the world, including the wealthy nations. That means it offers a huge opportunity for us for a course correction at this stage. Then if you look at the sustainability, which is also driven by United Nations Sustainable Development Goals, which had about 17 goals. Out of that, 6 are most important, directly apply to the environment and humans' influence over it. They are combating climate change, biodiversity and conservation, how I can conserve my ecosystem around me, healthy oceans, we have seen the acidity level increasing for many reasons. And the water security, there could be a 40% less or more shortfall by 2030 if we don't conserve or handle our water. The clean air, you see a lot of fatalities happening because of exposure to the polluted air. I think 92% of the world live in such environment. Weather and disaster resilience, I think we have a lot of experts in this forum. I think that shows that how important it is to protect our geophysical levels against any of these disasters, which we can prevent. So fourth industrial revolutions, which we call it as a 4.0, offers a huge opportunity to positively influence the earth on this topic. With this, I will just quickly take you through how the industrial 4.0 has revolutionized. If you look at the 18th century, we had more of a mechanical control, conventional steam engine, cam disc, cam lobes to convert to do more of a productivity into the manufacturing segment. When we moved into the 2.0 into the 19th century, we had the punch cards, assembly and production for large series, which were more of a mass production happening. So I think it was a very big beginning, good beginning for industrial revolutions. But the next 3 was a more of an industrial revolution with digitalization platform. We got microchips for software, increased degree of automation. We are moving from conventional to the PLCs, the automation, numerical controls, the IT system for production planning and control. I think that was a good turning point for us. But the pace with the 4.0 revolutionized, it has a huge impact. I think we will see the both side of this 4.0 when we go through the subsequent slides. The 4.0 encouraged us, offered us higher computing capacity, large memory, connectivity of people, most connectivity, bringing the globe together. I think that has revolutionized a lot. We can see today how much digitally we are connected. What is meant by this IoT we talk, or Industry 4.0? Industry 4.0 brings the physical world of industry, which has the machines and their safety, the energy and their efficiency, how fast I can release my product and solution to the market, what is my life cycle, how efficiently I'm producing my products or the end goods, right? These are the industry constituents. Then coming to the IT side, I have the cloud computing, powerful computers, set of big data, IoTs. Industry 4.0 brings these two worlds together, where we get a win-win situation for both, and it is expected to contribute for the better world we live in. If you look at the set of data, what we have, with the rapid progression of this IoT, if you look at 1995, we had 15 million people have the access to the internet. At the same time, around 97, we had 6 million computers with internet access. By 2020, we had 7 billion connected people, and 2020, 50 billion connected devices are available. This shows the extent of data we generate every time we connect to our smartphone or any other device which we use at home. If you look at the typical IoT architecture in an industry or in the manufacturing area, or I take one sample which shows the typical architecture. This bottom is the shop floor level, where I have the smart devices which are having capability to connect them to the internet. They are sensors having their own built-in self-awareness, or they are a capability to get into a whole system and get system awareness. So this is where lot of data gets generated every day, every minute, right? As we go up into the pyramid, it gets to the IoT gateways. We connect to the gateways by connecting the data acquisition through the PLCs and the connected system. Then we start getting more insight. Then we start handling this data. What is my intended outcome? What do I want? The raw data gets processed. It generates the decision-making capable dashboard or a data which acts as enabler for making the right decision. So the bottom line is large amount of data is generated, which is the fuel of our artificial intelligence, or we go to the next step of machine learning. IoT and machine learning as enabler of sustainability. If you look at the artificial intelligence, though we intensely talk for last 1 decade, but the evolution happened in 1955 itself. It was evolutioned by one mathematics professor, John McCarthy, in Dartmouth College, and he clearly defined artificial intelligence is thus inventing the name for a scientific field about thinking machine, where you can make those machines to learn the way the human intelligence is built in. Once you teach them, they start modeling the way the human thinks. That can make to simulate the real machine if we're able to give the real input for them. So this was all the way it started from 1955. So if you look at the whole structure, how the machine learning is subfield of the AI, on a peripheral level, we have the artificial intelligence, which gets the data like our own sensories, like rule-based reasoning. It gets the data, natural language processing or a translation, machine vision or a vision system for camera access, look at the quality, whether it fits, doesn't fit, then converts speech to text or text to speech. Robotics and autonomous vehicle, they're all part of artificial intelligence. So more deeper I get into the machine learning and deep learning. Machine learning is something where it has a certain activities, or I program a machine to learn. The learning will happen by either a supervised learning or an unsupervised learning, or it can be reinforcement learning. If you can take supervised learning is something like, I have my daughter getting into a garden. I ask her to pick up that yellow flower. That is supervised learning. I leave my daughter into the garden. I just don't tell her to say which color of flower she should pick up. That is unsupervised learning. And there are another machine learning process where more iterations happens with the data and trial and error. They achieve certain outcome. That is reinforcement learning. Then the deep learning goes to the further higher level, next layer level of learning for the machines, where we try to make that machine or a computer like think and act and learn like a human brain. It is like creating an artificial neural network. In the brain, we have neural cell, each cell multiple, it's a network to generate different set of data processing. It decides the priority. That's how we get into creating a simulated artificial neural network into the deep learning. As we go for more and more deep into this machine learning and deep learning, the amount of data handled, the complexity of algorithm based on the expected outcome, that will change. So if you look at the big data is like a fuel to engines. If the tank is empty, the engine comes to the halt. So that is where this data is valued to such a large extent. Going to the next one, what type of machine learning I have? I explained this machine learning comes into three different varieties called supervised learning, where we use a set of labeled data such as tagged picture to train the algorithm, and where the input and outputs are available in the data used for training that machine. Unsupervised learning, I explained the example of no instruction about which color flower to be picked up. They are unlabeled to data to train the algorithm. The algorithm has to figure out the logics behind it. More and more iterations it goes through, it generates, it finds the pattern, and the result is available for us. Reinforcement learning uses very little bit of raw data. Example, it frequently uses robotics, gaming, or navigation. Okay, these are the different machine learning models available today. I think we may develop some more, but as we go next level, it is deep learning. Deep learning, I'm not covering in today's session, but I'll explain how the IoT and machine learning has been contributing already for us. We are already seeing a content creation where we get the newspaper articles, sporting event coverage are written by AI, selection of most impressive scenes from a movie scene to publish for a marketing or a trailer that is created by our artificial intelligence, music compiled by AI used for the film, the website, the commercials, or every time when I access my smartphone, there is a clear tracking of my digital footprints that is generated by artificial intelligence. Then we go on all the way to vehicles driving, the flying themes, the drones, then seeing and interpreting the world, the visual search, cameras on the tractors, the autonomous driving. And this is how where we reach a position where our shelves into the fridge will be filled by artificial intelligence whenever certain compartments, which is smart enough, having smart sensors that can refill my refrigerator. Then all the way we go to the predicting the future based on what historically the thing has gone, whatever the situation, amount of data. Example, AI tells a saucer player what is their ideal defense position. It is based on deep learning, which it has gone through as a process, and the quality of data modeling it has gone through by the programmers through the right algorithm. So all values created by AI is big data. So big data is like a fuel to engine. That's how people value that data so carefully, so that doesn't let out so easily for anybody unless we went through the recent panel discussion. It meant for some research activity where no commercials are involved, because many organizations depend their IPRs based on this data. We have seen many organizations thriving just based on the data created by our own digital footprints. Coming to some of the research reports, it is PwC report on harnessing artificial intelligence. If you look at the evolution and the timeline, the way we have gone through the AI, we started with a very narrow AI, which was rule-based and the speech-based. But further, we went on to the B2C and search and e-commerce, which had the deep learning, image processing, writing, and the NLP. Then 2000s, we are trying about democratization and embodied AI, where with the data scientists are playing most important role. We will get the robots at home. We are already having the robots at home. We have seen into the many of the restaurants. They have been in use, especially this pandemics has accelerated this utilization of such digital technology for some of these services. And self-driving vehicles, we have seen intense competitions already, how the trials are going on. We are in the midst of this stage now. Okay, next stage going, we get into the neuromorphic computing, the brain-computer interface, where we have the emotional robots also getting into the play. So this is how we see the timelines and developments in the field of AI. Large investments are happening because corporates see a lot of returns coming out of this. Early adoptions are definitely paying for it. So that's about how the artificial intelligence is going to progress in the coming decade. Coming to the opportunity for our environment, today we are talking, or we are deeply discussing about what are the opportunities for AI to be utilized in making our earth where we live as a better place. It can deal very well as an opportunity into the area of climate change, the biodiversity and conservations, healthy oceans where we have a very low normal pH values for the oceans, water security where people get the safe drinking water, clean air, we reduce the fatalities, weather and disaster resilience, how we can do the predict and forecasting by using the AI, how we can put a resilient infrastructure, what are the financial instruments for it, how resiliently we can plan for the success of this, where we use the data to live safe for the larger humankind. Most important, what I'm sharing is an example, how a co-creation was done with a corporate by using the AI. This is a tomato plantation where they get subjected to a fungi called gray mold fungi, which is in the moist and warm conditions. Usually they occur into the greenhouse. They definitely happen under certain conditions, which is known to the farmer, and there is a historical data available for this. This data harnessing is done to give a clear alert to the farmer, what is the condition of his greenhouse. He gets an alert whether he need to maintain the temperature, reduce the temperature, or use the right preventive measures to avoid fungi getting infecting his plantations. I think this is where the AI opportunity for our environment, where we are using for biodiversity and conservation. There are sensors available at greenhouse which monitors humidity, the temperature. Sensors data goes to the database and it gets prediction algorithm which is co-created by the organizations. Then the farmers can live monitor the environment around the plantation, get alert, take precautionary measures, save their plantation so that I'm contributing to the biodiversity as well as protecting my plant against species and disease control by using artificial intelligence. Another good example I have is about on the industry side, where we want a sustainable productivity by maintaining my production, the efficiency, consume right energy, reduce downtime. How I can do this is by perfectly monitoring critical element of my plant performance. If you look at the right side, it is one of the equipment where critical elements of the equipments are monitored through the sensors. The data from the sensors is collected from all these elements. Example, if you take a hydraulic system, the motors, the cylinders, the pumps, the valves, and other aggregates, the data is collected to the IoT gateway. It goes to the cloud where we have a machine learning already done. We know the failure mode, historical data telling when the pump is likely to fail, what are the threshold level of the leakage, what are the threshold level for the contamination, the vibration level. That will very clearly give the trending to the user on a dashboard so he can avoid unplanned shutdown of his plant. There is a very planned shutdown available. He can reduce the downtime, keep the uptime running for a longer period so that he uses or he makes his asset utilization to the optimal level. This is an opportunity user case for a sustainable plant production. This is from the industry perspective. Then I will go to the other side of the IoT or AI. If you look at the AI, so far we discussed about how good are all those positive things, right? If you look on the another side, as per this report, there are many negative impacts are also likely to come. If you look at, there are performance risk of error, a bias, opaqueness like a black box are a risk of explainability or stability of the performance. So before we adopt, we should be aware of what are the boundary levels or a boundary condition under which a certain output is expected or outcome is planned by using the AI technology. There are huge security risk expected. Example, cyber intrusion risk, privacy risk, open source software risk. This is the second biggest risk. The control risk, if there are hacking, it may be ethical hacking also or whatever the way. If it gets into the rogue hands, it's completely a disastrous mode. You cannot control malevolent artificial intelligence, which can take the data theft, which can make your plant or an asset to malfunction. That is a control risk. Ethical risk, lack of values, value alignment risk, goal alignment risk. Economic risk, there could be a big economic risk if these are allowed to be happen. Winner takes all the concentration. There is a big digital divide may happen if there are very limited controls into the very limited handles for these artificial intelligence or the data. Social risk, example, we talk about the drone, autonomous weapons proliferation. Drone can be used for putting the weapons or transport of the weapon or dropping at their convenience, right? So that is where we need to be careful. So it gives a lot of positive benefits, but it comes with other side, which is indirect impact, which could be putting the human at risk or the assets at risk. So still it's a tug of war when choose to applying AI judiciously in view of a research showing that it has indirect impacts in the other way. Coming to the most important, so far we talked about.
Sorry to interrupt. If you could wrap up in a couple of minutes, we can have some time for question and answers also.
Sure. I have
Thank you.
Next 3 slides. Yeah. So next important, we talked about the innovation, the industrial revolutions, everything. Look at the nature way we live. For all the challenges we face, nature has a solution. There is an initiative called Biomimicry 3.8. Biomimicry, it is a strong source of information where in today's context, best idea may not be ours because sustainable world existed for long. Nature has a 3.8 billions of years of R&D. Biological intelligence since 3.8 billion years inspires new innovations. Biomimicry is nothing but very important. It emulates the models out of nature, the system and elements of the nature for the purpose of solving complex human solutions. Biomimicry 3.8, it trains, equips, and connects the change makers with its billions of years of brilliant designs and strategies. What it takes is the 3 more essential elements of biomimicry is I don't go to nature just to keep on extracting the things for me, but I work together, I harvest, and I domesticate it. The 3 basic elements are it will emulate, it will not just copy, it will emulate the way the nature behaves. It can be nature, the animal, the environment, or the bird. We emulate those surroundings. Ethos, the ethos of understanding how life works. Always the nature is used for increasing the level of life of the people, not to take on to the other side. That is the ethos behind it. And it always takes us to reconnect to the place where we live around the society. Please give ears to the ground. Please be part of the ecosystem where we live. Value everyone. These are the 3 important elements of biomimicry. I think they will give a lot of solutions for us. Look at these examples. Casual example, sustainable building, secrets of termites. The way termites build their residence or a nest, this is emulated in Harare by using the same system where the temperature is within 1 degree of either it is a day or night. Another one is example, learning from the whales to create efficient wind power, which can increase the efficiency, almost 32% reduction in the drag, and it demonstrates aerodynamic improvement. This is learned from the whales. Next important, we always see the how to remove the air using a logarithmic or exponential growing spiral. This reduces the friction, so it increases the efficiency. This is where we learn from the nature. There are best ways are already available in the nature for us. Last one, lotus plants, they have the leaves. How do they clean it themselves? Though it grows into the so remote place, unhygienic or sometimes unclean area, right? Microscopically, this rough surface, when looked at, it has a finish, fabric finish. It is already adopted. In creating the paints, it is adopted, which will reduce the need of chemical or labors for cleaning. I think it shows we have a lot to learn from the nature. With this, I say the future depends on what we do today at present. Our great father, Mahatma Gandhi said this, and it is time to pledge our commitment to save our earth. Then coming to the last, our founder, Robert Bosch said, cooperation is a must, and each individual depends on the other. This is where we coexist along with the nature. And with this, I would say, thank you very much for the patience listening. And I conclude my presentation with this. Thank you very much.
Thank you, sir. That was a nice presentation, bringing out the role of AI, ML, and IoT in the context of Industry 4.0 towards sustainability. I would open the floor for questions.
Please.
There's one question I see now on in the Q&A window. Thank you so much for mentioning the risks. Very valid point. How, in your opinion, these risks can be mitigated? Thank you, sir.
Yeah, I think mitigation of risk, in fact, it happens by uncontrolled use of this AI. if we are not very closely working closely with the nature, I think that's bound to happen. We create the risk. If we don't use the purpose for which it is built, we use it. Because I remember an example where by fraudulent way, there was an access to the data setup. I don't want to name the country and the organization. The data was accessed. Their whole nuclear facility was under threat. The whole plant was coming to be shut down. This is where the artificial intelligence, the data access, and this is where led to the almost close to the disaster situation. I think everybody who has the access to this data has the responsibility to mitigate this risk. It's a good question, but I think we all need to work for this one.
Thank you, sir. So I will ask a question. You mentioned biomimicry. So especially in the context of Industry 4.0, I mean, have you come across some, applications of biomimicry in that context?
I have not yet come across, but I think definitely when we start working with these organizations like biomimicry 3.8, we should be definitely able to generate that one. So that's my opinion. I have not come across, but definitely it has a lot to learn from the nature. They will definitely be able to guide us. There are many toolkits available for the people who innovate, especially from the point of design thinking innovation, where in the design thinking approach, very critical element is design for environment, or a green design has been built into the design thinking approach, so that at every process from the concept till it goes to the end user, even when you discard for a disposal, we follow through that design for environment. Definitely, I believe it should be available.
Sure, sir. I agree with you. I think we have a couple more questions. Let me look at those.
Please.
Right. So here is a question from Dr. Gopal. While large manufacturers can afford sophisticated Industry 4.0 setups for intelligent manufacturing, preventive maintenance, optimized manufacturing, etc., how do we get this to small and medium production plants? Do we have generic digital twins for equipment that can be rapidly customized?
Okay, very good question. I appreciate it. For a country like India, definitely we need, because large economy, we need cost-effective, highly productive, high technology. I am part of this to drive even our own organization. Definitely, the automation level, before even we go to the digital twin, it starts with very basic level of automation. Digital twin also comes out of our big data. I start creating a digital model of my product or a digital model of my process. To create that, I need the data points. This data comes out of the sensors and the process itself. So I start with a standalone machine by putting the basic sensor first. That itself is becoming IoT enabled machine. We can take a machine which is as old as 50 years. We can make it as a IoT compatible one. There are solutions. Example, there are multi-variable sensors available where a small matchbox sized sensor, which I can put it on the machine, which can capture multiple data sets. It captures accelerometer, temperature, vibration. Like this, many variants are capturable that works on a low energy Bluetooth. I can get the data onto a small app. I can monitor my very old machine. So I'm IoT ready. So IoT is a scalable solution. It depends on what context I am making it IoT ready. I hope I answered the question.
Thank you, sir. Here is the next question. Can AI be used for the coronavirus detection in public places?
This is already happening. Example, there were some data analysis done by one of the premier institute, IIT. Okay, they clearly projected based on the data collected from different parameters. There was a huge data collected. They clearly projected how it is increasing and how it is reducing. Definitely, it is a work in progress. But when the data creation start, the accuracy level depends on quality of data, volume of data, timing the data, how much is the dynamic data, and what type of dynamic mathematical model I'm using it there. I think it has various elements. Definitely, it is being modeled, in my opinion.
One last question, sir. How is Bosch as a company working on sustainable development and AI?
Yes, we are working in a big scale on the AI. We have a big team of data scientists in the place where I live in Bangalore itself, and we are working on this. There is a Bosch Global Research Institute in Stuttgart as well as in the US on the artificial intelligence. Huge investments happen on that. Plus, we are working towards carbon neutrality also to make it earth safe, right? I think by this year end, we are almost like zero, carbon neutrality zero from all our global manufacturing plant. I would say that is the biggest contribution from an organization like Bosch towards Paris commitment. We are doing it already.
Thank you, sir. Very informative lecture. I think that brings us to the conclusion of this lecture by Virupa. Thank you so much, sir. Thank you. And I think we have a break now, so we will reconvene at 8:15. Thank you all the participants.
Thank you. Thanks for giving this opportunity. Thanks a lot.
Thank you, sir.
Hey guys, are you still searching for the right master's courses? Then stop. Your search ends here. Center for Wireless Network and Application, Amrita Vishwavidyapeetham has opened its admission. You can be eligible for scholarship also. If interested, you can apply using the link in the description box.
Center for Wireless Networks and Applications, a cutting-edge research center at Amrita Vishwavidyapeetham, offers MTech and PhD programs. The center has the following state-of-art laboratories for researchers and students. India's first landslide simulation laboratory, and our contributions have resulted in the design, development and deployment of the world's first wireless sensor network system for landslide monitoring and early warning. This lab serves as a test bed for developing and varying the conditions of the systems that we intend to deploy in the landslide prone areas. These are the advanced equipments we use for testing soil and rock samples brought from the field. Their geotechnical properties are tested based on international standards. Keysight Technologies, a global leader in electronic measurement equipment and design tools, have collaborated to establish a state-of-the-art advanced wireless communications lab. This is one among the very few such labs found in Indian universities and has equipment valued at several crores of rupees. Smart Grid Lab targets distributed multi-scale smart networks which facilitate the integration of low-cost real-time monitoring and control devices into the grid. The lab serves as a test bed for students and researchers where they can plug in their modules and validate using the real-time data visualization tool. The lab also supports validation of renewable energy systems that are developed for rural electrification projects. This lab provides an experimentation platform for developing low-cost educational technology platforms. This lab hosts a variety of tools, including a host of specialized depth detection (PTZ) leap motion devices. A perfect platform for architecting a next-generation classroom system. using computer vision algorithms such as gesture detection, participant localization, etc. This lab will provide students practical experience in designing, deploying, and implementing wireless sensor networks in both indoor and outdoor conditions. Remote users will have a permanent test bed for development and testing of concepts. This lab includes 12 experiments demonstrating these concepts by providing study materials, animations, interactive simulations, and a remote panel. Hardware lab of Amrita WNA serves the students and staff for their research and development. The lab has various types of tools from Weller, Taperia, Fluke, Freeman's, Dremel, Bosch, Mecco, etc. Nearly 50 different tools can be found here. Our MTech programs.
Hi, I am Akshay Sudish, MTech Geoinformatics and Earth Observation student from Center for Wireless Networks and Application, Amrita Vishwavidyapitham. My research area is in the coastal change detection using satellite imagery. Recently, in one of the symposium organized by the center, I could meet up delegates of ISRI India and discuss my research work with them. They were interested in my work and offered me an internship. Now I am working with ISRI on GIS and remote sensing to estimate the coastal erosion rate. I am happy that I am contributing to some of the UN Sustainable Development Goals. I thank my faculty and staff members at Amrita WNA for supporting me. Thank you.
Amrita is now among the top 100 universities in the world and the first in India in the Times Higher Education Impact Rankings 2021. THE Impact Rankings is the only rankings to rate universities around the world on United Nations 17 Sustainable Development Goals. This feat is a testament to our Chancellor Amma's vision and leadership.
100 യൂണിവേഴ്സിറ്റിയുടെയും കണക്കുകൾ നോക്കുന്ന അവരുടെ റിസർച്ചുകൾ, അവർ കൊണ്ടുവന്ന ഫണ്ടുകൾ, അവരുടെ ബുദ്ധിപരമായ കാര്യങ്ങളൊക്കെയാണ്. അപ്പം അങ്ങനെ വെച്ചിട്ടാണ് പ്രൊമോഷൻ വലുപ്പം നീന്ത്. ഒറ്റ ഒരു അപേക്ഷ, ഈ നമ്മൾ കൊണ്ടുവന്ന് നടത്തിയ റിസർച്ചിൽ അല്ലെങ്കിൽ നമ്മൾ ചെയ്തത് സമൂഹത്തിന് എത്ര കണ്ട് ഉപകരിച്ചു, അല്ലെങ്കിൽ എത്ര കണ്ട് നമുക്ക് സഹായിക്കാൻ പറ്റി എന്നുകൂടി ഒരു ഭാവം നമ്മൾ ഉണർത്തിയെടുക്കുകയാണെങ്കിൽ അതൊരു സ്വർണ്ണത്തിന് പരിമണം വന്ന പോലെ ആയിരിക്കും.
Now ranked 5th in the world for quality education. Eighth in the world for gender equality. 37th in the world for good health and well-being. 52nd in the world for clean water and sanitation. Top 200 in the world for industry, innovation, and infrastructure. Top 200 in the world for partnerships for the goals. We thank our students, faculty, staff, alumni, and partners who are influencing change both nationally and globally as we build for the future. A university where future is driven by imagination. Experiential learning creates diverse opportunities, where industry exposure and international partnerships help you sail. Come, start your journey towards success with Amrita University. Success. It's the buzzword today in all walks of life. In your journey towards success, the university you choose plays a major role. With top-class research infrastructure, PhD faculty, and high-quality education, Amrita plays a major role in its students' success stories. Come, join Amrita University, an institution of eminence by UGC, ranked as the top private university in India by Times Higher Education World University Rankings and the 4th best university in India by NIRF Rankings 2020. Through our specially designed Chancellor's Scholarship, we provide up to 100% fee waiver and help you learn from the best. Our dual degree program in association with top universities from US and Europe can get you ahead of the curve. Come, start your journey towards success. Visit www.amrita.edu. Success starts with Amrita.
There's a place where the best minds come together, work to end inequalities, work towards transforming lives. This is a place recognized as one of the world's best universities. This is Amrita, now ranked among the top 100 universities in the world and ranked #1 in India. Amrita University.
Education has the mighty power to move millions of minds, from darkness to light, from limitations to limitlessness, from finite to infinite. Our country is believed to have had a higher education system as early as 1000 BC. But today, only 26.3% of the total eligible population enroll for higher education. Only 8.15% of people are graduates. Amritam Kamea. Now is the time to revolutionize, rethink, redefine education. 4th best university in India introduces new normal in delivering education to the masses. Amrita Ahead. Online degree programs. Unlimit yourself. Get ahead.
Dr. Karthik Shankar Narayanan, are you there? You had expressed the willingness to answer a question in the Q&A box. Probably not. The question was, as an agri student, do restaurant from Ajit Kumar. All right, so we can move on. So I will hand it over to Dr. Daanya to share the remainder of today's talks. Dr. Daanya.
Okay, thank you, sir. Hello, everybody. Welcome back to the last session of today's deliberations. So as our first speaker, we have Professor David Toll. He's talking to us on resilience of transportation infrastructure to climate impacts. Professor Toll is a professor of engineering and research director for sustainable infrastructure at Durham University, UK. He is co-director of the Institute of Hazard, Risk and Resilience and the incoming chair of the British Geotechnical Association. He is the chair of the ISS MGE's Technical Committee JTC106 on unsaturated soil, and he established the Joint Technical Committee JTC2 of FED IGS on geoengineering data in 2005, and he was the inaugural chair for 12 years. He's a fellow of UK Institution of Civil Engineers, ICE, and has been chair of ICE Northeast. He's a fellow of the Learned Society of Wales. He has been carrying out research into climate resilience of infrastructure and information technology applied to civil engineering for 30 years and has published over 200 papers and 12 books. The main applications of his research are in data representation, knowledge-based systems, case-based systems, neural networks, and support vector machines. He was the organizer of the ICITG conference series, which is the International Conference on Information Technology in Geoengineering, in 2010 and 2014. Professor Toll has held visiting professor and research fellow posts at the Tongji University, China, National University of Singapore, Nanyang Technical University, University of Sydney, University of Western Australia, and University of Newcastle, Australia. He was the founding editor of the journal Geotechnical and Geological Engineering and has been a member of the editorial boards for Geotechnic and Quarterly Journal of Engineering, Geology, and Hydrogeology. It's our proud privilege to have you here with us for this program, sir. A warm welcome to you. Let me hand over the session to you.
Thank you very much. It's a great pleasure to be here with you this evening. And thank you to all of you in Amrita who have stayed up so late for this session. So I'll present on resilience of transportation infrastructure to climate impacts. And I'll try and cover two of the themes of the symposium. So first of all, I'll present about a program called the Achilles program, which is a large cooperative research program in the UK investigating climate change impacts on infrastructure. So it's a collaboration between the universities of Durham, Newcastle, Loughborough, Southampton, Bath and Leeds, and the British Geological Survey. And then the second study, which fits into the theme of machine learning, relates to a project that we've been carrying out with the University of Minho in Portugal, looking at the identification of the stability condition for engineered slopes. And we'll be using machine learning algorithms, artificial neural networks, and support vector machines. So I'll try and cover those two topics. So starting with the Achilles program. So this is a program funded by the Engineering and Physical Sciences Research Council in the UK with about almost £5 million of funding. So it's a large collaborative program. And within that program, we're addressing three research challenges. The first of those are to look at deterioration processes that affects geotechnical assets associated with the transportation networks. So these are the slopes involved in either cuttings or embankments on the road or railway networks. And particularly interested in the problems of landslides affecting these as a result of climate effects. So I'll talk about that research challenge this afternoon, and particularly the deterioration processes associated with weather conditions. As well as that, the program is addressing the performance of individual geotechnical assets and trying to understand how that fits within a whole network scale and understand the engineering performance of the network. And then the third challenge, which is one that will be of interest to those who are interested in the machine learning, is looking at forecasting and decision support utilizing hierarchical Bayesian modeling. to synthesize many data sources with physical models. But as I said, I'm going to concentrate on the deterioration processes in my presentation today. And I'll start by just showing you a map of the UK. And so you can see a number of markers on the map, which are our experimental sites in the UK where we're measuring the impacts of climate and trying to understand what's happening in the present, so that we can start looking at understanding how it will behave in the future. And I'll talk about a site here in the northeast of England. It's called the Bionics Embankment, and that's actually up near where Durham is in the northeast of England. We also have sites down in the southeast of England, and we have done monitoring in Northern Ireland. What you can see on the right-hand side of the slide is climate models looking at future winter and summer scenarios into the 2080s and beyond. And what are the likely changes in precipitation against our benchmark in the early part of last century? And what we can see is that each of these graphs represent different emission scenarios in terms of greenhouse gas emissions. And we can certainly see, if we look at the summer maps here, we can see some red colorations, which is suggesting that we're expecting to see quite significant reductions in precipitation in the future. Whereas if we look at the winter scenario, we can see the blue colors indicating that we're expecting to see quite large increases in precipitation. So the expectation is we'll have wetter winters and drier summers going into the future. So this is one of our experimental sites, and you can see the embankment on the left-hand side. Some of my colleagues installing instruments into the embankment. Bottom right-hand corner, you can see a sprinkler system where we can impose known climatic conditions on the embankment. And you can see on the bottom left-hand side, many of the instruments that are actually protruding from the embankment itself. And this is a plan view of the embankments. Some of the sections are actually what we call the pore compaction test plots, which represents the typical state of the older infrastructure assets in the UK. That's particularly true of the railways that were built more than 100 years ago in many cases. And they're often relatively poor in terms of compaction, whereas the centre sections actually are compacted to highway specification, representing a better level of construction that was for much of our highway infrastructure that was built in the 1960s and beyond. And you can see a typical cross section. This is a 6-metre high embankment that was built specifically for this experimental work. And you can see there's a large amount of instrumentation installed within the embankment, tensiometers for measuring negative pore water pressures, soil moisture probes, piezometers, theta probes, again for water content measurement, and extensometers and inclinometers to measure movements, and of course weather stations and temperature probes, so we know the climate conditions that's imposed on the embankment. And this is an early part of our data set. So this is data starting back in 2009, and we've got continuous records now from that time period. So we've been monitoring this for over 10 years. This is some data of pore water pressure measurements, and you'll notice these are negative values. And what we can see is that during the summer month, we have these distinct drying periods where the pore water pressures become highly negative. Often during the summer, we then see that those pore pressures reduce. That's due to a wet period that often happens during the British summer. Usually when people are planning to take their holiday, that's when it starts to rain. But then later in the summer, we have another drying period going into the autumn. And then, of course, it starts to rain as we go into winter, and we have this period of wet conditions, and then back into another drying period in 2010 and 2011. And you'll notice that in 2012, we see a very different pattern. And that was a very wet period in the UK, when we had really no drying taking place at all. And a lot of landslides happened across the UK during that particular year. So to understand what those drying and wetting cycles are likely to mean, we've done a lot of triaxial testing, and particularly looking at unsaturated soil testing. I won't go into any of the details here, but happy to answer questions on that if people are interested. And I'll just show you a graph that shows the strength reduction associated with dry and wet cycles. So what we've got here is stress at failure, so a measure of the strength of the material, plotted against the number of dry and wet cycles that the soil has been subjected to. And so at 0 here, this is the as compacted condition, and we can see we're getting high strengths measured at that initial stage. And then what we've done is taken that material, subjected it to a drying period, and then re-wet it back to the same water content. And what we find is that if we measure the strength after one cycle of drying and wetting, even though it's at the same water content, we're getting very significantly reduced strengths compared with the as compacted condition. And after 2 cycles, again, it continues to drop. But then after 3 or 4 cycles, we see it's leveling off and no further change. And we can explain all these phenomena in terms of the suction changes that are produced as a result of these wetting and drying cycles. But clearly those changes in strength are very significant in terms of how our earthworks are likely to behave. And we can see the same sorts of patterns for other data sets. These are shear strengths measured against gravimetric water content. So again, starting at a wet water content and then drying back, we can see the strength increasing. But then if we stop at that point and wet all the way back up here to the high water contents, and then start drying again, the second drying cycle shows a significant reduction in strength. And again, if we then do another cycle of wetting up and then drying back, we've got another loss in strength. And we see this very consistently in all our data sets. And this is some testing on tensile strengthening as well as tensile strength testing, as well as compression testing. And again, we see that loss in strength each time we go through a cycle of wetting and drying. So if I start by concluding on that first part of the project, so for this Achilles project, we're investigating the effects of climate change on infrastructure slopes, that's embankments and cuttings. We've particularly focused on the railway network in the UK that's been badly affected by landslides. And Network Rail, who have to manage the company that manages the railway network, are often, on average, dealing with a couple of landslides every week, particularly during the more wet periods. So even in the current day conditions, we're suffering from problems. But what we know is that our climate models tell us that in the future, we're going to have more extreme rainfall events during the wet periods in the winter, and longer drier spells and quite severe drought possibly during the dry seasons. So what we're expecting is these wetter winters, drier summers. And what our investigations show is that we get a progressive deterioration in performance with significant losses in strength as a result of the soil materials being subject to drying, wetting cycles. And since we know that the cycles of wetting and drying are likely to become of greater amplitude in the future due to climate change, it's vital that we take these factors into account in designing for the future and allowing for this progressive deterioration and loss in strength with time that we know will take place. So that was the first part. I'll now switch to something for the people who are interested in machine learning and talk about the work we've done at the University of Minho. And these are my colleagues here, Joaquin Tinoco, Antonia Gomez-Correa, and Paulo Cortes from the University of Minho, who works on looking at how to use machine learning for slope stability identification. So, as we say, the management of railway slopes is a difficult task, particularly because of the budget constraints of railway operators. So they really need to be able to identify which slopes are in danger of failing and which are at most risk. And so they operate by trying to quantify and classify their slopes into different stability conditions. And they use an earthwork hazard category to predict their behavior. And this represents the earthworks hazard category. A here means that the earthworks are in good condition. B and C is moderate category, and D and E are the poor category. And that means they're at greater risk of failure if we're in the D and E failure. And what we want to do is predict which of the categories our slope is in based on routine inspection data. So Network Rail has inspectors who go out and check the slopes and observe different factors. And can we use that observation data to predict the stability condition? And to do that, we used a modeling strategy based on nominal classification, just trying to fit things into boxes, if you like. But as you'll see from the data, we had to deal with a difficulty that we have very unbalanced data sets. And you'll see that in a moment. So to try and address those issues, we've looked at oversampling techniques, one called synthetic minority oversampling, which uses a nearest neighbor algorithm to try and create new data to try and balance the data set. Or we can use a simpler oversampling approach that randomly adds repeated versions of existing data. So just trying to balance it by repeating data sets. So we've tried to approach this a number of ways. We've used regression and nominal classification. And I'm just going to talk about the nominal classification approach today. And we've used two machine learning algorithms. So artificial neural networks with a single hidden layer. And we've also used support vector machines where we take the real data set and try and transform it into a feature space using some form of nonlinear mapping that we can then use linear functions to try and separate between the different categories. So to measure how well these models are performing, we've got various metrics that we can use. We can use recall. So that's the percentage of all the cases of a given class that are correctly identified. We can look at precision, which is the fraction of all the cases identified that really belong to that class. So making sure they've ended up in the right box. And of course, both of those are quite useful measures, but sometimes we want to combine a measure of those. So we use this thing called the F1 score, which is a combination of both precision and recall. And all these measures have been expressed on a scale of 0 to 100%, with a higher value being better. So as I say, the data we were working with was very unbalanced, and you can see this now. So this is the data and classified according to Network Rail's own classification of the risk of these slopes, the category of these slopes. And we've separated the data into rock cuttings, soil cuttings, and embankments, where we're building soil up above the ground level. And we have about 6,000 slopes in the rock cuttings category, about 11,000 data sets for the soil cuttings, and about 25,000 cases for the embankments. And all this data has been made available to us by Network Rail, so the company that operates the rail network in the UK. And what we can see is these data sets are very biased. We've got a lot of them in the category A, which of course is great. That's where we would hope most of our infrastructure fell in a good state. But we can see that there are some slopes that fall into the poor category. And just to make a note here that I talked about a 5 category D and E, we found it very difficult to split, to analyze the data and split between a poor category and, if you like, a very poor category. So for our work, we've actually put everything into a single category and combined the D and the E together. And the data we're using to try and predict these categories use more than 50 variables. Some of those are slope geometry, things like existence of trees, animal activity, whether rabbits or badgers are digging holes in the slopes, different types of ground cover, and many other parameters that we can make use of to try and predict the classification. And these are the results for the rock cuttings, first of all, and I'm showing these first because this is the most difficult one for us to predict. So what I'm presenting here is, first of all, these are the metric values for recall, precision, and F1 score, and I'm presenting data depending on how we've oversampled, so 3 different types of oversampling. But I won't go into a lot of detail on that. We'll just look at the broad brush picture here. So we've got the artificial neural network response of the models on the left and support vector machines on the right. And what we've got is our predictions in A, B, C, D, and how well they do in terms of recall, precision, and F1. So we can see, starting with ANN, that we're getting very good scores for class A. We're predicting them very well with scores up in the high 90%. So there, we're doing really well at predicting the good category. Not so good with the moderate categories. Values are sort of around 50% for the F1 score for B, and not even as good as that for C. And for D, our poor category, we're doing very poorly. We're actually getting less than 14% being correctly predicted. And of course, that's a major problem, because ideally it's these poor quality slopes that we would really like to be able to predict well. So this is, means that these models aren't working well for this particular data set for the rock cuttings. So clearly it's difficult for us to predict these outcomes based on the observation data set for rock cuttings. We look at the data for soil cuttings. Again, very good predictions for class A. I should have mentioned before that even for the rock cutting, that the artificial neural network tends to do better than the support vector machines. So we've generally focused on the ANNs as our better models. So again, the ANNs work best for our soil cuttings as well. Good predictions for class A. We're now doing better at predicting class B with values around 60% for predictions in B and over 50 for C, and starting to look a little bit better in predicting class D. So we're getting an F1 score of about 35%, so doing a little bit better with the soil cuttings. And then for the embankments, we're starting to look a little bit better again. So again, just focusing on the ANNs, good quality predictions for the good category, better for the moderate, so over 60% here in both both B and C now, and now doing better at predicting in the poor category, the class D, where we're doing over 50% predictions. And so in conclusion, for our rock cutting data, we do quite well in predicting the class A, but class D, our predictions weren't good at all, only 14% that we're getting in terms of our predictions. A little bit better for slope soil cuttings, and good for A, and a little bit better for B and C, and starting to get some reasonable scores for class D. But it's the embankments where the models are working particularly well, where we're getting over 92% for class A, and even for class D, we're getting an F1 score of close to 55%. So those are the two projects. Hopefully that's given you a bit of the flavor of the work we've been working with our collaborators at Durham University, and my thanks to you all for listening, and of course to all my collaborators, my colleagues in the Achilles program, and my colleagues at the University of Minho, who have been working on the machine learning algorithms. So thank you very much for your attention.
Thank you very much, sir. Both projects that you showed us are very interesting. And we do have a question from the audience. This is on the first part. The question is, where the strength tests performed on structures that were made from natural compacted soil type of structures. Does this mean that a laminating layer of waterproofing will reduce deterioration significantly?
We have been thinking about that, about ways of mitigating this project. And in fact, interestingly, we have another project which I haven't been talking about called Cactus, which is about climate adaptation methods, where we've actually been developing what we're calling climate adaptation barriers. The difficulty is if you just put waterproofing layers onto our infrastructure, that causes a lot of runoff of water into neighboring areas, and that causes problems elsewhere. So ideally, we want to prevent water getting into our infrastructure, but we want to hold that water. So what we're currently developing within the Cactus project is water holding barriers, which actually have a water holding layer that has high water retention capabilities, can hold the water during a rainstorm, and then it becomes evaporated or transpired back into the atmosphere afterwards, using vegetation to encourage that process. And so, yes, that's certainly one of the opportunities we're looking at to try and prevent this cycle of wetting and drying between seasons.
Thank you, sir. I do have a question on the second part of your presentation. When you showed the differences in the model quality with your 4 categories A, B, C, D, do you think the number of data points have an impact on the quality? Because the sample, the category D seem to have considerably lesser number of data points than A and B.
Yes, of course, you're absolutely right. And even with the oversampling techniques that we've tried to do, that doesn't seem to be sufficient to be able. So you're always, and unfortunately, or maybe I should say fortunately, when we're dealing with infrastructure, we don't have as many cases that are in the poor category. As say, ideally, we would hope that most of our infrastructure is in the good category. And so we're always going to be working with unbalanced data sets for these things. And that clearly has an impact on the ability to predict with these types of models. And unfortunately, there's nothing we can do about that. And the oversampling does a little bit to help that, but doesn't actually correct it entirely.
Thank you, sir. Thank you very much for your wonderful presentation. And with the kind of data sets that you were showing us and the observations that you were showing us, we do have observatories in Sikkim and Munnar. And I don't know how aware of you are of Amrita's project. We have in situ measurements in these two sites. We do work with pore pressure modeling, monitoring and modeling and things like that. So we would like to continue our association with you in furthering this aspects.
That would be fantastic. Yes, I really look forward to continued collaboration, and very, very happy to discuss in more detail about that. Thank you very much.
Thank you very much, sir. Let me welcome Dr. Mohammad Imran, who will talk to us about how AI is transforming disaster response. He is a senior scientist and lead of the crisis computing team at the Qatar Computing Research Institute. His interdisciplinary research focuses on natural language processing, social and crisis computing, computer vision, and applied machine learning. Dr. Imran received his PhD in computer science from the University of Trento in 2013. He then worked as a research scientist at QCRI from 2015 to 2020. Dr. Imran has published over 80 research papers in top-tier international conferences and journals, including ACL, SIGIR, ICDM, ICWSM, and WWW. 4 of his papers received the Best Paper Award and 2 Best Paper Runner-Up Award. He has been serving as a co-chair of the Social Media Studies track of the ISCRIM International Conference in 2014 and has served as program committee for many major conferences and workshops. Welcome to you, sir. Let me hand over the session to you.
All right, thank you very much. Can you briefly confirm you can see my screen and you can hear me well?
Yes, sir, we can see and hear.
All right, thank you very much, first of all, for the invite, and it's my pleasure to talk to all of you. So my name is Mohammad Imran, and I work as a senior scientist at Qatar Computing Research Institute. And today I'm going to talk about how AI is transforming disaster response. So first of all, a big shout out to my colleagues and collaborators, a bunch of them. Without their work and collaboration, the work that I'm going to present would not have been possible. So really thankful to all these people. All right, so as we know, there are different advantages of AI, but one of the big main advantage of AI is to drive down the time to perform complex and recurring tasks, right? And we also know that the time during disasters is also a very important factor. So here on your screen, you can see a chart. On the x-axis, it shows the time, and on the y-axis, it shows the impact or the effort that some agencies put. So the red line here shows the disaster event when a disaster strikes at some certain time, and the blue line shows the response from authorities. And we see that there is a big gap between the red line and the blue line. So that gap really delays the decision-making process. And then definitely if the decision-making process is delayed, the actions from those agencies would be delayed, and that will eventually lead to high community harm. Now, at Qatar Computing Research Institute, one of our major focus is to reduce the gap between when a disaster strikes and enable authorities, governments, and humanitarian organizations to decide, take their rapid actions. And we try to provide them whatever they need to do early decision making, and we hope that that will help them to reduce the community harm. Now, why does time matter? So on this chart, which is a survey done by FEMA in the US, survey from many different disaster managers, we can see that different types of information after a disaster, like in terms of building damage, transportation damage, disaster extent, and so on and so forth, these information types reduce their values as time passes. So here we can see that the effectiveness or the information value of all these types is 100% at the 0th hour when the disaster strikes, right? And eventually, with the time passage, this values goes down. For example, the building damage information type reduces more than 30% of its value after 48 hours. So here I'm talking about the first response from the authorities, the rapid response. Definitely, there are recovery efforts and other types of response, but I'm talking about the first response from authorities. Now, this is the bucket that we target and provide humanitarian organizations with required information. So it's the first 48 hours to 72 hours is the time period when most of the information are not available, readily available to different disaster agencies for their decision making. Now, let me show you how, for example, different types of non-traditional data sources would help here. And you would agree with me that like before social media came into being on 2006, getting all these different types of information would require maybe weeks, because you need to dispatch teams to the disaster areas to conduct surveys and then collect information and come to the headquarters, and then the decision making happens. So this process is tedious, it takes time and resources. So, but with the help of social media, can we leverage, can we extract similar information maybe in a timely fashion, right? And it has been studied a lot in the literature, and studies show that with the help of social media platforms like Twitter, Facebook, and there are hundreds of other platforms like WhatsApp and Instagram, one can access to similar kind of information in almost real time. So that's what we wanted to use social media for. Now, as I said, that different types of social media platforms, but let's take the example of Twitter. And we know that Twitter is known for breaking events. So for example, the Hudson plane crash, first report came on Twitter. Similarly, Boston Marathon bombing, first report came on Twitter. And our extensive analysis of a large number of disasters ranging hurricanes to earthquakes and floods show that a large proportion of information on Twitter come from general public, and they talk about needs and donation. They talk about people who are affected. They talk about caution and advices, and so on and so forth. So in addition to this, in addition to the textual messages that people post during disasters, they also post a large number of images. So here are the images that I'm showing you from different types of disasters that we collected from Twitter. So you can see the images about road infrastructure damage, building damage, electricity and communication lines damage, and so on and so forth. So among different advantages of these images, first of all, these are ground level imagery as opposed to, a satellite imagery, which only gives you the top view. And since these images show real damages, they are coming from, eyewitnesses, bystanders, and these can be considered first-hand reports in the early hours of a disaster, and they are quickly available. You don't need to have any kind of activation, and the variety of these scenes is huge. You can infer and use for lots of various purposes here. Now, given this useful data is there on social media, there exist many challenges when it comes to the to the extraction of this data. So one of the big challenges is that such social media platforms produce high volume data, and we have seen that over different disasters, like millions and millions of messages pile up during hours and days of disaster. In addition to that, not only high volume, the velocity of these data is very, very high, maybe tens of thousands per minute, which is beyond the capacity of human resources, despite you have a large crowd to process them. Now, another biggest challenge is the irrelevancy of the data. And based on our analysis of different disasters from Twitter, we have seen that over 60% of the data is totally irrelevant that people post. And those include, here you can see on your screen, in the form of image modality, you receive cartoons, you receive advertisements and celebrities and whatnot. Now, out of the remaining data, we see that many data points are duplicates. And here, for example, in terms of image modality, you will find blurred, unblurred scenes, text, images with and without text, cropped images, resized images. People retweet, people reshare these images. So like almost 80% of the other half consists of just duplicate content. Now, out of the tiny portion of the remaining data, in terms of, for example, if we are interested in damage analysis, only 3 to 8% of the data has these damage signals. And here on your screen, you can see the proportion of different damage classes. For example, this is only relevant data. So Hurricane Harvey, Hurricane Irma, and Maria, and you can see the severe class is only very, very tiny, maybe 2 to 3% of all during all the disasters, and a little bit higher proportion for the mild class, and majority is non-class, none to little, where there is some disaster scene, but it's not damaged, or it's not severely or mildly damaged. Now, in order to sift through millions of data points within minutes that pile up, definitely we cannot use human resources. We have to use some artificial intelligence techniques which can help us, process these data and extract these informative signals. We call this problem as a finding needle in a giant haystack that grows each passing minute. So for that purpose, we have developed one system called AIDR, Artificial Intelligence for Digital Response. It collects data, it uses human intelligence and machine intelligence together and build models to classify data into maybe different urgent needs that people are facing, maybe different damage classes, and so on and so forth. So this platform is available on this URL. And I'm also proud to mention that we also win the open source software world challenge in 2015. Now I'm going to show you some of the real world deployments of this system with real stakeholders during real disasters. Before doing that, let me introduce you briefly one of our pipeline, which is the image processing pipeline, specifically for damage severity assessment out of social media images. So the task here is, given an image, is to assess whether this image shows severe damage, which means fully or more than 90% of the whatever infrastructure type is shown is destroyed in terms of buildings or houses, and those are non-livable, non-drivable roads or bridges. And mild damage, which is partially destroyed buildings, probably they are livable, and probably they are drivable, but they are partially destroyed. So having this task in mind, I'm showing you a very high-level overview of the pipeline, which consists of several components. Obviously, it starts with the data collection, and then we have relevancy filtering and deduplication filtering, and then damage assessment. So all these three components use deep learning models, computer vision deep learning models, to process thousands of images in real time. So here, for example, I show you the performance of our damage assessment model, which is pretty well in terms of mild and non-classes, but it's not doing well according to this precision recall curve for the mild class. So we learned that with the help of experts that the mild damage is kind of confusing. It's a kind of subjective category, even when we present those images to human. So the model inherited that confusion inside it. Now, one of the deployments, and also the recent one, is we deployed this system during 2019 Hurricane Dorian with the Montgomery Community Emergency Response Team in the US. They worked with FEMA to analyze social media to extract damage scenes. So they are a bunch of volunteers and expert people on this task. So we actually helped them deploy this system and look at all the tweets. In this case, we looked at more than 8 million tweets and 300,000 images. And the system classified all those images in real time, and in total found 13,349 images showing severe damage or mild damage. And here I'm showing you how the dashboard looks like. And there are different filtering options that experts can filter through. And then there was an option for experts to tell whether what they see is indeed correct or not, and we found that 76% of the times they found the system prediction as a correct prediction. Similarly, we deployed the system during Beirut explosion, and it's a similar pipeline, similar classifier, severe damage, mild damage, and no damage. And let me also give you another application that we are still working on. This is a collaborative work with a European Mediterranean Seismological Center and British Geological Survey. The task here is to identify landslide events in social media streams. So what we do, we have developed models which can sift through these, images that people share and identify whether it's a landslide, rock slide, or mudslide. And this is still a work which is in progress, but we have seen major, successes in collecting this data over time with the help of experts. Let me show you a very brief evaluation that we did. So here on this chart, you see that the blue dots are showing the NASA landslide events collected or identified using satellite imagery. And the red ones are the incidents or the images that our system collected. And you can see that, and these are all verified by the experts. And you can see the system collected a very large number of events than what NASA can collect using satellite imagery. Another application, rather on the NLP side, is to find education insecurity events or reports on social media. So you know that many incidents of education insecurity where there is a damages to school or bombing or kidnapping of students and so on and so forth are not reported in mainstream media, but they are reported on social media. So the purpose here is to assist United Nations OCHA and education above all organizations finding these reports with the help of AI and machine learning models. So we have developed several multilingual classifiers. These are the text classifiers which look at Arabic content, French content, and English content and find pertinent reports. And these go to this dashboard, which is publicly available on this site. Okay. On the last few applications, so this is here the purpose is to combine remote sensing and social media to to identify flood extent. So what we do, we use change detection techniques with the help of before and after satellite imagery in an area of interest. And then we try to overlay social media reports, which are geo-referenced. And those reports, for example, showing damages, flooded roads, and so on and so forth. And we try to, strengthen our signals, which we collect from remote sensing techniques and social media to make better, decision for the response efforts. Now, if you are interested in using our data sets, this is the largest data set that we have on the human labeled images that cover 43 different incidents like wildfires and floods and earthquakes and car accidents and so on and so forth. And these are all human labeled across different places as well. So we have wildfire in the forest. We have fire in the city center. We have floods in downtown in different places. So you can access the data from this URL, and there is a demo available on this. And more data sets on the NLP side are available on crisisnlp.qcity.org, as well as if you are interested in COVID-related data set, we have the largest multilingual data set with geolocation information available on this URL. And more information about our work and publications can be found on our Crisis Computing website. With that, I would like to thank you again for listening, and I'm open for your questions.
Thank you, sir. It was a very interesting presentation which took us through the various aspects of the use of social media during disaster scenarios. Thank you for introducing us to AIDR. We do have a question. How do you correlate location from the social media sources? Does your platform automatically look for syntactical references from the posts, or do you use other corollary information?
Yeah, that's a very good question. So I didn't get a chance to go into the detail of all these models and steps that we perform to extract these signals. But you might be aware that only 1 to 3% of social media data, in particular Twitter data, comes with some geolocation information, and almost 97% of the data does not have any geolocation information. So we have built some geolocation inference systems which try to look at different metadata. For example, we look at location mentions in the tweet text. So we look at if someone is saying that this particular road is flooded, we try to look at the road name, that dependent mention name, and then try to geolocate it with the help of other signals that we find in a given temporal time window, right? So this is one type of signal. The other type of signal is we look at user location metadata. We look at user profile metadata, and then we also look at some place tags that people tag when they tweet about something. They don't mention any location in the tweet text, but they probably tag some locations like a city, maybe a neighborhood, and so on and so forth. So using all these different types of metadata, we have a kind of a technique that leverages this data as well as performs some kind of triangulation, and then a kind of one location that receives the highest weightage is then used for the assignment for that data item.
Thank you, sir, for that clarification. I do have another question for you. You showed how the flood extent is mapped using the satellite image also, combining with your other data. So what is the latency? I mean, after a flood event occurs, how fast do you produce these flood extent maps?
Right, this is also a very good question. So definitely the latency that is inherent is in the satellite image retrieval. So we have right now access to mainly two types of data sources, one which are publicly available to anybody, like Sentinel-1, Sentinel-2. And these satellites have their own revisit latency. So for example, Sentinel-2 has a revisit latency of 5 days, which is huge. And if you are lucky, if you're lucky and the satellite is in the right orbit, in the right area, you will get the satellite imagery. If otherwise you don't. The other type of satellite resource, which is not open source, is Maxar imagery. So that is relatively less in terms of latency. But for the purpose of building these models, definitely we don't really care about the latency as long as we have a large number of data items with a pair of before and after imagery available, labeled by human for the training of machine learning classifiers. And in this case, for example, a change detection method or maybe a deep learning classifier. So that is enough for us. For the deployment purposes, you are right. The latency plays an important role, and You have to see if the resource that you're relying on can give you the data. Otherwise, you only rely on social media sources.
Okay, thank you, sir. Thank you very much for the wonderful presentation.
Thank you.
Because social media is present everywhere in our lives, and its influence is only expanding. And with more disasters also around the corner, I think the type of research that you do is very important in disaster mitigation efforts. Thank you once again. So we have another very interesting presentation coming up next from Mr. Ravi Teja. He is the CTO of Sentience. He has worked earlier with Flipkart and PayPal. Ravi Teja has been architecting and building internet-scale distributed systems since a decade and is now heading Akiro, which is an internet-scale messaging platform for IoT media. He was an early contributor in Apache Yarn, Hadoop, Taze, and MapReduce. Welcome to you, sir. Mr. Ravi Teja will present today about how IoT combined with big data becomes very powerful. Over to you, sir.
Yeah, so there has been a slight change in the topic, and I think the title was not updated. So today we'll be talking about how Akira with IoT will help in environmental sustenance. So if you see, Earth has been around for 4 billion years, and when did humans come? Maybe 200 to 300,000 years. So Earth has gone through a lot more worse, right? Like tectonic changes, reversal of magnetic poles, volcanic eruptions. So nature has a very powerful self-correcting mechanism, right? And if its habitants do not play by its rules, it self-corrects. So if you want to be in this planet, we need to play by its rules, and we need to understand how to coexist with its ecosystem, right? And Earth has already given us various warnings in form of global warming, climate change. And if we ignore these warnings and don't act on it, we are at loss, and we need to be ready to be evicted. So all we are trying is taking care of our home and not meddling with it. Let's see where we are today. Right? So if you see the climate's tipping point, we are closer to that than we actually imagined. We are talking about tens of thousands of cubic meters of ice, which is melting. And we are already close to 400 ppm of carbon dioxide in the atmosphere. So good thing is the change has begun, right, globally. And countries like developing and developed countries are coming together to act on environment. And it's a long way to go, right? It's not an easy path as well. And we definitely need a companion which can actually help us reach there. And it's technology. And if you see, there are large improvement points which are required in many areas of industries, wildlife, taking care of them, and agriculture, and also large cleaner energies. So if you see, right, the good news is technology is already there, and technologies like IoT and ML can actually help you and take us to the goal much more faster. And coming to the first step, right, what is the first step we need to take? That is the measuring. So measuring is the first step of any change, and that helps us measure where we are and is the steps which are taking are helping us or not, and how much it is affecting. So if you see how actually IoT helps you in sustainability, let's take some examples. One is, as we are talking, take the measuring. So if you see, IoT helps you in measuring the impact on the ecosystem and environment in various layers, like starting from water, air, or waste disposal, garbage disposal, or much more powerful equipments like and camera feeds like weather and other data as well. Next is the smart farming. So if you take smart farming, agriculture is a very important contributor of environment, right? So, and if we see, there are various aspects, like starting with analysis of various factors like soil and weather to the implementation of it, like planting and spraying pesticides and fertilizers and so on, right? So all these places IoT can actually play a major role. Next is smart cities. So cities are a very important factor of ecological balance, and they actually contribute a lot to pollution as well as the resources it uses. So effectively taking care of these resources and waste management and so on actually helps a lot. And IoT plays a very important role in smart cities and smart home automations. Next is the cleaner energy. To reduce the carbon footprint of our planet, it's very important that we move to cleaner energy as soon as possible. And IoT helps it in a very large way, like starting from deployments of clean energy systems like windmills or large-scale solar deployments, and also operationalizing them, means maintaining them and getting different data of them and analyzing how to make it better. And last but not the least, the wildlife, right? So it's not, Amazon forest is called as the lungs of our planet. It got its name because of a reason, right? So it's very important that we understand the ecosystem around wildlife, and also we need to make sure we act accordingly and actually preserve it. Yeah. Now let's take some examples and deep dive into how actually IoT helps you in taking care of the ecosystem. So let's take this example of drones in agriculture. So drones are a very important part of agriculture these days, and this particular trend is picking up, right? And if you see this example, 95% of the pesticides actually don't reach its target, and it gets eroded in the soil, and it gets washed away to the nearby water bodies and lakes, right? So that is why it's causing a lot of issues. So if we see how IoT can help in this particular aspect, so it plays a two-part role in farming, right? So one is analysis, right? One is the soil and field analysis and checking how well the soil is irrigated and the different chemical compositions of the soil, right? Using sensors or food imagery and so on, right? And next is the assessment, health assessment of the crop and weed detection and so on, right? This is the first part where analysis is done. The second part is the implementation and actual operation of the farming, where we are talking about planting, spraying pesticides, spraying fertilizers, and also irrigation, which is a very important aspect in drought countries, right? So by doing all these effectively, it's not only saving resources, also it is saving a lot of damage which is being done to the ecosystem. And how it helps, like as I was saying, it is water saving, it helps prevent nutrient runoffs, and also it optimizes the usage of pesticides and fertilizers. So these are some things which are major problems today. And with IoT coming into picture, these can actually help us a lot, right? And not only the environment aspect, even farmers save at least 85% of their farming operational costs with IoT. So that is an incentive for people to move to IoT as well and make the environment better. Moving on to the next use case, we'll be talking about the home automation. So it might be a little surprising how home automation fits in environment sustainability. But if you see, we're talking about around 30% of lower energy consumption with home automation. This is with smart lighting, smart cooling and heating systems, because these are some things which take a lot of energy, and making these efficient is very important in sustainability of our environment, right? And if you see various use cases where IoT can play a role in the environment, like one is heating and cooling equipment control and making it efficient. Like if you do it manually, generally you set a temperature which might not be optimal, right? But automation around this heating and cooling systems makes that automated and sets the temperatures according to how much you might need. And this is all dynamic, right? And we are talking about controlling of home equipment and lighting. Sometimes you forget switching off and switching on the lights. So automation around that really helps saving energy. And next is the water usage, right? So this is again two parts. One is the lawn irrigation and all, right? So generally we switch on the sprinklers and we forget it, right? And it might not be optimal. So automating this with home automation also is a very important thing, and it saves a lot of water. And not only that, even leakages are a huge problem in homes. Like if you have a pipeline leakage, the water keeps going, and that's a huge loss. So even this is being automated by home automation. It detects the water leakage in the pipes, and actually it stops the cuts off the pipeline, or it will actually give an alarm to the owner. So what we're talking with IoT here is actually energy saving and water saving, right? So which are very important aspects. Now moving on. So if we see what are the key challenges in IoT solutions, which help all these use cases, right? And we're talking about use cases across domains, like two of them we have seen. One is agriculture, one is home automation. Similarly, smart cities, wildlife, cleaner energy, and so on, right? So it being a complex system, it has its own challenges, and the systems which you use it needs to take care of all these challenges. Then only your path will be smooth and you'll not have issues. So let's talk about some of the challenges, right? One is the huge variety and huge number of devices. So if you see, we are talking about a huge range of devices, starting from sensors to drones to wind mill sensors, right? Which are deployed in oceans and deserts. So it's very important that the IoT system will take care of this variety of devices and also the scale of devices. We are talking about millions of devices connected per smart city, right? And you can imagine the scale nationally, right? And next is the huge data which is getting collected and the variety of data which is there, right? So we are talking about petabytes of data which is getting collected. Say if it's a city, it's a region, right? So petabytes of data which is getting collected per region, and that will go to exabytes when you're talking about countries and continents, right? So it's very important that you deal with this variety of data and also take care of this data, the huge volumes of data, which is not at all simple. Next is the super quick responses. So here there are various devices like drones or cutting machines or so on, right? Which require your responses to be in milliseconds, or there will be a huge monetary loss as well. Your drone goes and crashes, or your cutting systems actually cut more than what is required, right? So it's very important that IoT system will take care of this as well. And next is the bad connectivity. So with so huge deployments, right? So for example, windmill farms or solar farms, we are talking about areas of hundreds or thousands of acres, right? And it's practical that it has a very bad connectivity because of its vast nature of deployment. And it's very important for the IoT system to take care of these bad connectivity and also has that reliability in these situations. And moving on, next is the acting at real time. So it's not only important that you collect all this data from the sensors and devices, it's also very important that you actually start acting on it on the real-time events. So I'm talking about even connected cars or emergency response vehicles, right? So they need to immediately act on the events which are there on the field. Like say there's a wildfire, right? And the sensor actually send the information on the wildfire, and the fire engines need to respond very quickly to that as fast as possible. So with these challenges in IoT, it's very important that your IoT system which you pick actually takes care of all this. So if you see, actually Akira IoT is one of the IoT solution which Sentience gives. And this has, this takes care of majority of the problems which we are talking now, right? So we are talking about bidirectional communication establishment to the devices. Like say, for example, we have various kinds of devices, and you need to not only send data to the devices, also you need to collect this data back from the devices, right? So it's very important that it takes care of the variety of devices and act on the data which is collected, like process the data, validate the data, and export the data to various systems, right? So it's not only generating reports and dashboards on the data which is collected from these sensors. It's also important that you have machine learning algorithms on top of it, so that as we saw in earlier talks, you can actually detect various anomalies, or you can detect the various patterns, what is happening on the ground, right? And not only this, it's very important that your other systems like CRM systems, the systems which actually measure your effectiveness of energy and others need to be taken care, and the integration should be really smooth, right? And we're talking about millions of devices. So it's very important that the system which you're picking up can actually support millions or billions of devices which are being connected. And moving on, so this is a typical high-level architecture of a IoT system, right? Like how exactly it looks like. So if you see on the southbound, you have all your devices, edge systems, or it can be your consumer devices as well, right? Because IoT doesn't end at sensors and machines. It's also your mobile phones or tablets, cars, and so on, right? So all these devices form the southbound layer, and they actually communicate to your system using the load balancers, right? And in between are the core of the system, where you have various services which take care of different aspects of the system. I'll come there. Next is the northbound aspect of the system, where you have the consumers of this data. So what are we actually doing with the data which we collected, right? So one is, it can be turned into reports and dashboards. It can be consumed by machine learning algorithms and detect anomalies and other aspects of it. Or it can be actually exported to various systems as well. And if you see on the right-hand side, we have various analytics pipelines and monitoring pipelines. And this is where all the churning of the data happens, right? Validation, extracting, transforming, and visualization. So in the middle is the core of the system, which takes care of connections, message delivery, security, which is a very important aspect, and also complex event processing, right? So together with all this is the package an IoT system will come in, right? And yeah. And moving on, as we are talking, scale is very important aspect of any IoT system, whatever you choose, right? So these are some numbers which depict the scale of a system and how vast it can be, right? We are talking about billions of device connections, and we are talking about hundreds of 100K RPS per second, and all with a latency of 10 milliseconds, right? So these are the things which are really important for important KPIs of any system, which needs to be taken care of. So yeah, so with this, I actually end the talk. I think we can, hope you guys enjoyed the brief talk, and yeah, we are open to questions.
Thank you, sir. Thank you for discussing with us how IoT connects to sustainability and introducing us to the various aspects of Akiro IoT. Participants who may have any questions or comments, please feel free to put in the Q&A box.
Thank you. I think, we don't have much questions.
Thank you,
Thanks
sir.
for the opportunity. Yeah.
Thank you very much, sir. Please do check in the Q&A box because sometimes participants put in the question a little later also.
Sure.
Thank you once again. Now we have Dr. Konstantinos Nikolopoulos, who is a professor in business, information systems and analytics at Durham University Business School. Dr. Nikolopoulos studied electrical and computer engineering at the National Technical University of Athens in his native Greece. He further completed the International Teachers Program at Kellogg School of Management at Northwestern University. His research interests are forecasting, analytics, information systems, and operations. Dr. Nikolopoulos was professor of business analytics, decision sciences at Bagnor University for a full decade and completed 3 tenures as the College Director of Research, Associate Dean for Research and Impact for the College of Business, Law, Education, and Social Sciences, in charge of the Ref 2014 submission for the Business and Law School. Before that, he was lecturer and senior lecturer in decision sciences at the University of Manchester, a senior research associate at Lancaster University, and the CTO of the Forecasting and Strategy Unit in the Electrical and Computer Engineering Department of the National Technical University of Athens. He has also held fixed-term teaching and academic appointments in the Indian School of Business, Korea University, University of Peloponnese, Hellenic International University, RWTH Aachen, and more recently in Kedge Business School. Professor Nikolopoulos is an associate editor of Oxford IMA Journal of Management Mathematics and the Supply Chain Forum, an international journal. He is also the section editor-in-chief for the Forecasting in Economics and Management section in the MDPI Open Access Journal Forecasting. We are extremely privileged to have you with us today, Professor, and a warm welcome to you to the program. Let me hand over the session to you.
Thank you very much. Can you hear me well?
Yes, sir.
Okay, let me try to share my screen. Initially, I thought that was at 5 a.m. in the morning. So I was trying to convert the time zone, but then I realized it's fine. So it's good that it's in the evening here in UK. Yeah. Okay, share screen. Okay. Okay, can you see the slide?
Yes, sir, we can.
Okay, thank you very much. Okay, so when I was invited to present in this very timely and very important conference, which I gladly accepted, that came under my remit as a member of the executive board of the Institute for Hazard Risk and Resilience in the University of Durham, that were closely affiliated with the research you are doing there in India as well. At the moment, I was actually still working very much into 2 projects that are dealing very much with risk, resilience, and especially what I do, which is forecasting and how we can use forecast in order to help us ameliorate such conditions and such forthcoming events. So I wanted to spend at least a half an hour that you entitled me here today to discuss a little bit about my discipline and what we can do, what can be forecasted, what not, and what extent we can use that for disaster response. And the talk is coming with a slightly provocative title, but it's is something that is very well thought and has been presented over the years in various fora. So it has been presented in the Institute for Work Foundation. It has been presented in Cardiff, in Lancaster, in Birmingham. It's going to be the keynote as well in another conference that's running in Durham next week, in various centers for decision sciences, and here today. And the idea is that when we are dealing with data to try and create some forecast about the very difficult events to forecast, like black and gray swans, if we assume that at least the gray ones are forecastable, we tend to forget what kind of tools we have in our hands. So the idea is that Kevin, the two last letters IN, they link to intermittent demand, which is what I really want to talk about today. There is a related article in the European Journal of Operational Research that is dealing with that in detail, a single author article of mine. But here I elaborate more and I show clearly some immediate applications. And part of that stuff has been used actually during the pandemic as well in order to create some forecasts and help take some informed decisions. Now, this is partially funded at the moment from the projects that I'm running, and they're at various stages. The one is running actually in Southeast India. It's called SASI, and it's funded under the Global Challenges Research Fund and the Medical Research Council in UK, and is about to finish this year. But given the coronavirus situation, we are looking for an extension since we didn't manage to get as much data as we wanted from India. The other, which is also partially funding this research, is called RAMONS, and it's an EU project. A project that aims for monitoring radioactivity into the deep sea and to what extent that can alter and affect fisheries, create immediate risk issues for nearby cities or nearby ships, or and it has to do both with natural activity as volcanoes and also